Hello. Good. Hello. 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 बरोबर. हेलो. वन यूट्यूब में लेता है. हेलो. 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 वही. हैंड माइक से बोला था. कलर माइक भी चालू है. हैंड माइक कितने रखे हैं? हैंड माइक तीन है सर. एक कॉलर माइक है. नीचे है ना. नीचे तो है. अभी फिलहाल तो नीचे नहीं है. तो क्वेश्चन आंसर होगा ना. हाँ, क्वेश्चन आंसर का टाइम हम सर्कुलेट करेंगे यार. नहीं नहीं, तो स्पीकर ही बोलेंगे ना, अलग से दो बोल रहे हैं. नहीं नहीं, यहाँ तो इनके पास ही रहेगा, दो अलग से बोल रहे हैं. हाँ, दो अलग से. ये तो इनके लिए. हाँ, इनके लिए नीचे नीचे तीन ही बोला रहेगा फिर. पीछे भी उनको कल बात भी हो गया. तीन ही माइक बोला है. तो एक हम नीचे दे देंगे. नहीं, नीचे कैसा होगा? तो डिग्नेटरीज है. आ रहा है उसमें. देखते हम अरेंज कर देंगे. तो हैंड माइक ये सर बोले. ठीक है, मैं बोलता हूँ सर. अरेंज कर लेते हैं तब तक चाहिए देने के लिए. और दूसरा सेशन का टाइम होगा. हाँ, मैं दो बोल देता हूँ. ठीक है. ठीक है. नीचे बैठ के मीन्स आपके से पीपीटी कौन शेयर कर दिए? सब पीपीटी पीपीटी भी वगैरह सर. पीपीटी कौन शेयर कर दिया? हाँ, पीपीटी कैसे किस तरह जो नहीं, पीपीटी तो अभी है नहीं. किसी का भी नहीं. तब जस्ट टॉप होगा ऐसा. हाँ, जस्ट ऑनलाइन. ऑनलाइन चलेगा. ऑनलाइन चलेगा. पीपीटी है नहीं. पीपीटी जस्ट टॉप ऐसे चलता है. पीपीटी नहीं, पीपीटी पक्का पीपीटी.
Good morning, ladies and gentlemen. May I request you all to take your seats? We will begin shortly. Good morning, ladies and gentlemen. Thank you all for joining us today for the Research Scholars Summit on Employment, Entrepreneurship, and Startup Opportunities, with the theme Translating Innovative Research into Employment, Entrepreneurship, and Startup. To begin today's proceedings, join me in welcoming our guests on the dais, Mr. Bharat Agarwal, Chairman CII Western Region Task Force on Education, and President Vishwakarma University. Professor U. Kamachi Mudali, Vice Chancellor, Homi Baba National Institute. Mr. Martin Mascarenhas, Director, Beam Technology Development Group, Baba Atomic Research Center and Chairman, Atal Incubation Center, BARC Anushakti Foundation. Ms. Aarti Kochivatla, Vice Chairperson, CII Maharashtra State Council, and Managing Director and Lead Government Advisory and Strategic Partnerships, Accenture India. And Dr. P. Anbalwan, IAS, Principal Secretary, Industries, Investments and Service Departments, Government of Maharashtra. Dr. Alpa Antani, Regional Director, Confederation of Indian Industry. Welcome, ladies and gentlemen. Thank you all for joining us. May I request Mr. Bharat Agarwal to please deliver the welcome address.
Dr. P. Anbalwan, IAS Principal Secretary, Industry Investment and Services Department, Government of Maharashtra. Mr. Martin Mascarenhas, Director of Beam Technology Development, BRC and Chairman, Water Incubation Center, BRC and Shakti Foundation. Professor U. Kamachi Mudali, Vice Chancellor of the Homi Baba National Institute. Ms. Aarti Kochivatla, Vice Chairperson, CII Maharashtra State Council, and Managing and Director for the Advisory and Strategic Partnerships at Accenture. Dr. Alpa Antani, CII Western Region. Good morning to all the dignitaries over here, respected academicians, industry leaders, researchers, students. It's okay? Yeah. Industry students and invited guests. It gives me great pleasure to welcome you all to the Research Scholars Summit on employment, entrepreneurship, and startup opportunities on the theme Translating Research into Employment, Entrepreneurship, and Startups here in Mumbai. At the outset, I extend a very warm welcome to all our esteemed speakers, panelists, moderators, representatives from the industry and academia, members of CII and HBNI, and most importantly, the bright research scholars who are at the heart of today's summit. Today's gathering is both timely and significant. India stands at a unique moment in its journey. With a wide startup ecosystem, strong policy support for innovation, expanding industrial capabilities, and a young talent pool, the opportunities for research scholars have never been greater. However, alongside these massive opportunities comes a stark reality check. As the chair of CII Western Region Education Task Force, I think we must have a candor to look at where we stand today. India has seen a monumental boom in intellectual property. We recently crossed a milestone of over 1.1 lakh patent filings in one single year, with education institutions driving 30 to 40% of this growth. But we must also ask this question: where is this research going? The uncomfortable truth is that the vast majority of our brilliant academic research remains confined to paper. It lives in beautiful bounded theses on library shelves or as publication credits on a resume. According to what I read from ChatGPT of the Indian Patent Office, a total of less than 7% of the actual patents have been commercialized. The rest sit dormant. We have mastered the art of filing, but we have not yet started deploying. If we look globally, the story is a bit different. The most disruptive, valuable, and breakthrough businesses in modern history do not start in corporate boardrooms or via some copycat model, but they were born out of university labs, forged by research scholars just like the ones in this room today. A few examples we all know. Google began as a Stanford University PhD research. Genetic, a pioneering biotechnology industry, was founded of a recombinant DNA research by a biochemistry professor. Dropbox, born out of MIT when its founders were frustrated by data storage. And even in our backyard, we have IdeaForge, which manufactured India's leading drones emerging from the labs of IIT Bombay. These founders did not just write papers, they built empires out of their hypothesis. They understood that the patent is not a destination, it is merely a starting line. This summit has been designed precisely to bridge this exact gap, to transform our scholars from creators of documents to architects of industries. Throughout the day, we will engage in rich discussions across diverse domains, including chemical sciences, engineering, medical and life sciences, physics, and mathematics. These sessions will provide insights into emerging industry trends, evolving workforce requirements, translational research pathways, entrepreneurial opportunities, and future-ready skills. We are privileged to have with us an exceptional lineup of leaders from industry, government, academia, healthcare, technology, and innovation ecosystems. Their experiences and perspectives will undoubtedly inspire young researchers to think beyond conventional career pathways and explore avenues where research can lead to innovation, enterprise creation, and impactful solutions for our society. I would especially like to forge the importance of collaboration. The future belongs to ecosystems where academia, industry, government, and startups work together seamlessly. To all participating scholars, I challenge you today. Let your research breathe, not in a PDF. I run an academic organization back in Pune. We are all in the race to file patents. We are in the race to publish papers. Most of our accreditations and patents depend on that. It is time that we think beyond only to this part of the research process. Thank you so much.
May I invite Professor Kamachi Madali to deliver the theme address, please?
Distinguished Chief Guest, Dr. P. Anbalagam, Principal Secretary, Industry Investment and Services Department of Government of Maharashtra, and other distinguished colleagues on the dais, Mr. Bharat Agrawal, Chairman of CII Western Region Task Force on Education and President of Vishwakarma University, Mr. Martin Markel Das, Director Green Technology Development, and the Chairman of Fatal Incubation Center, BRC Anusakti Foundation. Ms. Aarti, Vice Chairperson, CEO Maharashtra State Council 26-27, and also the Managing Director of Accenture India. Welcome to the moderators. The distinguished moderators. I begin with Professor J.P. Mittal, the youngest person to the audience. He is 86 plus, and Padma Professor J.P. Mittal is our distinguished professor emeritus, HBNI. He has 7 decades of experience in chemical sciences and former director of the chemistry group, BRC. We have another Padma awardee, Dr. R.B. Founding Director of the National Institute, another young man, 76 plus, member of the Energy Commission, distinguished professor emeritus of HBNI, and former principal advisor of BE. Dr. Sudhir Gupta, Director, Data Management Center, HBNI Mumbai. Professor S.M. Yusuf, Bhuvan Sri, is here as Director of the University of Mumbai Center for Excellence in Basic Sciences, and is also former Director of Physics. I am also very proud to introduce my Professor K. Prai, and former Director of Chemistry Group, and Registrar Harinarayan Sahu. And I am extremely happy also that we have session panelists who are participating in chemical sciences, engineering, medical health and life sciences, physics and mathematics, and final validation session on entrepreneurship and skilling. A warm welcome to all the industry leaders, CII leaders, respected representatives from the government of Maharashtra, faculty members, scientists, research scholars, students, and ladies and gentlemen. I'm extremely delighted as the Vice Chancellor of Home Institute to welcome all of you for this Research Scholars first ever summit on employment, entrepreneurship, and startup opportunities. This is widely organized by the Institute and the Confidence of International Industry in association with the government of Maharashtra and the Atal Research Center Bhupas Shakti Foundation. And we have an excellent theme, translating innovative research into employment, entrepreneurship, and startups. Today's summit is a very clear mission to create a meaningful platform and continue this effort in the future also, where research scholars, industry leaders, innovators, entrepreneurs, policymakers, and academicians can come together and collectively deliberate about the future of science-driven careers, innovation ecosystems, entrepreneurship pathways, and transformational research opportunities. As I find large number of attendees from other than the family, the foundation of the scientific ecosystem, which has basic R&D to begin with, then translating the research into applied research, basic research into applied research, then making products in the industry and services and products in companies, and also giving service organizations and academic and scientific institutions. The foundation for this was Bharat Ratna Dr. Baba, who exceeded far beyond the establishment of atomic energy in the country. Dr. Baba is a scientific fluent in India by advanced research, indigenous technologies, innovation and social development. In 1948, the Atomic Energy Commission was established more than 75 years ago under his leadership, followed by the creation of Atomic Energy Establishment Bombay, which now begins the Baba Atomic Research Center, the world's multidisciplinary research organization. BRC Bach called is the mother of organizations, and several other industrial R&D and academic institutions came out of BRC, starting with IGCAR, Indira Gandhi Center for Atomic Research at Kalpakam, Raja Ramana Center for Advanced Research, Advanced Technology at Indore, Cyclone Center at Calcutta, heavy water there at 7 different sites, industrial units in the country, rare materials plant at Mysore, Board of Research in Isotope Technology, Nuclear Fuel Complex, Institute for Plasma Research, Tata Motors Center, centers which are affiliated to which are all dedicated to nuclear science, accelerated technology, healthcare, research, computer science, strategic technologies, and basic sciences. We represent one of the fights to multidisciplinary scientific ecosystem in the world to integrating advanced research, technology development, mission, and societal applications across various scientific domains. In this, in the larger vision of this, strengthening research, academic excellence, and high quality research development, we found the issue a city under the Department of Atomic Energy in 2005 under Section 3 of the EDC Act. The fundamental objective of HBNI is to nurture capabilities in nuclear science and engineering, simultaneously promoting advanced research in physical sciences, chemical sciences, mathematical sciences, engineering sciences, life sciences, medical and health sciences, and interdisciplinary domains. HBNI is a unique distributed structure with 4 located all over the country was envisioned to not only as a big institution, but as an academic framework that could integrate the exceptional research infrastructure and scientific expertise available across these institutions into System for Advanced Education and Research. Thanks to the visionary leadership of Dr. Ravi Kakotkar, former Secretary, and Dr. R.V. Govind, Commission and Founder Director of HBNI. Over the last 2 decades, HBNI is evolved into one of the country's leading research-oriented academic institution. I'm very proud to tell you that HBNI has more than 4,140 active students. None of them are undergraduate degree, they are master's degree, pursuing PhD, MTech, MC, and specialty and super specialty medical degree like MD and MCH and other advanced academic programs with highly qualified and recognized 1,230 faculties. We have a distinguished alumni base of 9,900 scholars. I'm very proud to be the Vice Chancellor that national recognition for the academic and research excellence. HBNI was accredited with a A+ grade with a score of 3.4 in 2022. But I'm very proud to tell you the National Institutional Ranking of the Ministry of Education 2025. We are placed number 7th rank in the research institution category all over the country, 12th rank among all the universities all over the country, and 20th overall category among more than 4,140 institutions in the country. These recognitions reflect the strength of the research ecosystem created collectively by the institutions of the Department of Atomic Energy. Alongside the academic and research excellence, HBNI also has taken focused initiatives towards career facilitation, entrepreneurship, and industrial development. As research ecosystem evolves, it is increasingly important that our scholars are exposed to not only academic excellence and careers, but also to opportunities in industry, startup, technology translation, innovation management, policy and translation sciences. Accordingly, HBNI has been actively strengthening its interaction with industry bodies, innovation ecosystems, and innovation platforms through collaborations and agreements with several organizations. In fact, we have signed with several academic and industry organizations, including centers of our own being. One such important collaboration that we have signed is with the Conference of Indian University of 2024, and we strongly felt that this collaboration should translate into direct engagement opportunity for students and scholars. That is where the NCTS pursued organizing this interactive summit, where students can directly interact with the university leaders, innovators, and policymakers. At this juncture, I am very proud to tell that both CII and I'm extremely happy that we have received a great support from Dr. Balaban, the principal secretary of Government of Maharashtra. When we jointly enthusiastic and came forward to support the Government of Maharashtra, he supported the participation and display activities of 3 of the units of the university department, as well as he requested the Maharashtra State Higher and Technical Education Department to encourage the scholars and faculties to participate in the program. I am very happy that this summit with your blessings was successfully brought to participants not only from HBNI, but also from other universities, industries, startups, and research organizations from Mumbai and all over Maharashtra. I'm very proud to say that 50 students from all over Mumbai and Maharashtra and other places also have participated too. This summit is carefully designed through 5 thematic sessions: clinical science, engineering, medical, health and life science, physics and mathematics, and entrepreneurship and skilling. Each session addresses highly relevant questions of emerging career pathways, industry expectations, transformation research opportunities, startup ecosystems, innovation, future workforce requirements. I am very proud to have an exceptionally distinguished group of panelists and moderators numbering 28. They are going to representing leading universities, healthcare institutions, technology organizations, startup ecosystems, academia and government sectors. I want to acknowledge their presence here in advance for their valuable contributions for being moderators and business experts. I am confident that the collective expertise available for the sessions will provide valuable insights and inspiration to our research scholars and participants. I would especially urge all the participating 270 students and scholars and other communities to actually engage in the discussion, interaction, and with the experts, ask questions, and fully utilize this opportunity. Platforms like this often should become turning points in shaping future careers, collaborations, and enterprise journeys. The Maharashtra is actively participating in this summit. I sincerely thank the government of Maharashtra for their engagement, support, and cooperation, including permission for the use of government logo for the event. This reflects the importance of collaborative efforts between academia, industry, and government of Maharashtra in strengthening the international growth. To our partners, CII, Government of Maharashtra and the AAC BRC Amsakri Foundation, I would like to say that this is one join our hands, but HBNI feels that we should have a much larger vision for creating platforms for sustained industrial academic interactions, innovation partnership, entrepreneurship support, and translation research for scholars. I am also happy to invite our innovation partners, innovation ecosystem, and collaborating institutions to actively organize and expand such activities in the future. I must acknowledge the enthusiastic participation of scholars, students, young faculties, innovators, startups, and mentors. And I am sure that by participants can take away valuable insights, perspectives, and inspiring interactions from the summit. With these notes, I once again welcome all dignitaries, speakers, moderators, participants, students to this important summit and this celebrations a great success. Thank you very much.
Thank you, sir. May I invite Mr. Martin Mascarelis to deliver the special address, please?
Distinguished guest on the dais as well as off the dais, faculty members, researchers, research scholars, innovators, industry representatives, ladies and gentlemen. A very good morning to all of you, and welcome to the Atomic Research Center. It's a privilege to address this distinguished gathering at the Research Scholars Summit on Employment, Entrepreneurship, and Startup Opportunities, jointly organized by HBNI and CII. At the outset, I would sincerely appreciate the efforts of CII and HBNI in creating this important platform where academia, industry, researchers, innovators can come together. Such interactions are essential because innovation today cannot happen in silos. The future belongs to collaborative ecosystems. For decades, scientific institutes generated world-class research, but many promising technologies remain confined in laboratories. This is because there was an inadequate transmission ecosystem that existed. Today, the landscape is changing rapidly. As Bharat sir said, from CII said, but only there is not a great group of young researchers who are satisfied with publishing papers, but they also want to build products and solve national challenges and create global competitive enterprises. So the problem lies in information and knowledge. Okay, so can I just diverse from your from I know the existence of CBRC and Shakti Foundation. How many of y'all? See, this is the problem. Okay, so this is where I mean, this is where the problem lies. This is where the AIC and Shakti Foundation, a Section 8 company established under other incubation mission, connect the two. That is the researchers as well as BRC. We are the transition out of BRC and in the bridge, the gap between research and commercialization, and market adoption, between scientific talent and entrepreneurial opportunities. We work towards enabling technology translation and commercialization, as well as incubation of tech startups. Presently, we have around Glossy technologies for translation to industry, and on an average, transfer of 100 technologies everyone contributing to societal and industry growth. Incubation, which is, I think, the topic of today, incubation startups. Okay. So incubation means two ways of incubation that AIC follows, AIC Avashakti follows. See, one is we have a growing basket of technologies which we have developed for use in movie, but having a potential of spin-off applications. So this we have distributed in our website. Request our industry partners, our young research scholars to look at this list and see if they have potential for commercialization. See, one of the technology, okay, this is, I mean, perhaps a really good example. So, DIC has developed a plasma technology. What is this plasma technology developed by DIC for a particular incineration activity, I mean, activist incineration activity? That was for the application. But there is a company, there is a startup that thought that this technology could be used for something different. Now, what is the difference? What is the differentiator? He said that I use this plasma, this high temperature source, hydrogen. Okay, so that I could directly convert biogas into hydrogen. Possibly, he said that he was thinking that transporting hydrogen in large quantities would be unsafe. So we can transport methane and at the source of usage, we convert the methane into hydrogen. So I'm just giving an example for the audience to understand how some technology and spin-off could be applied. The other word which we follow is have cohorts. Okay, in these cohorts, young researchers, startups, we give them an opportunity to present value, to pitch their ideas. Okay, and we put these ideas up if it's a deep tech idea. Okay, because we have mentors and advisors who can mentorship in deep tech. Now, let's say, I will give you an example here also. Please don't limit yourself and say, I will AIC will not accept. Suppose if you are making, say, a cosmetic product, do you think AIC should invest the time of it and mentorship into it? How many of you agree? How many of you won't agree? I mean, agree. Should not invest because AIC Shakti. Foundation that invests in how much should okay, I'll see a few hands. Okay, but suppose now I say that say this cosmetic product, the foundation requires a functionalization by using technology. Now, should we agree to this incubation? To say that we should agree. The same way with other both sides. Wonderful. So you see, there is no a binary decision. There are a lot of layers of decisions. I mean, so it's so please come up with your ideas. Yeah, I see whether we can incubate it. See, if the technology requires, say, technical help, this can be provided by a large number of resource of members that we have. 5,000 scientists and engineers in BRC. Working with biogas field, as I said, we work in the gamut of fields, 7 verticals, and we work in all the verticals, okay? Now, if suppose if you feel that you have developed a product, but you require to validate the product, you are willing to open up BRC labs for you to validate the products. Say if you require funding, okay, seed funding we could possibly get it from AIMS or something like that. But suppose we require more fundings, we could help you to get funding. We could compete with venture capitalists. Okay, so these are the kind of helps that we can assist you in your incubation. Hence, what we've done, we've created an ecosystem researchers innovators to take their ideas from laboratory to market. And this information, so Bhavit's over right now. Shelf. Okay, so this is my pitch to you is please have a stall out, please come, interact with us, see whether your ideas are worth incubating. I would especially urge young researchers and scholars present today to think beyond the conventional career paths, where research has potential not only to generate knowledge, but also create enterprise, industry, employment, and national impact. India is not job seekers, but also job creators. I also invite industries, startups present here to actively engage with the ecosystem that we have built. As a strong collaboration between research institutes and industry is essential for accelerating technological adoption and building competitive indigenous products. Friends, today India stands at the threshold of a transformative era. The vision of the Viksit Bharat 2047 calls upon us to create not only economic growth, but technological sovereignty is very, very important. You realize what technological sovereignty means? See, so many demands are there. During this war, innovation, leadership, sustainable societal impact. I will invite our research scholars, young innovators to play a role in this journey. With these words, I once again thank HBNI, CII for organizing this important summit and wish this program great success. Thank you very much.
Thank you, sir. May I invite Ms. Aarti Kochi Butler to come deliver the special address, please?
Dr. Anbalgan, Professor U. Kamachi Mudali, Mr. Bharat Agarwal, Mr. Bobby Kuriakos, Dr. Alpan Tani. Good morning, distinguished guests, industry leaders, members of academia, research scholars, students, ladies and gentlemen. It's an honor to address you at the Research Scholars Summit on Employment, Entrepreneurship, and Startup Opportunities, jointly organized by Confederation of Indian Industries and Homi Bhabha National Institute. At the outset, I would like to congratulate the organizers for conceptualizing this important and timely initiative focused on translating innovative research into employment, entrepreneurship, and startups. This is extremely relevant in today's rapidly evolving global economy, where research and innovation are becoming integral to economic growth, industrial transformation, and societal progress. We're witnessing a significant shift in the nature of work and careers across the world. Emerging technologies such as artificial intelligence, quantum computing, cybersecurity, and data sciences are redefining industries, for example, advanced manufacturing, biotechnology, and creating absolutely entirely new opportunities. In this changing environment, the expectations from the workforce are also evolving. Today, organizations are looking beyond academic qualifications. They are seeking individuals with process analytical thinking, adaptability, interdisciplinary understanding, innovation capability, and the ability to solve real-world problems. Research scholars are uniquely positioned in this landscape. The journey of doctoral research itself builds resilience, problem-solving ability, scientific temperament, and deep domain expertise. These are highly valuable capabilities, not only in academia, but also across industry, governments, startups, and the innovation ecosystem. However, there is also a growing need to bridge the gap between research excellence and real-world application. Research should not remain confined to labs, journals, or publications alone. The true value of innovation lies in its ability to create impact, whether through technology development, industrial applications, policy solutions, sustainability initiatives, or entrepreneurial ventures. Today, industry is actively looking for stronger engagement with academia and research institutes. Collaboration between researchers, industry leaders, startups, and policymakers is essential to accelerate innovation and create scalable solutions for national and global challenges. As someone working closely with government advisory, as a government advisory and strategic partnerships lead, I believe India today stands at a very important stage in the innovation journey. Across areas such as startups, deep tech innovation, digital transformation, clean energy, healthcare technologies, and research-driven enterprises, creating new opportunities for innovation, collaboration, and entrepreneurship. This creates unprecedented opportunities for young researchers and scholars. I would encourage all participants here to think beyond conventional career pathways. Entrepreneurship today is not only about building businesses, it is about solving problems, creating employment, generating impact, and contributing to nation building. India needs more research-led startups, more innovators, more technology creators, and more interdisciplinary leaders who can transform ideas into scalable solutions. Sectors such as healthcare, agri-tech, climate tech, semiconductor technologies, mobility, digital infrastructure, and sustainability are opening up tremendous possibilities for innovation-driven careers and enterprises. At the same time, technical expertise alone is not sufficient. Future-ready professionals must also develop communication skills, leadership capabilities, business understanding, collaboration skills, and openness to continuous learning. The ability to work across disciplines and engage with diverse stakeholders will become increasingly important in the years ahead. I would also like to emphasize the importance of creating stronger industry-academia partnerships. Platforms such as this summit play a critical role in enabling dialogue, collaboration, mentorship, and exposure for research scholars and young professionals. Such engagements help align research with industry needs and create pathways for employment, innovation, and entrepreneurship. To all the research scholars and early career researchers present here today, I would like to say, remain curious, remain courageous, and remain open to possibilities. Your research has the potential not only to advance knowledge, but also to create impact for society and contribute to India's growth story. The future belongs to those who can transform knowledge into innovation into opportunity, and opportunity into impact. I once again congratulate CII and Homologous National Institute for organizing this important summit and bringing together such a distinguished gathering of leaders, experts, scholars, and innovators. Confident that today's discussions will lead to collaboration, opportunities, and inspiring journeys ahead of all participants. Thank you so much.
Thank you, ma'am. For our keynote address today, we invite Dr. P. IAS, Principal Secretary, Industries, Investment and Service Department, Government of Maharashtra, to please come forward. Thank you.
Namaskar.
Mr. Bharathan, Professor in Cognitive, Mr. Martin Mascarenhas, Mr. Babu Kuriakos, a scientist, scientific community, friends, brothers and sisters. In fact, one of the finest occasion probably is more like a homecoming. I was like discussing with senior colleagues. I was always fascinated with science and numbers. And it's like ninth or tenth standard. Everybody used to probably but I used to play with numbers. That's what I was sharing. I was probably the first two in the graduate school to score 100 of mathematics. We did 87. Probably most of you probably will not be there at the time. Science was always fascinated. From some school at home, even now. So astronomy, these numbers, basically science is what we think like God. That's only a science. You can have a flight, you can have like hundreds of tons of like probably carriers flying and taking like 16 hours, 18 hours of flight. Correct. Like when like Mr. Bharat was mentioning about that is like a conversion rate. If you look up probably if you also do a chat GPT or anything, just work it out. Probably functional patterns, probably close to 2.5 lakh, but out of the 1.4 is actual commercialization. And if you say someone the farm 27 or 22, they declare that it's commercialized, it's close to 6.5. When you look at like probably Coca spends close to 5% of its entire budget on like I would say R&D, and USA is 3.4% of its budget on R&D. Almost 40 to 60% is actual conversion rate. So what exactly is this? Is not a research which like it should not be like really on paper. It has to be translated into probably opportunities, employments, and probably ultimately into product, not just a prototype. So if you look at technology, the value of probably, and also you all know the value of both. So most of them are like at the stage of 4 or 5th. So how to use the gap? Probably federal government and also the state governments probably woke up to the occasion. If you look at current budget and how India is looking at, it's proactively process to steadily transition from a factor-driven economy to innovation-driven economy. When we started, when businesses started probably in Europe, the chimney, the stack we call stack, having some 4 years with pollution control board, having qualified a veterinary and also an engineer in civil and environmental engineering, the black smoke was seen as a signs of prosperity. That was a thought process. So bakery was the first product. Basically, bakery item is like a form of industrializations. Anywhere in the world you start, any town, there's nothing like bakery will be there. Now that stacks you have, but if you see smoke, it's not a prosperity. You see it like pollution. So that's what the thought process will come up. Currently, economic forum signed close to this what 30 lakh crore, which translates to 360 odd USD. In that, most of them probably when you look at like tech related, from polysilicon to wafer to you have cells and modules. Look at probably chip, silicon or fab. Even like lithium, I would say like beneficiation and also battery energy storage system. Every company asks for a technology transfer. And what is the amount? Even if some say that investment is like 1 billion, probably 10,000 crore, the technology transfer amount is like 30% of it. So that is what the other probably the Western world, probably Taiwan, even China, even Korea, they're making on us, even USA, UK. So ultimately, when we look at the numbers, we should be proactive. And government of India also established, we also have a National Research Foundation, which has an outlay of 50,000 crore, which will strengthen the research capacity and probably will promote industry academia collaboration in much like better way in a meaningful way in a prominent way. Look at state, Maharashtra, so very strong research talent and innovation base. Having been a country just like probably Singapore, Thailand, South Africa. The economy of 660 billion USD, but probably one of the very biggest sub-sovereign economy of the country, which accounts for close to 1/6 of its GDP and probably 1/5 of its exports and probably I would say 30% of its entire FDI, cumulatively for past 2.5 decades. With Legacy Bharat mission, probably when Bharat India reaches 30 billion USD, Maharashtra should have a line share, probably 5 trillion. That is what the number will come to 2047. Just period. Just probably what like 60, what was what another 20 years, just 20 years. But the 660 into 5 trillion. So business as usual. And I would say probably the way which we look science has to phenomenon has to be changed. That's what the Viksit Bharat and of course Viksit Maharashtra is a hardcore 4 pillars. I would say one is a growth driven, has to be sustainable. That's why we said the black chimney versus a chimney which probably may not have any smoke, probably clean smoke. Inclusive, not just one section of society is getting benefit of, probably Gachini to Nandurbar to probably southern part of, I would say Kanyakumari to probably Kashmir and probably from Arunachal to Gujarat. So that's why the inclusivity sections of the society has to be obviously governance. So that's why the Prime Minister mentioned that unity of governance, not the government. So with these 4 tips, we actually divided into 106 initiatives, which are predominantly 16 industries and investment in services, because which is what this department is going to create money, create value, create economy. So probably in the next 5 to 7 years, the state is going to create fully autonomous industrial townships, which will also function as a municipal body. And also, the government is going to have Invest Maharashtra, so going to be a 6 or 8 company. So, investment agency, which will be a single point to promote investment. And secondly, we look at sectors, we have 24 sectors out of the 12 are sectors, starting from probably capital goods, auto, all that. Now we have tech, emerging sectors, emerging technology, there are all 12. So 24. So R&D and focus. That's what the state level. Basically, federal government also has. And very sustainable manufacturing organizations. Energy transition is one thing that we should look at on a much more bigger way. If you look at state which has an installed capacity of close to 53 gigawatt, having spent 2.5 years as a chairman and director of power generation company, which is the single largest state utility in the entire country, operating close to around 7,000 megawatt. Facilitating energy transition with this crisis, so self-sufficiency. So we need to create a lot of like IPs, patents, I would say the patent which can be converted into commercial output and product. So this particular initiative is trying to create as a 600 billion fintech and finance services, not just like a product, probably manufacturing, also tech we need to be doing. And establish as a 50 hub for media tech AGC, animation, visual graphics, comics, XR, extended reality, augmented reality, all that. So when we operating thermal power plant, so we used to use that AR glasses. So someone probably sitting in probably Frankfurt or Stuttgart will try to explain how to like do a repairing in a world sitting at Corabi and copper around. Such research and such products we need to bring it from like our country and our state. And we invest largest deep tech ecosystem with at least 50,000 patients. So if you look at what are the states which are probably Tamil Nadu, probably the number 1, then Karnataka, then obviously we are at number 12, Maharashtra. So we need to put our socks and probably we should do. Organizations are there, we expect more from that. And the state is also doing emerging districts. If you look at 36 districts, out of that 9 districts contribute to 72% of 50 lakh crore. So out of 660, And if you look at other 12 districts, which are where per capita income is even less than the national per capita, that Maharashtra will have that sort of like dichotomies. And another like this is where the per capita income is more than the state average. So we have introduced a concept called emerging districts. They are not like rural like untouchable districts. They are not rural industry districts. We are building a disturbed incentive system to industry to this EW problem untouched locations. Like Nandurbar has attracted 5,000 plus crore. First time attracted Nandurbar helicopter oxygen facility for air ambulances, firefighting, and probably firefighting and rescue. And India battery energy storage system, like manufacture. So observability will take industry to that. So research also should take like also should be ultimately able to bring the common and the lowest, the lowest city, the lowest strata of the society also should benefit. Startup capital of the country, we have close to 30,000 plus startups. If you look at BPT, it's close to 8 lakh. If you look at functional, probably 60 to 70% are functional. Out of that, close to 30% is others. If you look at Maharashtra, we churn out 7 lakh technical STEM. You have science, technology, engineering, mathematics. Without that and finance, without that, nothing moves. So we churn out 7 lakh graduates every year. So where we will accommodate? We need to create like employment. We need to create that value. Otherwise, probably after 10 years, you'll end up with like probably 1 group people just searching for that, probably depending on some apprentice thing. Like that's called like subsistence living. So we don't want to do subsistence living. So to build that status, very proud to be, I would say, elaborate and brought out almost host of 20 odd such policies. Each of the small sector is given a different value dispensation. The first state to create like a bamboo industrial policies is also supported by ADB. While like bamboo is traditionally taken as like a kilona, toys, probably mattress. So we are trying to bring a fiber from bamboo. We are trying to bring methanol almost opposed to SAF. So SAF is like a 70%, it's all being imported. So we should be looking at that. So we have policies such as like Maharashtra Industries Investment Services Policy, which aims to attract 8 to 5 to 7 years. Out of the 5 is from manufacturing, 350 is from services. And we also have policies like working property centers. You have surpassed Hyderabad and Chennai in this year, leasing out 30 lakh square feet only for GCC. So we are looking at the capital of the country. 30 lakh square feet in 9 months. The policy, but only 10% will come for incentives. Rest of them will roll out that thing. And also, we should about comments and of course, policy. State is hosting Institute of Creative Technology, and state is also setting up I would say ABCG Park in Goregaon in 100 acres. Where you have all customers, you have virtual studios, you have all startup. You come there, shoot there, and probably and even about that. And also state has also should prepare. So state is coming up with the circular economy policy, and also coming with some electronics, perhaps semiconductor, pharma, biomanufacturing, and of course big tech. Big tech is on like it's a bit big tech is done. We should look out and circular economy. The economy is like basically for ultimately whether it is stability, employment, whether it is value to economy. That's what like government of India. State is also major footwear, apparel, and accessories policy. They're probably trying to brand the luxury. Probably have the sneakers or shoes which will run. Probably will be manufactured consumer number 2 years. So that's what the state is looking at. So we expect a lot from the scientific community, which really will bring probably the 1 to 5 to the actual truth. And also, I would say like it has an integrated education system and actively strengthening the system. Of course, IIT, HBNI, of course, TFR, BRC, of course, ICT. They're going to host, of course, we have like what happens. CII is also getting institute like TMA. Such policy, which is launched by the Chief Minister's Chair in the Bangalore, it also provides a dedicated platform for research scholars government projects. So anything which benefits citizen clientele. And secondly, the Maharashtra Startup Entrepreneurship and Innovation Policy 2025, it aims to support 1.25 lakh entrepreneurs. So category to those just we out to get that. And also to recognize 50,000 startups and funding and mentorship. On that, the state also has a dedicated fund. That's what I'm saying, the value of both technology level. So to bridge the gap, so the capital when probably from an academician to researcher to become an entrepreneur. So if you see if you are like companies, most of them are like academics and researcher turned an entrepreneur. On that state is also setting up a, I would say, EM hub. It's like a Maharashtra technology hub in Colombo, close to airport, with close to 5 lakh square feet of like ready-made startup ecosystem, probably for 10 to 12 verticals, and we also do mentorship, everything. Basically, we also will be helping to do a prototype, like probably partners, also do access to capital, finance. On that, the state has also launched a scheme called Matrix. Matrix is basically Maharashtra Accelerator on Research, which has close to around almost in another like 2 years, we are close to around 1 million square feet. Almost 1 million square feet. It's almost close to 2.5 to 3 lakh square feet. Where these spaces are being rented at probably 30% of the cost. And we have a ecosystem there. So the state is tied up with probably some, I would say, developers because they launching IT policy. Super purpose of this should be 20% of the built-up for such ecosystem. So we also take benefit of that. Matrix is a scheme. We can also roll it out. So and signed with like Tata's, both like government of Maharashtra Industry Department and signed with Tata's in like process for one city near Mumbai airport. So it will create base infra. It's not a bad cell, it will create a base infra with like plug and play infra. So the city will offer a plug and play ecosystem integrating all startups and launch. And we also signed with a company called Canvas, which like technology laboratory, 6 to 7 verticals, like defense and aerospace, which will come up with 50 acres in Kalapur. And this will also have like probably 10 acres like a research, probably a training component in Mumbai. So it will try to set up probably close to 5,000. Maharashtra government also will have a 9% stakes. So this Canvas is again a based organization Maharashtrian Dr. Milan Pinto. So he signed an agreement, but this also we should be looking at that. This will be also reality. And same is also setting quantum services hub, I would say quantum valley in close to airport. So that will contribute some of our efforts to reach our goal. So I would urge all the scholars, especially your research has a tremendous potential to create jobs, skills, and solve societal challenges. So just to be researchers, but we research entrepreneurs and probably innovation leaders. So that's why I asked, what is the research topic? When I was doing some research on milk production studies for how have a cow it eats 40 liters. So how is calcium? If you look at calcium, it's close to around 3 grams per liter. So just to mobilize 3 to 40. So what do you do that? So what is the order which should feed? What will digest? What will metabolize? And what will convert into the body? So not everyone has a capacity to do that. So what will basically the fourth compartment is where is actually the stomach. That is, see, whatever you do, it will have the same problem that microbial protein. But it's a segment of stomach. You feed probably protein, most of the protein, but it can same set of like microbial similar, like I would say, format. So they talk about bypass. So you pH at that particular segment of the stomach. You bypass rumen, reticulum, and omasum. Go to abomasum, but probably duodenum, the first segment of your intestine. So to be for a also, if you give just another element, probably there's a capacity to absorb. So automatically, you can try to take resource from the bone. Probably after third or fourth month, the cow will go weaken because it mobilizes its calcium resource from the bone. Because that's the first point of like research. So you bypass, like you bypass what the city, you bypass the city. So you combine the keywords, bentonite, imported material problem, daisy, but now you go to Rajasthan. So you combine that so that this particular component is available in Tabanism, it gives a best absorption. Innovation. So absolutely, that's what like, see, it's not, science is not just a master of physics. Science is biology, ultimately. There. So that's what the sky is the limit. So what problem are you solving? And can this be scaled? Can this be scaled up or just it's going to be one up? I will purpose, I will split my research topic into 7. My guide will also say, सर्व आम्ही पण करू म्हणजे आधी म्हणजे ऑलमोस्ट 20-25 वर्षाआधी आम्ही पण हाच धंदा करून आलो बट दॅट डझंट मेक एनी सेन्स That's what I want to say. So, all the parties support strong talent, capital, and industry demand. This is obviously a societal demand. And platforms like this summit are really critical to bring together all the like-minded people to probably together greater Bharat and India's research ecosystem will going to see change. That's why we look at patent filing from like last year to this year, 30% increase from like probably 1,10,000 was gone to 1,40,000. Better Jai Maharashtra.
Thank you, sir. May I invite Mr. Bharat Agarwal to deliver the closing remarks, please?
सर इसमें माइक को टच नहीं करेंगे, डिस्टेंस मेंटेन करेंगे ना तो ऑनलाइन पार्टिसिपेंट जो है अभी नजदीक जाएंगे तो कनेक्ट होता है.
As we draw the session of the Research Scholars Summit on Employment, Entrepreneurship and Startup Opportunities to a close, it is both a privilege and a responsibility to reflect on the rich insights shared this morning. We are privileged to hear from Dr. P. Anbalagan, who reaffirmed the government's commitment to strengthen the innovation and investment ecosystem in the state. He highlighted the critical role of policy support and industry-academic collaboration in enabling Maharashtra to emerge as a leading hub for innovation-driven growth and entrepreneurship. We heard from Mr. Martin Master-Innes, who emphasized the importance of structured incubation pathways for translating science into startups. Professor U. Tamachi Mudali laid a strong thematic foundation by reminding us that innovation and research must ultimately find expression in societal and industrial impact. We also had the privilege of hearing from Ms. Aarti Tuchi Bhatia, who brought in valuable perspectives on industry partnerships and global collaboration. The message is clear. Research cannot remain confined to laboratories. It must move decisively towards employment generation, entrepreneurship, and scalable startups. Today's discussions reinforce the vision of CII Western Region Task Force on Education, under which the summit has been convened, and the broader mission of institutions like the Homi Bhabha Research Institute, National Institute, and the Bhabha Atomic Research Center in fostering translational research. I hereby acknowledge the support and collaboration of Homi Bhabha National Institute, Atal Incubation Center, BRC Anushakti Foundation, the Department of Industries, Investment and Services Government of Maharashtra, MIDC, Maitri, and Confederation of Indian Industry for their collective efforts in strengthening the academia industry government innovation ecosystem. As we move forward into the day sessions here at the DE Convention Center, I urge all participants to actively engage, challenge assumptions, and explore actionable pathways that convert research ideas into real-world adventures. I also encourage our participants to visit the stalls set up by Maitri, MIDC, and CII to explore emerging opportunities, innovation initiatives, and collaborative platforms supporting entrepreneurship and industry engagement. With that, I thank all the speakers and guests for setting the tone for the meaningful summit. And I formally conclude the inaugural session. I wish everyone a productive and inspiring day ahead. Thank you.
Thank you, ladies and gentlemen. Before we close the inaugural session, we have a small token of appreciation for you all. May I invite Professor Kamachi Mudali to please hand over the token to our esteemed guests. To Dr. P. Anbalgan, IAS, Principal Secretary, Industries, Investment and Service Department, Government of Maharashtra. Put your hands together, ladies and gentlemen. To Ms. Aarti Kuchi Butler, Vice Chairperson, CII Maharashtra State Council, and Managing Director and Lead Government Advisory and Strategic Partnerships, Accenture India. To Mr. Bharat Agarwal, Chairman, CII Western Region Task Force on Education, and President, Vishwakarma University. To Mr. Martin Mascarelis, Director, Beam Technology and Development Group, Baba Atomic Research Center and Chairman, Atal Incubation Center, BARC, Anushakti Foundation. To Dr. Alpa Antani, Regional Director, Confederation of Indian Industries. And finally, may I request Mr. Bharat Agarwal to please hand over the token of appreciation to Professor U. Kamachi Mudali, Vice Chancellor of the National Institute. Can I request you all to please step forward for a group photograph? Can we have one more with the mementos, please? The requirement will come, so the side. Thank you, ladies and for our participants seated, please note the next session on chemical sciences, careers, sustainable and advanced studies will begin. Focus on opportunities in specialty chemicals, green chemistry, pharmaceuticals, advanced materials, and nuclear-related and process industries. This session will highlight industry expectations, translational research pathways, regulatory awareness, and the growing demand of sustainability-driven innovation.
So we can announcement that there's a question sheet and registration key. And if you have any questions in a particular session, in the question, and our volunteers will collect. So that some of them can be questioned and manifest.
Okay.
For everyone who registered for today's program, while entering, you might have received a questionnaire. Any questions you might have throughout the course of the day, you may note it down, and our volunteers from HBNI will come and address it. If you have any questions regarding the questionnaire, you can speak to ma'am here.
The session and the panel state.
For our next session, please join me in welcoming our esteemed guest, Professor J.P. Mittal, Distinguished Professor Emeritus HBNI and former Director Chemistry Group BOFC Mumbai. Mr. Richard Lobo, Global Head Innovation R&D, Business Excellence and Chief Ethics Counselor, Tata Capitals. Dr. Anubhav Saxena, Chief R&D Officer, Pidilite Industries Limited. Mr. Arun Bhanumurthy, Executive Vice President, Strategy and Transformation, Deepak Fertilizers and Petrochemicals Corp Limited, and Dr. Raghavendra Rao, Head CDMO R&D Pharma and Animal Health Business Unit, Heikel Limited. Put your hands together for our speakers for the session. Thank you, gentlemen. Professor Mittal, may I ask you to take this forward, please?
Let me first take this opportunity to congratulate the Vice Chancellor of HBNI and in charge and the academician from the CIE, and they had to have this joint collaboration program. I think this was needed for a long time ago, and we had this all the time. We were talking that we should have something of that time where the industry and collaborations will be there. But only it was finishing after this discussion, and nothing happened afterwards. So we hope that this time it has been planned in such a manner that some things will follow up and things will be improving. But as you must have seen in the program, we had 1 hour only for the chemistry session, entire chemistry. And in order not to delay the whole thing, I have thought of a system in the sense that we have there are 4 speakers going to be. And as a moderator, it's my duty to see that the time is taken very correctly. So let's think that we will give 15 minutes for each person. And in the 15 minutes, around 2 minutes, they would all talk about their own industry and things of problems of that kind and things. And about in 10 minutes or so, we will take up some questions to you, which last night we had done a lot of brainstorming on these questions, what will be asked. So we have listed the questions, and those questions I would like to ask them, and their replies will definitely give the answer of that. And 2 or 3 minutes, if we have, we will take students and talk to them and ask the questions from the students and answer. Would it be okay? That would be correct. Okay. So we start with the number 1 speaker, Dr. Richard. I've seen that all the speakers here have been chosen in such a manner that they are very senior people in different industries. For example, from Tata Chemicals, from Pidilite Industries, Deepak Fertilizers, and Heikel Limited. So each one of them represent industry in their own areas, and it will be interesting to see how each person sees the problem of these students interest in the industry or industry distrust in sometimes in university students because they think that they're all doing research and research oriented. I don't know how to use them in the industry. So I think that's the main purpose of this whole thing is that to remove this distrust among the students and senior industry people. And we will, I'm sure after these presentations, Students can ask whatever questions you have felt for them. At the same time, they may also ask you some questions. What is the problem? Why you are saying that? So may I now start from industry, which is a very big industry, Tata Chemicals, and to represent that, Dr. Richard Glover, who is the head innovation, business excellence, and ethics from Tata Chemicals.
Thank you, Professor Mitchell.
Yeah,
I can speak on your, if you all can all hear that.
as you like.
Thank you. Well, let me start by quoting Professor Mittal, which is, a big boy in the space. Many years ago, Professor Mittal spoke about how water itself is chemistry, H2O, and how it is so vital in every part of our daily lives. And I'm very fortunate that I'm part of Tata Chemicals, a company that gives Tata Salt on our tables every single day. Reaches 650 million people in a year, which is like many countries put together.
All of you can hear? Otherwise, I'll ask him to speak a little louder.
I can speak louder if you want. I can stand. So I'll keep more fit if you want me to stand.
If the time now starts, right?
So, and I think, while chemistry is so much a part of our life, it's becoming more and more important that it becomes interdisciplinary, right? And so, as the age has been progressing, a lot of science rooted in physics, chemistry, and biology have been coming together and delivering far more value. And today we've got, an era where we are focused on sustainability and green chemistry because we want the future to be far more bright. And I hope we will be able to cover upon those topics going forward.
Excuse me, they are saying that you must come here. Going.
Sure. All right, hope I'm audible. I can learn myself to thank you. And I was saying about how science has become far more interdisciplinary. It's become more critical and important. And you pick anything, for example, an ice cream, right? It sits in the space called colloidal chemistry. It is neither liquid nor it is solid. Or the toothpaste that we use every day in the morning forms in the same space. And you have to bring together this perfect blend between different interdisciplinary sciences. At Tata Chemicals, we've been focusing on a principle for the last 85 years, which is called serving society through science. And it's become so ingrained in what we do. All our decisions have to pass through that filter, in particularly if it is linked to R&D and innovation. So take, for instance, the birth of water purifier business, which is called Tata Swachh. It ended up becoming the world's most affordable water purifier. You took rice husk ash, put nano silver technology on it, and we are able to purify water today, removal of pesticides, fungi, virus, bacteria, up to US FDA standards for as low as 10 paise per liter, zero running water, zero electricity requirements, and serves the rural part of India. And we focused on 3 areas. We said we'll work on food, energy, and water. While I spoke about the water part, the food part, we used to focus on fertilizers, and we still have a focus on pesticides, plant growth nutrients, plant growth regulators, because we believe it's very important as an agrarian country that we improve productivity. But the world is shifting. When we look at green chemistry and sustainability, the questions now ahead of us is not about improving productivity per acre of land or increase the crop yield. It is about delivering climate resistance and stress resistance to our indigenous species. And how can we start working with crops that will have lesser use of water? Because India as a country is going to go through water stress, particularly by the time we reach 2045. Our temperatures are already soaring. I'm sure none of us dare to step out in the afternoon from London from 1 o'clock to 4 o'clock. We will want to be in the conference room. But that's the reality that we face today. And we've got our farmers and we've got crops that are out there. And huge amounts of precious crops, which is going to feed a 1.4 billion population, needs to be sustained
better productivity, same nutrients, but lesser use of water, higher resistance to climate stress, and also using lesser harmful chemicals, right? Because it will ultimately go to the soil. We've been also focusing on the energy sector. And as you can tell now, the new one is about electric vehicles in the market. And we've been fortunate that we started this journey earlier on. And we're looking at different spaces of that same energy, right from looking at metals and minerals. So the whole concept of sodium ion battery, for instance, it comes from salt, as basic as salt. And India does not have indigenous lithium in our country. Or for those that are interested in it, there is a space called perovskites, also commonly called perovskites. It's an ore that was discovered by a Russian scientist, which converts this light that we see to usable energy or electricity. And the power of this is excellent because the rays of the sun that it falls on a solar panel is converted only at about 17%. Because it's not constant at any point in time. And here you can have a mechanism, the same energy that we are using can then be reused because that ore is replicated. And it is the scientists and the brains in this room, the future of India, that we would like to come forward and take up these missions. We've got institutions like HBNI, many of the IITs, the CSIRs, many of the respected academic institutions in our country that are already working at the forefront. And we've got many colleagues as yourselves that are in research, doing your PhDs and MScs, and we'd love to answer some of your tough questions. But as a panel, and Dr. Mithil pushed us in that direction yesterday, we wanted to urge everyone here to deeply reflect on how we can embrace this so that we are a stronger India, a better India, and a better contributing society for the world. Yeah. Thank you. Over to you, Dr. Mitchell.
Thank you very much. Give you the permission to ask you a few questions.
Please. Or should I stand?
Well, question number one is India is witnessing a strong push towards sustainability. On?
Yes.
Sustainability and circular economy. This is a very fashionable thing to say. You should have a circular economy. Models from the perspectives of the Tata Chemicals. How do you see chemical sciences contributing to the national building and sustainable industrial growth?
Thank you. Thank you, sir. And I think there are three pivots that we've been focusing on. We've been reflecting very deeply on this whole aspect of circular economy. And we said, why can't we pivot and look at circular design? And many of us would have heard about it. We've kind of taken it more seriously, which means that your starting point itself should be an agricultural waste or a chemical waste or an industrial waste. And then through the channel and the end of life, it starts becoming far more benign to environment, but possibly gets used in another product. So you don't have to then focus on the whole aspect of recyclability. You can actually focus on reusability. So the circular design becomes very critical. I think the other is a shift in mindset, and we like to call it systems thinking, which is also a concept that all of you would know. And we have married systems thinking with the 12 principles of green chemistry. We've said both of them work very well hand in hand. It encourages our innovation, our R&D and our business thinking to say, why are we trying to import solvents? Why can't we use indigenous materials? Why can't we actually use waste materials to be the starting point? Why are we filing for patents? Because we want to have the patents and the publications. Will this really translate into commercialization of those products? And an example of this is we looked at the problem of rice husk ash. You see, a rice husk at some point in our country became an extremely a good source of, let me say, more economical energy, right? So you take rice husks because we're the world's largest producer of rice, and then you use it in boilers to get the energy out of it. The ash that comes out of it gets dumped into river bodies or into landfills. Now, the view is that it's a very good carbon source. And it is true. But anything that is good and is put in large quantities in a particular area can start becoming toxic. Just think of it, before having your lunch today, you end up having 10 rasgullas or 10 gulab jamuns, right? It's very heavy for your body. It's almost like that. And we took this as a challenge and a problem. We worked with many academies around the country, and we now have a process where we take out silica from this rice cash and we put it into tires. It's in the most leading tires of our country. We have a 10,000 tons per annum producing commercial unit in India at Cuddalore ahead of Chennai. And it gives amazing strength to a tire.
Yeah.
The friction level, the ability of the tire to have safety and lower fuel consumption has also been proven. So these are possible. So you take a national issue and a problem, and then you take certain principles on the other side and then marry them together, and we believe there's a higher value add.
Good. Yeah, excellent. Thank you very much. Because next question also had some connection with the same thing, saying students often believe that innovation and high-end research happen only abroad. How would you describe the research and innovation opportunities available within India's chemical industries ecosystem, which you very nicely explained? So I think that question you have already answered. We'll move on to the next one. How are modern chemical industries evolving from the traditional manufacturing to new innovation-driven and research-oriented organizations?
Thank you. Thank you, sir. I think one of the things I've been seeing, and I'm sure, many of our esteemed panelists here today come from the same industry mindset. We are quickly moving from volume focus to value focus, and you'll see it in all our companies. It's become very critical and important. And the biggest pivot that's happening is the ability to embrace. At one point, it was called automation, and the ability to bring process engineering far more stronger. Today, we all talk about it. It's called AI-driven tools, right? But it's about using the next lever. Today, it's AI. We can tell you 5 years later there will be a new tech revolution that will come in, and new wave that will come in, and nobody will remember ChatGPT, right? This is almost like the brands. Some of us had Orkut as one of our, or Yahoo.com and so on and so forth. These are all still very critical and important, or if you've got those email IDs. They're all critical and important, but you build on new technologies and platforms. I think industry is looking at 2 or 3 areas far more sharply. How do you innovate for nation and for society? And this is a link that's happening across industry, far more stronger. Because we are seeing as well that the new generation will commit to those that are sustainable, those that have a purpose, those that are able to articulate their values as to why they exist, and they will choose those products over the others. The other is how you take out friction and challenges from your operating processes so that you become far more agile and better. And we believe not just AI, but also the core of engineering, which is brilliant for India, is going to be excellent because you can then bring far more scale. We are the world's largest producer and exporter of software-based solutions, right? We are the world's greatest frugal engineering country. Some of the best scientific minds have come in from India. And the most important part is our 1.4 billion is actually a strength for the country. It is the world's largest, fastest growing market on the face of the earth. With that comes the other responsibilities, which Indian industry is finding far more faster, better. And we've seen that there's a lot of adoption. And that's the reason we are here today, because we believe in this mission so very much, and we thought we could share about it.
Very good. So for doing that, what are the key skills and mindsets that students must develop today to remain relevant in the future-ready industries such as green chemistry, energy materials, and sustainable technologies? They have to learn so many things here.
Yes.
Entirely what they have learned in their schools and colleges.
Thank you, Dr. Mittal. One thing I love, Dr. Mittal is asking me all the questions, so I can now sit and think about what others are speaking. Right? That's on the lighter side. But I think I would go back to the whole aspect called system thinking. It's very critical and important, particularly as researchers and those that are looking at careers. system thinking, you look at the entire value chain. And I'm sure we study about all these things. And then apply systems thinking to your own careers. Don't pursue a job or a company because that company seems to be good and seems to be doing better. Pursue a problem or a challenge that you think you want to. Because then you will find that passion and then you find the right organization to join. I think the other aspect is the youth of today, and I'm so happy to see so many youngsters around here. You've got a very strong voice. And this voice needs to be leveraged, right? You have to see where the voice is the highest, and sometimes where the voice is not very strong. And if your passion is part of that strong, then you should be there. And careers are in many domains. Careers are not just in the large corporates. The greatest careers in our country lie in two big sectors. One is in social entrepreneurship, which is changing the grassroots of India to be able to be a greater, stronger nation. And we need the right talent, we need the right passion, we need the right energy. The other is the entrepreneur ecosystem, which is growing in every state of the country. And look at everything. I was so glad that Dr. Anbaglan was here today. And, worked with Dr. Anbaglan when he was CEO of MIDC as well. And there's amount of changes that he brought. And every state in India has got a very sharp entrepreneurship focus. So it's not just that you need to be in any one particular state in order to be scaling. We are Indians. We can be in any part of the country and scale. And so I would urge that you can still pursue research, you can still pursue your career, you can still pursue your passion, but look at the world of India far more differently. Beyond the corporates and beyond the medium-sized industries, there is the social entrepreneurship, and there is the spirit of entrepreneurship, right? Of making your own startups or joining startups in order to scale.
Wonderful. Last question. For students aspiring to become entrepreneurs in the chemical sciences domain, what opportunities do you see emerging in India's sustainability and advanced manufacturing sectors?
Thank you, Dr. Mitchell. This is my personal view, and it's a point in time. I think, like our Honorable Prime Minister has also mentioned and has put out, and we've got many of our scientific bodies, including the Department of Science and Technology. There are three areas that I think India is very, very much in need of. The first one is in areas of energy security, and what more now than before. We see how the pressure points are coming in, not just on crude oil coming into our country, but all the other requirements of fuel, LPG, and the like. So energy is very critical and vital. And new areas of energy, so that we are able to progress as an economy, is very critical. Sitting on that same energy then is being able to get into the next spaces, which is renewable. And this is not just about renewable energy. It is renewables across value chains, right? Take, for instance, bioplastics or a biopolymer. It starts upstream as biology. You take sugar and bacteria, which will, let's say, to make it simple, the bacteria eats the sugar, you break the cell walls, and then you get into physics because you extract water and then you start polymerizing it. And then you take a bacterial output and make it equivalent to a petrochemical output. And that is your biopolymer, which is bioplastics.
Yeah.
Right? And so I would urge that that's the area that we need to start thinking on far more: energy, renewables, and then looking at far more, I would say, entrepreneurship. Startups, we need more people taking the plunge to transform grassroots and to transform industry.
Well, thank you very much for giving
Thank you.
reply
Thank you,
to all
Dr.
the questions. Now, we will have 2 minutes for any students to ask questions to Dr. Lobo. Please ask. This is the purpose. We decide only when some questions will be asked. All of us have, don't feel shy. Just come on, get up.
Maybe we can take question later.
Do you think we should wait till the end? Yeah, okay, fine. But actually, you gave me a very good answer, because just now you might have heard some telephone was ringing for me, and it was because my son had telephoned from US saying that he has decided to quit Cornell and therefore become an entrepreneur. So when you won't finish your degree first, you can know, so you just want to quit and you can't start entrepreneurship. But good, you told me at the right time. Okay, now we can move to next speaker, which is Dr. Anubhav Saxena from the pig light industry, which is an extremely important industry. All of you use Favicols and things of that kind, which are very, very wonderfully made. So Dr. Anubhav Saxena, please, yeah.
Thank you, Dr. Mittal. Good morning. It's always good to be among the young crowd. So how many of you talked about Fevicol? How many of you think, obviously everyone might have heard Fevicol, correct? How many of you think Fevicol is the only one product? Do you think it's multiple products or multiple chemistry, or it's just one type of chemistry? Okay, how many say one? Just raise hand, one chemistry. Few hands, multiple chemistry. Okay. So I think how many of you heard Dr. Fix-It? Everyone, right? Very quick. Most of you. So I think Pidilite is what we feel we are the home improvement company. Anyone making home, repairing home, or living home, our product should be used. Right, so it starts from the construction, Dr. Fix-It, waterproofing brand, right? Starting from from the foundation itself, we have a very unique set of polymers. Then further construction starts, whether say you are plastering it, you are concreting it, you are doing the waterproofing of the walls, you are laying the tiles. Everywhere our solutions are getting used. Once you make the house, then you start like putting the furniture, and Fevicol comes in, right? Nowadays, if you look at the quite a bit fancy interior design, which you see earlier, just wood, but nowadays a lot of nano composites have been used, a lot of charcoal composites have been used, a lot of unique plastic laminates have been used. And we have to come up with a solution to very different type of chemistry. So we operate about 13, 14 different type of polymer technologies where we're trying to provide solution in different shape and form which should serve customers. And once you started looking, how many of you do painting? Anyone who does coloring or the kids? Right, so some of the brands of Fevicryl, where art is stationery, I think there's quite a bit of Fevicryl. I think that's another section which we operate. And other than that, the most important and exciting for us is also B2B business, where we serve some of the sunrise industry like electronics. It's becoming important. In electronics, if in phone, is about 20 plus adhesives have been used, right? Then in automobile, in general mobility, let's say you look at the Vande Bharat, the older trains versus newer train coaches looks pretty good, right? Metros, right? The automobile, let us say EV, whether it's a two-wheeler electric, four-wheeler electric, in general mobility, provide solution packaging, right? In your houses, the FMCG packaging, you see that a lot of adhesives have been used. So I think we touches life from starting of the day, even the mattress which you sleep. I think it's a lot of adhesive, different types of adhesive have been used. So I think I thought it's a quick introduction, and you can name the type of polymer we use, either convert into the adhesive, sealant, or coating. And that's very important because it helps us sealing the joints, it helps us making the leak proof, and eventually it's help building your building much more sustainable because much more durable, corrosion resistant, right? And sealing helps us in the energy saving.
Thank you very much. You have made the industry so popular everywhere, including the film stars.
Yes.
Films, there are so many places are saying Fevicol lagaya.
And we have a Bollywood song, which the
Bollywood song. Okay. Now shall we go to some questions?
yes, please.
basically, we have explained very nicely about the different industries. Now they would like to repeat some of these questions like, how should a student approach to the career in chemical industry?
Yeah, I
How do they
think,
approach?
yeah, I think that's a very interesting question. And we must celebrate. So first of all, you should understand what type of job you want to do in industry. So if I talk about chemical industry, it starts from the whether you're a synthetic chemist, so you can make a polymers, you can make the monomers, pre-polymers. Then there's a group which formulate, and in formulation you need a little bit material science, nanoscience, nanotechnology, combination of all. There's an analytical department which characterize things, right? Whatever molecules you have made, what's the formulation you have made, convert into the give the insight on the characterization. And then regulatory section is also chemists required, where there's a IP, intellectual property management. Again, there are a lot of chemistry interests. If you don't want to work in the lab, you can do that. Application development, technical sales, all depends on you. What you want. Typically, it happens that you're not very, typically students are not very clear what type of job they want in chemical industry. Once you are clear, then you make a CV around it and try to connect to the, I think nowadays everything is well connected. Reach out to the, based on your research, based on your interest. Look at that, what type of industry you want to work, and then connect on the LinkedIn, connect with the other networking, go and try to understand what they do. And it's really something as an interest to you, right? So I think first of all, just understand what you want to do, what type of job you want to do, and then connect to the industry, understand what type of responsibilities, what type of expectations are, and then calibrate. Once in front of your CV, I think the typical mistake that a student do, they just make one CV and just pass it on everywhere. That typically does not work.
Okay, very good. Once you are here, some more questions for you. That is, for example, many students normally take career decisions based on their external influences, maybe their parents, maybe their friends, etc., that this is a good career, this is another good career, etc., rather than their personal clarity about their interest. They should be inquisitive and curious about certain interests which they have. How should you, young chemistry students, graduate, approach career planning in a more structured and informed manner?
Yeah, I think I further build on what I said earlier. So I think first of all, career is not something which should be chosen, which you rightly pointed out. It's a journey. It has to be developed over the period of time. And also should be developed based on your strength. Right? So I always say that you identify whether you're a batsman or you're a bowler. So if you're a batsman, then you just pick up your strength, really identify what you're really good at. And I think something like it's easy to say that find out what you're good at. It's not that easy, right? So it has to be, again, it's not a silver bullet. It has to be, you need to try a few things, right? If you figure out 3, 4 things you want to try, do a little bit experiment, do internship, talk to many people and really understand what you started liking it. And what you started liking, one of the parameters is where you start losing essence of time, where time passes very quickly. That's something probably you are liking it. So that's what I would say that focus on your strength.
That's very important.
Try a few things and then converge which one you're really liking. Few years here and there does not matter much. Career is long. It's about 35 years. Or like if you're a Dr. Mittal, then you just ageless, right? So 50 years, 55 years of that career, then a couple of years here and there does not matter. Find right things.
70 years. 70 years.
70 years of career, wow. Right? So I didn't invest in initially 3, 4 years here and there, 2, 3 years does not matter much.
Okay. One more question here is, how can MSc and PhD students prepare themselves differently for industrial R&D or manufacturing roles or scientific research?
Yeah, I think this is again the everyone, right? So it's not about if you are passionate about research, basic science, please do that. I think I'll just say that whatever you do, you should do with the perfection.
I think that is the best thing.
It has to be
That's what you want to do. That's the best thing.
yeah. So you have to have deep work, right? Really achieve like the highest benchmark on whatever you do. And we need everything. We need basic science, we need like the industry, I think also requires a lot of research, and academia also should do more translation research. So, but it's up to you to like what you like. Again, coming back to my previous answer, what you really like it, right? And if you want to like, if you like the application oriented work, then join industry and industrial research. If you want to have an interest in the basic science, then you do the basic science. But I think everything that does not matter, right? So for you need to really think about it. It's not about very simple, right? If you go to South Indian restaurant and asking the like the butter paneer or the something more North Indian, it probably may not work, right? So be clear what you want to do it.
Yeah, some false impressions are in the mind that they believe, students believe that uh, industry does not require very bright research students. They look for something mundane which we can do continuously based on some technology which is imported and then do exactly follow that. And some places, for example, I have personally seen that some paint industry or paint was there and they said, well, we need only BSc. We have all technologies, we have to follow it. That's all. Is this a correct impression?
No, I don't think it's a correct. I think it's a portfolio. So we need everyone. And you have every type of work. So I think we look at innovation in three phases, right? The first part is the incubation. If you're the incubation, great scientists who can do research, incubate, platform, next generation polymers, chemistry, etc. Then it goes to the development phase, and then also it goes to the like the maintenance phase, right? So for maintenance, a lot of bachelor degrees required, right? You do a lot of QC, you do a lot of testing, and certain people like it, and they like it, then it's all good. It's good for us, good for them. It's like a portfolio, right? What it is, mutual fund or only FD or only like the or only buying homes. It's basically everything. You buy little gold, you buy. I don't know the one, but that's a different thing. But then you have a portfolio, right? Exactly. You have a portfolio and
So that what they want to do, what he has interest. That's the best. If you want to do research, can be done research. If you want to do basic or daily life things, routine type of job, there are many jobs available for them. Some people like to do that. And it is important, that's also required. So you decide what you really want to do in your life, how you want your life to see. And everywhere, different opportunities are available in the various industries. And you talk to your people, talk to the friends, talk to the person boss, and things like that.
So we have about 25% PhD.
Yes.
And about 45% masters, MTech and MSc. So it depends on what type of work which we want, and especially PhD focus more on the incubation and the next generation things.
So let me thank you for a wonderful presentation.
Thank you.
Any questions from the audience which have not been picked up? One or two questions come? No, I think you have answered most of the questions. Pardon? Students. First, students, please, first priority. That will make it more interesting. Please be honest and stand up. Don't feel shy. If you have a difficulty, ask.
One question. Yes.
Loud, please. I think the microphone is not there. I can't get it.
So like in industry, we are computational chemistry students stand, like what job opportunities we can get in industry.
Sorry, I'm not able to.
In industry, we will check computational chemistry stands. What the career opportunities?
Oh, I think the speak up is more important and I think
Industries.
yeah. So AI is one of them. I think it's quite a bit of focus. As I speak, last week only I just opened the lab for AI in Pidlite. So that's obviously important. And I think it's the part when we're talking about, I can talk on the career in industry quite a bit. So the initial when saying the synthesis on the polymerization, etc. Before that is the modeling as well. But obviously I, in comparison to others, probably we need little lesser, but still like a 3, 4, 5% computational simulation, modeling, AI, machine learning, those opportunities are there.
Okay.
But it's a niche, not like a, and but it's very important.
Yeah.
But in some industry, probably they
Depends on what chemical industry, there are different kinds of things that we require. Thank you very much for your presentation.
Because the entire pharma industry depends on computation itself. Very industrial.
And from now on, everything will come from the computer science. Okay. Thank you so much. May I now request Mr. Arun Bhanumurthy?
Good morning, everyone. It's indeed an amazing time to the people. I am always told that spend maybe 50% of the time, people 50% of your age. So, well, I don't know if that's true because when I moved, I see Dr. Mittal, I'm sure that it's the reverse. But yeah, a little bit about myself and the company that I represent, Deepak Fertilizers. So, when we had Anubhav sharing about students and the student life, I look at myself having done my double graduation chemistry and BSc Tech in university. I was at a crossroads where was it important to pursue pure chemistry or look at MBA? And I chose MBA. And incidentally, obviously, paths have changed. But then I came to a company. I in fact worked with a company called BASF, the world's largest chemical company, and there I saw some of the people at the top, especially the ones at the seniors, were all doctors. They were all people with degrees and richness in chemistry. So it's about how you look at yourself and how do you make yourself able enough to get to heights. What is also important is that a little bit about myself again, is that I'm still looking at myself as a student where I'm pursuing a PhD now, but in MBA. It's in the field of strategy. So the field of learning is like when I'm part of agri, so look at fertility of the mind. That the idea is how do you keep your mind fertile and make sure that something nice is absolutely what you want to be able to soak in and make sure that it makes a wonderful thing coming out. So when you look at today yourself at crossroads, it's important to tell yourself that what am I doing for myself? It's about investing in yourself. And here, when I talk of BSF, what was also important that we learned was there are competencies that all of us require. So the very basic competency is technical competency. Is how do you operate something. The next is looking at functional competency, looking at a field that I am in finance or I'm in strategy or I'm in supply chain. So there are many fields. So the functional competence, but what's the highest or the topmost is behavioral competency. So what gets you to a place of authority is typically the behavioral competency. That is, how do you evolve as an individual and how do you make yourself someone who is able to get to a place where you're able to obviously orchestrate and make things happen. So I think as an individual, as at the juncture that you are in, you're trying to look at yourself as what is the competency that you're going to invest in yourself and make that capable. Coming to the company where I belong to Deepak Fertilizers. So Deepak Fertilizers, as the name is suggests, so what are we in? What does Deepak Fertilizer manufacture? Anyone? The obvious answer, right?
So, yes, so you haven't referred to any chat GPT or any of the other sites, so I might just elaborate. So while we are into the crop nutrition business, we are also into mining chemicals. We're into industrial chemicals. We do have a little bit of a real estate kind of arm. But yeah, dominantly chemistry, and we even to the commodity chemistries. So when you look at the crop nutrition business, a dominant part of that is bulk fertilizers. We're also into micronutrients or the water solubles. And mining chemicals are a very large part of our portfolio. And industrial chemicals, when we look at times like COVID, where a lot of our product, especially the IPA that we make, we started as the country's only IPA manufacturer. Now we have two in the country and many more going to come in. But isopropyl alcohol, nitric acid. So these are very basic chemicals, the commodity chemicals that we manufacture. But yeah, as a company, we have in some way looked at the bigs in the industry where BSF. So where you're looking at both backward integration and forward integration. So we've invested in chemistries that take us to be more reliant in our inputs. So that is backward integrated. And we are also interested in the downstream. So we are actually as a company looking at how do we get solutions for customers, and that's the area that we are now slowly looking at getting better with. So this is a little bit of the company that I belong to. Yeah.
Now, some questions.
Sure.
Fertilizers and mining sectors, as both in which you are a specialist, are undergoing major transformation due to sustainability questions. And no pollution, nothing, etc. Energy security concern, both of them should be minimized. What exciting opportunities do you see for chemistry students in these industries, particularly with respect to energy security and sustainability?
Right. Yeah, I think very pertinent question, sir. That today, the world that we live in, we are trying to look at, it's not about size only. It's like, how do we make more out of less? So the entire topic is about how do we make sure that we're becoming more and more specific and very, very focused in the way we are able to use our products. So when I started my career with Rallies and we used to distribute Tata Chemicals fertilizer, that is urea. So urea was something that was absolutely the one that was wanted. So any chemical that you would want to piggyback on urea, we sold. So the farmer essentially was looking at that this was the most cheapest product, and we, as a populous country, we see a lot of subsidy also on urea. So the volumes of urea being used automatically does not improve the productivity. It in some way, deteriorates the soil condition. So the idea is today we are now slowly moving to a place where we're getting more and more aware, and the use of water solubles, being able to use drip irrigation, and the ability to be having products that are very specific, especially slow release, like we talk about medicines, the slow release. So these are areas which are automatically evolving, and we find that our farmer community is equally getting themselves better equipped. So as part of my research study for my PhD, I have been working with farmers in Nasik, especially the grape farmers. These are among the most productive, more intellectually better set, because they are also exposed to export markets where MRLs or the residue limits are very well set. So they are the ones who are now asking us products which are the ones which are slow release, which are the ones which can be consumed at less volumes, because these markets that they're going to export automatically want them in that way. So technology has slowly started getting better to the place where we're getting more precise. Similarly, when I look at mining is not about how do I blast a particular ore, but it's getting to the place where how do I reduce my total cost.
Yes, right.
Because it's about how do I make the blast so precise that the rock is broken such that my excavator can lift it, my entire truck that is going to obviously have its own carbon footprint is able to maximize. So the bulk density and the volume space that it's going to occupy is precisely good, and automatically it's able to clear the mine better. So the preciseness of mining is the area to work on. So when you look at today, we are also seeing that technology in terms of how digital capability, especially AI. A lot of data is now available for us to make sure that this is possible. But yeah, these are fields which are surely areas for any one of you to look at. Yeah.
Yeah, sure. Last question. India is facing, as you see nowadays with this Iran war as well, from structural challenges due to dependence on the imported raw materials.
Right.
And of course, what is the thing? How do you go around doing something which will be like, for example, coal gasification? Very important scientific area in which chemists can contribute. But are you people are thinking on those lines?
Right. So uh, the product that we manufacture, the core ingredient that is used is natural gas. So we are a fertilizer company, a dominant consumer of ammonia. We manufacture ammonia now, but the input that goes in is natural gas. And as a country, we are structurally challenged. So we are dependent on a lot of inputs, and the prices that we automatically get, we're not competitive. So there are a lot of inputs that come into the country from countries that are in the Middle East, Russia, and who are dominantly having these sources of energy. So this is essentially an area that the tides are against us. And when we look at today, some of the things that are abundantly available with us is obviously coal. Coal as a resource is something that is for us to tap. Yeah, it's not an easy chemistry to extract, all the fractions from coal. So coal gasification is a topic of great interest and is being funded by the government of India. And this would remain to be one of the topics that each of you should look at, because when we look at countries like China who have done a good amount of leverage using their own coal resources, I think it's topics to learn somewhere also with pride of how some of these some of our neighbors are able to do it better than us. So coal gasification. Yes, there was one other thing that I wanted to put from my mentor, Professor M. Sharma. Just recently heard from him that one of the other topics that we're abundantly available with is the vegetative topics like, and I heard Dr. Lobo also mentioning that lignochemistry. How do we use lignochemistry? How do we build this so that it's abundantly available? We are one such country where solar, we are also covered with water on 3/4 of our sites, as well as the vegetative pieces. So I think lignochemistry is another part which automatically opens up an area where we could become a little more reliant on some of these inputs that we today import. So these are again areas of interest, and I'm sure that lots can be done here.
Okay. Thank you so much for your excellent lecture and presentation. Any questions from students? All right. Yeah, there is one. Come. Microphone नहीं होगा.
Farmers are basically nano urea is being seen as a better alternative as compared to conventional urea. Can you throw some light that why it is not being adopted at a large scale in our country? Is there any scope of improvement over there, or what are the potential pitfalls in that technology?
Well, I can see that nano urea is something that is surely the technology that we all need to look at, getting dominantly adopted. But there is a place where you're looking at distribution as well as the way the awareness of the farmers getting better. I think I would only say that this particular subject is an area where, given that it has its own political pieces connected to it, I can only say that it is yet not, it's nascent enough in the sense that people are not able to adopt it purely because the distribution network as well as the ability to make this product easily available is one of the topics why it is not caught up as much as it should have possibly. Yeah.
Yeah. Thanks.
Thank you.
Okay. Thank you very much. But best questions? Now, Raghavendra Rao.
Thank you.
High-Cal company.
Yes. So, myself, my name is Raghavendra Rao.
I am responsible for the research and technology at HICL. Basically, I'm an organic chemist by education. Did my PhD and postdoc from Glasgow, UK. And moved back to India, worked for companies like Dr. Reddy's, CII Life Sciences, Piramal, Pharma Solutions, and Syngene. So my last stint was with Navin Fluorine. I was a chief scientific officer. So this brief overview. I will talk about pharmaceutical industry. So just before starting pharmaceutical industry, I wanted to understand how many of you from organic chemistry background? Fantastic. So when you pursue organic chemistry, either masters or PhD, obviously someone will look at whether I can get into a pharmaceutical industry, which is very very easy to get into, right? So and they also feel that they can contribute to the society, and at the end of the day, we think of patients, right? So in pharmaceutical industry, the things are evolving drastically. So traditionally, what was happening was in India, we were making bulk manufacturing of active pharmaceutical ingredients and the advanced intermediates. But now things are moving in some direction from the pharma point of view. Now, the different direction in the sense like earlier when it was a large volume productions, now the fundamental research is coming up with the high value products. Earlier we used to take some of the medicines like 200 milligrams or 210 milligrams per day as a maximum daily dosage. But now things are moving to nanomolar concentrations, particularly high potent active pharmaceutical ingredients. We talk about only a few milligrams per day or per week. That ADCs are coming to life. So antibody drug conjugates, peptide drug conjugates, proteins. So these are the new things are coming up in industry, and which are very very unique and niche areas. The Western world is investing a lot, and of course in India, we also, as a service industry, we are also catering to those innovator companies. Particularly from the HICL point of view, we are into pharmaceuticals, and in pharmaceuticals again, we are into API generics, meaning we come up with the APIs with less cost and affordable price to the needy patients. And the other sector what we offer is CDMO, contract development and manufacturing organization. Also, we operate into agrochemical, and specialty chemicals. So these are all the different verticals that we operate. And the CDMO point of view, this is a very, very good opportunity for the scientists coming up or researchers coming up from the pharma, as well as if you want to get into a CDMO of the pharma, it's a great opportunity to start with. So I'll just stop here. I would like to take some questions, and then we can talk about.
Okay, thank you very much. There are very few questions left, but still.
So please use mic for
Okay. What is the one skill every chemistry student must develop to stay future ready? One skill.
Yes. So one skill, but every student should develop is
card.
Yes. So, but you should develop curiosity first of all, and you should be updated with new techniques that are coming up. For that, you need to do the research and try to get up to the speed and try to understand how the industry is operating and the new technologies are coming up in the Western world. That's something you need to really develop the skills to understand those things, particularly the artificial intelligence, simulations, and the techniques such as I mentioned in the ADCs, and product kind of things that you can try to understand those skills so that you will be progressing in your career once you enter into the job.
Okay, one interesting question is, what technical and non-technical skills should PhD students develop to improve employability and succeed in an industrial role beyond the traditional research lab?
Certainly, technical, obviously, everyone should have the fundamental core subject knowledge in both. It's not, okay, we have something, but, if you get into the deeper and deeper, that would be very, very important with respect to technical, point of view. Of course, when it comes to pharmaceutical industry, in technical point of view, you should know, that the technologies that are coming up to understand the analytics. For example, if you are making a synthetic molecule, so how to analyze that? For example, spectroscopy techniques, NMR, HPLC, GC, okay, and GC headspace, to understand the residual solvents. These are the techniques that you need to be aware of, and then to get into the, because it's a theoretical knowledge that you always have from your books, but you should have hands-on experience. But you would opportunities in your academic institutions, or maybe do some industrial, internships that you will, come across these techniques and you learn. So when it comes to non-technical aspects, obviously the interpersonal skills are very, very important. As a scientist, okay, you are making, you are experimenting and then, documenting and publishing results, and that is not sufficient anymore in fast-paced environment. So if you want to progress in your career, then the interdisciplinary activities such as, you should be able to coordinate with your peers, and you should be able to work in a team environment. For that, you should have a very good coordination skills, communication skills, and demonstration skills. So these are the very important things that everyone should have, so that it's easy for any individual to progress in that career.
Yeah, very important. There's one question asked for the students. Anand Anna Sable from HBNI, that from perspective of the pharma industry, as you belong to, what is the most significant skill gap or blind spot you see when the fresh PhD transitions into corporate research?
Yeah, so that's what we are seeing. The gap is, I interview so many, scientists, it's really entering into the pharma industry at certain level, of course. So what I'm seeing, the students are lacking fundamental chemistry. In those days, we used to have reaction mechanism. If you want to draw something, if you want to understand natural chemistry, you need to have, 30, 40 step synthesis. You used to draw on piece of paper, without any, looking at this. And the reaction mechanisms, for example, right? So how a chemical transformation is happening. So for some reason, the scientists are coming to industry with that kind of gaps, right? So this is something very important. If you really want to excel in your career, you should not forget about your fundamental chemistry. To do that, organic chemistry is very important. Of course, I also don't know, most of the things, but we should keep updating ourselves, refreshing ourselves, go back, refer your fundamental chemistry knowledge, because this is, if you lose that, whatever the stage, but if you have those fundamentals, and if you lose that gap of having this, fundamental knowledge of organic chemistry, would really help. So this is the gap I am seeing. Also, from context, if you, and after your PhD, if you really want to go abroad for your postdoctoral studies, or if you want to pursue career in corporate world or outside India. So the communication, the speakers, right? So with respect to English and the communication. So that is something, the gap I'm seeing, to enter into this kind of world. So you should be updated, and you should be confident in when you speak, when you attend interviews. This is something you should be able to focus, so that you'll be succeeding in those areas.
Okay, thanks a lot. So thank you very much for your wonderful presentations and all the questions are answered.
Yeah, thank you.
Now there are one or two more questions general questions from the audience and from the students. A person from the physics background doing PhD in colloids and polyacrylates, how one can or she approach chemical industry, and most of the job profile specifies subject and recruitment notification. Physics person.
Yes. So physics or chemistry or anything, it's a science, right? So because sometimes we also as an organic chemist, what we do, we study in certain areas. But when you go to industry, you have to explore, multidisciplinary, subjects. So as a physics person, opportunities because to understand particularly, you may be fit into the analytical chemistry kind of things. And there are not only which chemistry, whether analytical or in synthetic chemistry or other things, but as a physics chemist, there are certain areas you can focus on because you guys are in terms of solving things. So you can assume the artificial intelligence with respect to computational chemistry kind of subjects that you can choose, and when you do practical involved, because in discovery chemistry, physics students as well sometimes. So discovery chemistry have all these bonding studies and understand how interactions are happening. And that's where sometimes we try to look at in physics students as well, so that we can get into that area and we can excel in that particular area.
Okay, wonderful. There are a few more questions, but I would suggest that these questions you can ask these people at the tea time because tea is getting cold. So I think we'll meet them there and catch hold of them and ask as many questions you want. Then only the purpose will be served.
Thank you.
Thank you very much for all the wonderful things. So I hope you have enjoyed this session. Please, students should be more active. That's the more important thing is they should ask more and more questions. And don't think there is something like fundamental chemistry and something like applied chemistry. Somebody is applied work, somebody is doing research. The basic point is there is always a good science or there is a bad science. You can do bad science in both. You can do bad science in research and paper publication also. You can do bad science after doing any fundamental nothing. So just have curiosity. That is the number one. I would suggest to every student that you should be curious. Ask questions as much as possible. Ask yourself why this color is red, why the color is pink, why this color, how can it happen, all these things happening in the same line? How are different colors? Ask any simple questions to yourself or to your friends or to your teachers. So indicating that you are curious about the whole subject. So as long as you are really curious, you will be a good student. And maybe that's what I do up till now. I'm very curious. I don't mind asking questions to anybody. Why does the mango becomes bitter, black, or to be sweet? What happens inside the chemical reaction? That was the curiosity which brought me to BRC. Because they said you have to go to BRC, they tagged some components inside the chemistry and then followed up how the acidic component is becoming the sugar component. And I joined that at the age of 19, and I'm still trying to understand what happened. So thank you very much for being a wide audience, and of course all the speakers. You have done a wonderful job, and I hope we'll meet again somewhere, some places. Thank you very much. I think tea is waiting. Not yet.
Just a few moments more, sir. Before we end today, this session now, we do a small token of appreciation for our speakers today. May I request Professor Kamachi Madali to please hand over the token to our speakers. Professor J.P. Mittal, Distinguished Professor Emeritus, HBNI, and former Director, Chemistry Group, BRC Mumbai. To Dr. Richard Logan, R&D, Business Excellence and Chief Ethics Counselor, Tata Chemicals Limited. To Dr. Anubhav Saxena, Chief R&D Officer, Pidilite Industries Limited. To Mr. Arun Bhanani, Chief Executive Vice President, Strategy and Transformation from Deepak Fertilizers and Petrochemicals. And Dr. Raghvendra Rao, Head CDMO, R&D, Pharma and Animal Health Business Unit, Hykel Limited. Can I ask you all to please stand for group photograph? Yes. Yes, please. Thank you, gentlemen. Before we move on, I have 3 quick announcements. One, at the time of registration, you would have received a questionnaire. Given the paucity of time, or in case you do not get to ask your question during a session, you will write down your question, tick the session name, the speaker name, and hand it over to colleagues at HBNI. We have Pranita and Sakshi Basat. Can you put your hands up, please? They've identified themselves. You can hand over the questions at any point. We will wait for 5 minutes for a quick tea and coffee break. At the tea and coffee location in the lobby, you will also find a photo booth and you will also find multiple stalls. Please visit the stalls and be back for our next 2 sessions before lunch. Thank you.
API. Mike, only this much.
Now it's coming for online. It's better.
Better, huh? This way.
Yeah. So it can.
I know. This is okay.
Testing continues.
I know. This.
So online people not be able to get unclear words.
Actually, from next onwards, we have told them to use and make sit and talk.
Okay.
In mic.
Yeah.
Not many will come.
Okay.
I saw that.
Hey. ठीक है ठीक है ठीक है कर दिया अभी वो बता दिया अभी पार्ट राजू वो रहना है माइक है जो आएगी ना माइंड
हेलमेट चालू दे चलना शाम करके आप भी तेरी बैठ जाता
So then we say.
Videographer banks.
Good afternoon, everyone. May I request you to take your seats, please? For our next conversation on engineering, powering the future of workforce, exploring employment avenues across emerging engineering domains such as artificial intelligence, robotics, smart manufacturing, low carbon energy systems, including nuclear and renewables, advanced instrumentation, and infrastructure technologies. This discussion will center on industry-ready competencies, R&D roles, internships, and innovation-led careers. Please join me in welcoming our speakers. Dr. R.B. Goel, Member, Atomic Energy Commission, Distinguished Professor Emeritus, HBNI, and former Principal Advisor, DAE. Dr. Nandakumar, Chairman and Managing Director, Chemtrol's Group. Dr. Anuradha Ganesh, Founder and Director, Arantri Consulting Services Private Limited. And Mr. Hemant Narvekar, Vice President, Head of Manufacturing, Low Voltage Switchgear, India, ASEAN and Africa region from Siemens Limited. Please join us on the stage. Thank you, gentlemen and lady. Thank you. Dr. Glover, may I request you to take this forward?
Thank you. And I must compliment HBNI and CII for organizing this event where I see so many young faces are present. And this session is on engineering. I think many of you must be doing PhD in engineering. Some must be doing PhD in sciences with emphasis on applied aspects. So that is closer to engineering. So can those who are working in these applied aspects in sciences or engineering raise their hand so that we can know the composition? Yes, I think there are some. Okay, I think first let me try to talk to students. When we say engineering or say technology, what exactly is meant by technology? How technology develops? There is a really nice book, and those of you who are interested, they can read that. It was published in 2009. The author is Brian Arder, and the book is The Nature of Technology. From the gist of that book, I'll just try to convey next 2 minutes. Novel technologies originate by piecing together existing ones, that is existing technologies,
and of course by capturing phenomena, that is new phenomena. Phenomena are simple natural effects and as such exist independently of humans and technology. The technology is a phenomenon captured and put to use. There are certain technologies like removing wood and producing fire. They are easy to stumble upon by accident. They require only causal explanation, that is, you study cause and effect relationships. And all such phenomena have been harnessed. Deeper underground are scenes such as chemical effects. Some of these are uncovered by early adepts, but their full uncovery requires systematic investigation. The discovery of largely hidden phenomena, such as nuclear energy, require modern techniques to reveal them and accumulation of knowledge to understand them. They require modern science. Science not only uses technology, it builds itself from technology. Science without technology would be a weak science. The technology builds on harnessing phenomena largely uncovered by science. Science and technology thus co-evolve with a very symbiotic relationship between them. For evolving new technologies, the industry needs qualified individuals. It needs research scholars like all of you who are sitting here, along with, of course, technologists. Given this background, let me quote some facts. About 10 years back, US National Academy Press, they published a survey where they wanted to find where exactly doctoral graduates are going. And they found that around 43% of STEM PhDs are with industry. When it comes from 43% are outside industry. And amongst engineers, 26% only are with academia and rest are with industry. So this tells you the kind of scope which industry provides you. And I was very happy today in the first session, it was, I think, the Pidilite person, Dr. Anubhav Saxena, when he said that amongst their senior staff, there are 25% PhDs. This trend is catching up in India as well. Given this background, we have to see the topic assigned for this panel. For selecting a topic for research, members of faculty in universities can adopt one of two approaches. One is to go to library and based on literature survey, find a gap and pick up that for research. Second is to have dialogue with the industry and find out what their needs are, what problems they are facing, how can they increase their productivity, how can they reduce energy requirements, how can they substitute costly inputs with those available locally, and now in the present era, how can we adopt circular economy. Essentially, universities have to become engaged universities. They have to engage with industry, society around them. The value system in academia has to evolve in a manner which places more emphasis with this engagement. Society, industry, academia, they have to move together. So in this regard, I like to quote from two eminent persons. One is very old and one is new. I think youngsters here will not know that there was the Education Commission way back in 1966, headed by Professor Kothari. He writes in that report, and I quote, "At present, the center of gravity of Indian academic life is largely outside India. That is to say, our scholars and scientists working in fields which are internationally cultivated and still tend to look outside India for judgment of their work. are intellectual models of the problems which they study, for the books they read, and for their form of appreciation and approval. And then he later writes, the Indian problems are not seen in their concreteness and particularity, and as a result, techniques and theory are not adopted to Indian situation. This was in 1966, and in 2016, there was a book published in Europe by Elkanah and Cooper. They write, I think, something similar from 1966 to 2016, and I quote, the fact that hundreds of new universities in China and India copy the curricula from the United States for Europe and send many of their doctoral students to study there results in a serious neglect of their own scholarly traditions as well as local and regional problems. This again gives a message that faculty, students have to engage with industry, and industry has to value the advice which they get from scholars working in India. They don't have to look for collaborations from abroad, technology transfer from abroad. I'm trying to give message to both sides. Industry should look to Indian scholars and Indian scholars should engage with industry. With this, I conclude my remarks and I'd like to say that to translate the research output into words, including employment with industry in India or startups in India, faculty and students should become engaged individuals. And this becomes more important in the current geopolitical scenario, which has unfolded past 1 year, I should say. Here, if you see, after Second World War, the countries like Germany, Japan, South Korea could progress because their rise was assisted by USA in particular. China started rising to mid-70s again, their rise was assisted. And when we were planning to become Viksit Bharat by 2047, the statements which are now coming from global think tanks, they are clear pointed to the fact that India's rise will be resisted. The era of assisted rise is behind us, and with this, the importance of research, importance of innovation, the role of faculty, role of Indian industry, role of research scholars become more and more important. So I think we have in this panel, we have three very eminent panelists. So rather than asking specific questions, I'm told that the time is at a premium, so we have to cut down a session from 1 hour to about 40 minutes. So I'll ask one question from all the three distinguished speakers here. But how from all three of them have different background, based on their background, based on their perspective, how exactly they are looking at the role of students work with faculty, the role of faculty, and what kind of role they will like fellow industrialists to play. The first speaker, Dr. K. Nandakumar, is the chief director of Chemicals. And he told me that they work on instrumentation across engineering disciplines. Dr. Nandakumar, please.
Thank you, Dr. My name is Nandakumar, academic engineer. Way back in 1970, I passed out. Within 7 months, Dr. has covered what is the scenario of the world and how India should react to that. Or rather, I would say, we know what we do. We know what the rest of the world is. Willpower world. Volatility, uncertainty, complexity, and ambiguity. That's what Dr. Grover said. Now, is to be universals. With that in mind, in government, we always talk about this, but which all investment is sustainability. And what is sustainability? It is peace. And the reason peace had it. And the peace, people, human resources, planet, the environment. Third is prosperity. Prosperity also includes profit of that. Without that, there is no sustainability for any industry. The reason why one of these elements, what is the purpose for it? The sustainability is a concept. With that, you can't sustain it unless you have a specific purpose. So with that purpose, we look at the world. India has to certainly look into research, no doubt on that. Because whatever there is a gap. It's not only a gap in existence, but future. When we look at sustainability, in 2047, is Vikasat Bharat, 2047. But prior to that, in the previous World Conference, there is zero. There is to become in terms of the emissions, carbon emissions, to be removed by 2050. But in the population, just property on 20%, I believe property value is 20%, and looking for employment and entrepreneur, 65% of employment. And of course, the list is just more above the moderate. How that country can sustain without really looking at how we what we do. So we need to look at technology areas, the research areas, and that is the area it has to look at it. Because even if we become by 2070, so in which I am coming from chemistry, we need to certainly have all technologies to be upgraded. And that process, without research, you cannot do. When you do technologies, what it needs to commercialize, what is the engineering equipment. We also need to open. So we also need to implement science or R&D, etc. And even with that, you cannot really sustain even with all the projects collaboration. Where it was originally globalization, today it has become regionalization. In that globalization, also you need to cooperation and collaboration with others. So certainly the collaboration, you need to have compliances, you have to have across the areas and sustainability. When you look at certain areas, you can't sustain at the same time, you have to be sustainable with your self ecosystem. When a person was chemical engineering, it was good concept chemical engineering because it was just introduction at that stage, everything was important. You need to share the books in the laboratory. Because it's difficult to get people like books coming mostly US. But mostly where people at that time would share. Even the professors also came from overseas also. So that was a difficult time. But I'm understanding each statement seats was there, chemical engineering. But we need to sustain that, we need to go out. After when we study also, I had an opportunity to work in a field by coaching. And there we went to instrumentation. Within 3-4 weeks time, I got into instrumentation. And every year I used to go for training there. And after 4th year, after 5th year, after my project was also in profiling. What I am saying is, I just got a telegram job with me. I applied. Then came back. There was a strike. But there is was working 100% capacity. No, because all the pipeline. Where I got into a lot of experience in science of engineering. Because with 4 days training, I was asked to manage distillation unit. Everything was pneumatic instrumentation, 100% imported. With 4 days training. So that's where you get into practical life. I didn't much, but as a result, that helped me develop my own habit. And after working for 3 years, I came to Mumbai, worked for 3 years. Then I started my own company, Chemtrons, in 1975. Today we completed 50 years. I must say that it's starting at that time industry is not possible because when I started, I had 2,000 rupees. But I had the courage and I used to travel all over India. You will be without a hotel, every the train. But that made me to know what the country is. And 2 years later, I also used to collaborate with overseas companies to market their products. So that, because my products are made in India, instrumentation, everything is imported. So I have no money to start, expand business. So when I started selling the products, I get commission. So that commission is going to sustain that. One company with whom I represent, there was a company by name company. It's one of the largest pump manufacturer, chemical process pumps for chemical industries. I was selling the products in India. And the international sales manager of that company came to India. He found there was a lot of potential in India. And this young man, I could sell some business. He thought there is a great potential. So he went around. He asked me one afternoon, a young person, do you think in this country with so much of restrictions, are you able to sustain your business? Because at that time it was a controlled economy. Even if I had to go overseas, I had to get an RBI permission to get a DA every day or for my own expenses. So it was very difficult. It was an import license. You can't import anything without an import license. So actual user license is required. So I was suddenly flabbergasted about that question. When he asked me whether you can sustain, I am doing, he admits that I am doing business. So he was asking me a question. Can you sustain in this country with a lot of restrictions? I will give you a job in better zero. Are you ready to accept? So I was never expecting that question. I said, no, I just started, but I just would like to. So yeah, he did not, he felt that I do not do job. Young engineer wants to go to USA. He's a young boy. Even after offering a job, he was ready to go. After 6 months, when he came, he asked me this question. Are you ready? No. Still, I said no. I said no disrespect to the American companies. But I am today a chemical engineer because government of India gave me scholarship. And that scholarship was good enough for completing 4 years. Why I am saying this, all the students should look at company, our mission. That is good. And I have not left my job, my portion at that. Even today, I have a lot of challenges, but still I had satisfaction in serving this country. I brought a lot of technologies, collaborations, and I personally brought a lot of foreign savings to this country. First collaboration is signed with a German company, third largest German company at that time, Sekat, for developing. At that time, there was no research in India, especially on the process plant. So I signed that collaboration. We bought that displays and level transmitters, which I have sold even in nuclear power stations, in power plants, supplied. And at that time, it was a technical collaboration or for financial collaboration, on technical collaboration. 7 years to develop a product and then pay fee. What I am saying, even that time, government has given a lot of incentive, but young people did not look at. Most of them wanted to go overseas. Somehow, the nationality within me, because I am a student, I was also practically involved in political science. So look at the country. So I personally had to do a lot of service to this country. And I overseas brought and developed the product lines here. And I spent with the CII 43 years, I'm a member.
CII also has improved quite a lot. And collaborations improved. I have been in numerous committees in CII, and something I'm handling for the last 20 years in CII. Spent a lot of time. So what I would like to say is in the coming forward is to look at what the technologies we need for sustainability. Even this, to look at digitization is one area. Without digitization, you can't sustain. Couldn't do compliances. Whenever digitization is coming, what is coming? And that is where the research certainly has to talk about words. To focus on research because yeah, it's across we can look at the physical and also the sensors coming in get exactly everything you can copy it on, which helps you in reducing the maintenance period, which helps you in forecasting what are the potentials. It is not engineering. The other day I just saw WhatsApp. It's WhatsApp in China. One person is coming with a digital tools, looking at artificial intelligence, his problem related to health. Within 1 minute, he gets his prescriptions and body. So that is a lot of artificial intelligence in digital tools is coming. Doctor somewhere, doctor same digital doctor also gives a prescription within system coming there. So digital is one focus. Even traffic congestion can certainly be to digital teams. It's a digital area. Digital tools is the future of the industries, future of the science certainly coming. Then comes robotics. Because you can't really do everything physically. So you need to look at what the robotics is coming. And robotics, especially on the engineering side, it is a collaborative robotics known as cobots. And that cobots certainly will do a lot of processes, a lot of applications where you can't even physically enter because of the compliances, because of safety, because of the quality inspections there as well. So collaborative robots will control most of the operation, which are is playing. So the critical areas where you can't access a specific clean purpose, you can do cobots. Then of course other areas which is coming is the advanced instrumentation, manufacturing areas. Then also some of the areas which one has to look at beyond the engineering side is the low carbon emissions, low technology areas. And I personally to develop this and also to collaborate with the overseas communities to sustain. Since if I get time, I'll certainly come back. I will interact with most of the people because I have a lot of personal experience in industry, 50 years in small scale industry, and looking at global competitions. So I personally our country has a great future. And in the coming days, India will be the focus point for the rest of the world. Not USA, not our closer. I used to say India has to become government of the East. We have achieved that. Germany can become India. That's the person I have. Thank you, sir, for this opportunity. Thank you.
Thank you, sir. Thank you, Dr. Nandukar.
Now, the speaker, Dr. Amanda Ramesh, who has background in energy science. She has a startup located at IIT Madras. And I was just talking to her, and she emphasizes indigenous technologies. Dr.
Thank you so much, Dr. Grover and the eminent panelists. And thank you, CII, for this opportunity. I will start with my work with CII. Before that, I must tell you what I speak is totally out of my experience of 25 years at IIT Bombay, 10 years at industry and startup. Believe me, every stint has given me a lot of learnings, and I'm just here to share that with you. He said that I focus a lot on indigenous technologies. But before I talk about that, let me just give you I am the chairperson for CII, DSTPM fellowship, where we ensure that every PhD which is there has an industry component to it. You know how difficult it is to find candidates who apply for our fellowship? Hardly any. We have been wanting to give 100 every year. We have not been able to give more than 30. All right. And if you ask me, is it because the academic is lacking connection or is it the industry lacking connection here? It's not that. There is something more to it, and that's where you people really will play a role. Now, let me bring another aspect of it and then arrive at a solution here. So India is saying that we want to increase the industry investment in R&D based on their survey and saying Korea does so much, Japan does so much, US does so much, Indian industries should put in so much in the R&D. Good. They will put in money along with an academia. They will submit it to ANRF. They will get some project. I suppose most of you are doing PhDs on some of those. It's been funded by some of the other project, right? Very rarely it happens that there is no project and the faculty is taking unless it's an institute fellowship. There also to do the work, experimental work, you definitely need some or the other funding. All right, that is done. So there is a problem. Now at least some industry is there. The faculty has taken up the responsibility to give the solution. Who's doing it? 5 of that person student. Right? Out of the 5 students, after you finish PhD, where are you going? Right? Where are you going? If I go by the law that he had given for US, let me replicate it here. 40% of you would like to go to the industry, 60% of you are back into academia or the in research organizations. So let me not talk about those 60% yet. Okay, so 40% of you are going to look for jobs in the industry. Which industry are you going to look? That industry which is saying, why should I start with R&D? I am going to give a project to the academia. That is one answer. The second is, what am I going to do with PhD students? Why should I take them? What are they going to do for me? I don't have any research lab. I'm not spending anything. I don't even know what research to do. I don't has made this product, Japan has made this product, Korea has made this product. We know it's going to be useful. Either make it indigenously or tweak it. That is all the PhD students are required for. Free will innovation tweaking. All right. But who if were there in the industry, would tell before or 5 years before or 3 years before that listen, I think this is where the world is going. We should start research on this. Okay, and then they would say, okay, we have facilities, let us start with collaborating with academia. So it's a chicken situation. You understand what I'm saying? So unless you people are not there. All right, now I tell you why you can do it. Each one of you are working in one small area. Do you think industry is going to give you a job in that one small area? Very few people. Some pharma industries and maybe some others who have an R&D organization, maybe tablets, maybe KPIT. Few of them to research with one of you. Where are the rest of you going to go? There is no job. If you go there, start at the lowest level like any person. If you're ready to do that, fine. But where is that PhD thing coming? What happens is when even if an industry wants to take some PhD, they'll think, what do I do? Okay, run this area. Maybe I want to start something on hydrogen generation. They will take you. You have worked on an electrolyzer catalyst. Okay, what are you going to do for the industry? You are working on electrolytic catalyst. When you say, I know everything about catalyst. He doesn't want that. He wants you to say, can you set it up for me, a full R&D unit on this? Therefore, it is your job as a PhD student to be aware and be accountable Now I will tell you what I mean by aware and accountable. Aware, you are working in one small, you have to narrow down your problem because you are doing a PhD, right? You have to give, what is it, at the end of the day, when you finish PhD, you have to give some contribution to the scientific knowledge. Then it's over to you and you get a thesis and all that. Well said. But you have to be aware. What happens today in our country is 90% of the time, the PhD student is only working on that small project. 10% of the time is for taking a bath, going with parents. That's all. Because that's what is told to us. PhD career, see here and there, PhD. And that's what the faculty also want them to do. I think you need to change that. You need to make it 70-30, 60-40. And I'm not saying 40 of that time go around and see a movie. But there is a lot of your own area. If you're talking about catalyst, will you what is an electrolyzer? What are the different type of fuel cells? Where are they used? What is the good situation? What are those? At least do a little more. And on top of it, please understand what you are. Okay? I will tell you what a PhD student is. You never have heard this. You come into PhD with zero expertise in that area. By the time you finish your PhD, your faculty considers, your supervisor considers you as an expert in that area. From zero to expertise. Which lab has all the super facilities? Hardly any in the country. Okay? You know how to work with the least resources, how to do jugaad in making a good experimental setup. All of you know that. We agree? All of you at some point or the other done that. So you know how to work with least resources. All right? You know how to manage your bosses. You know how to manage people who are reporting to you. When I say reporting, the lab, the office, sign karana hai, I will take him for a cup of tea, sign karwa dega sir se. Right? All of you know that. So you are very good at people management. Agreed? You are very good at confidentiality management. You will go to a conference, talk about your work, and you will not tell them what you have done. You will say everything, but they will not know what you have done. They cannot copy it because you are extremely good at management, confidentiality management. Agreed? And then you also know how to network. My this thing is not working. I know that lab, that person operates that, he will help me. Agreed? You know which lab, what person is there. You're networking. Unfortunately, until you finish PhD. After that, unlike the IIM graduates, they do this year, this batch. How many of you know PhDs of this batch? You don't know. IIMs know, all the IS officers know, but you people don't know. But you are very special, you completely forget. And now I'm coming to what you are. Because you are all this, an MBA who learned this after he finishes MBA, you people are learning it in 4 years as a case study. You are learning to start from zero to become an expert. You are learning to explore different areas. You are learning to build something with least resources. You can solve any problem with least resources, anything in the world. I know how to do it. You have very good networking. You know how to manage your bosses. You know how to manage your juniors. You know everything that an person does. The only thing you probably don't know are those buzzwords. Stakeholder meeting. I learned it after I went to really, because you don't talk about it. You don't use those words, that's all. You need a little, maybe when you submit your thesis, 2 months course you do on financial management, learn all that, you're very good. But you don't know it. And therefore you don't give that perspective when an interview is taken. Then why would they take you? Aren't you the best person to be the strategy manager, R&D strategy manager? They are the ones who will know. I'll finish. So they are the ones who you are the ones who will tell the industry, I think this is the way to go. This is the academic partner you have to choose. This is the project. There is a big problem. You know how to bring it down to an academic problem statement. So all I'm trying to say is Please know yourself. Please, I know we talked about various technologies. I'm talking about yourself. I think you have to make yourself ready for the industry by finding out what is it that they want in your area. Don't restrict yourself to that one small area. Then you will not be industry ready. I'll stop here, and I'm not going to talk about technologies today. I can go on, but I want to wrap.
Thank you. From the applause, it's obvious that it was a very, very good motivational comment for all of you. So I think since watch is running ahead, I will request Mr. Hemant, who is from Siemens Limited and head of manufacturing for low test switchgears, to share his thoughts with the students here.
Yeah, thank you. Story. So the biggest challenge is in shortest time. Side, I myself as the idea of adaptability. But I'm really proud about that. Although I've talked about, but in the kinds of scenes, I could achieve. It was run by an scientist from science. In fact, science is a reciprocal of and science is the guy that found the industry and the first practical generated model. So we are the and so technology is when it comes in a big form, it's a revolution. So we have industry in fact, I'm quite sensitive about industry development, and that is what I would like to message. Because private industry sponsored cost of 4% of budget. And the industry is coming from 4%. The 2% out is coming slowly back to 4%. Since the capital are still capable of slavery back. And that is coming back now. And India should become the east of China, east. And that is exactly of career experience. So that and foreign companies, Asia Pacific. So this is a great success of India. When I look forward for carry this in future, and the ultimate goal is to come back. So was last years, and then we will. So if I just say which is some iceberg. You can see the iceberg. So what happens? You can see a lot. That goes and that goes. So and every time something happens, so us well. And that is also I try to it's the purpose. Unless the purpose is clear, that is the percent. Don't go for the sake of achieving some prosperity. It has to be backed by purpose, and purpose comes with the question why. And so asking why. First, ask why this is happening, and then let's so that so that you so that's so I would like to say in the shortest possible time. India.
Thank you, Mr. Navika. So we have already received two questions from audience. First question is from Cycling Panda. It's related to influence of AI. So I just talked to Dr. Mantu Kumar. He says he will take up this question. Please.
The question is how can we address the influence of AI in job ecosystem and engineering world? I would say you get up in whatever you do in it. There is no other function but management is others moving on. So artificial intelligence is going. There are two aspects of that direction. I constructive. So let's focus on the positive side of the artificial intelligence. Certainly, time. I certainly understand. So there is as I said, jobs. You can so just questions. Okay. Yes. So, India's largest ways all groups. And to that, a strong collaboration between industry movement collaboration between industry and academia. It is very long back. What happened is industry became concepts because it became their balance sheet so So industry is share as a result, academia could but it has certain challenges because the compliance of something functional so I can be constituted or such right. Sir.
Thank you. To be fair to Sai Panda, he has addressed that question to all the three panelists, but because of shortage of time, I'm just restricting here and taking up the second question from Shujit Himanshu. This is on rise of India and China, comparative rise. Answer is partly political, partly social, But still, we'll try to answer this question. And Dr. Anuradha has agreed to take up this question. He has not pointed out to any particular person.
But I will, to start with, just quickly read out. It says, essentially, China was at the same stage, but today we are miles apart in terms of R&D, innovation, etc. So how do we bridge the gap? That's what the question is. This is the time to bridge the gap. Forget what has happened. This is the time to bridge the gap. The government is very supportive of that. The industries are looking at the academia to help. Okay, the academicians lose this opportunity, we will be way back. We have to work up. I'm now talking on behalf of, as an academician, and I will give you an recent example. The industry goes to pick up. First of all, best is to have startups. If you have innovation, please try to make a startup. And the startup is not because it's great and each one of you become businessmen. Startup is a very good way of commercializing the IPs that you are making to a level where it can be to the bigger technologies. It's very, very important that you take that up, all right? But at the same time, when industry comes to you, remember it is time bound and there is nothing called as I will manage it. It has to be perfect. Okay, you can of course say it's a pilot and we need a lot of pilot things and all. Money is there, grants are there, government is ready to give you money. So there is no excuse. Please buck up and do it. That's the way I'll put it.
Well, I think walk is sticking ahead, but I'd like to end with one particular suggestion for the young scholars. When work on a particular topic in PhD, there was a hint of this in what Dr. Anuradha said earlier. Based on the postdoctoral fellows have come to BRC and there are some who want to stick to the same topic in which they did PhD. They don't succeed. There are some who think of the PhD as a part of training. For example, take the case of a high energy physics person. He deals with a lot of computational tools. He can use those computational tools in many areas. There are cases which have been there's a magazine, CERN Korea, which comes. It clearly says many of those who worked on high energy physics, they are going to stock market and succeeded because you meet the same tools there. There can be a person who has worked in experimental condensed matter physics. These people use a lot of instruments. That knowledge can be applied across several fields. You look at your PhD as a way you have been trained in so many things and use that training to a diverse field, you will be successful. If you want to stick to the same area, success may be there or may not be there, you will be uncertain. With this, and keeping the look at the clock, I stop here. Thank you, and thank you to the organizers for giving us this opportunity.
Thank you, speakers. As is customary, we have a small token of appreciation for you all. May I invite Professor Kamachi Mudali to please hand over the mementos. To Dr. R.B. Grover, Member, Atomic Energy Commission, Distinguished Professor Emeritus, HBNI, and former Principal Advisor, DAE. To Dr. K. Nandakumar, Chairman and Managing Director, Chemtrails Group. To Dr. Anuradha Ganesh, Founder and Director, Arantri Consulting Services Private Limited.
Thank you so much, madam.
And to Mr. Hemant Narvekar, Vice President, Head of Manufacturing, Low Voltage Switchgear, India, ASEAN, Africa region from Siemens Limited.
Thank you.
Thank you, everyone. Can we have you all for a group photograph, please? Anything, whatever. you prefer.
Thank you.
Thank you all. We have one more interesting session before we break. For this conversation on medical health, life sciences, expanding horizons in healthcare careers. The healthcare sector is rapidly evolving, creating diverse career opportunities beyond traditional roles. This panel will highlight emerging pathways in areas such as digital health, biotechnology, public health, and healthcare management. Experts from academia and industry will share insights on future skills, global opportunities, and how young professionals can build impactful careers in a dynamic healthcare ecosystem. Please join me in welcoming our speakers on the dais. Dr. Sudeep Gupta, Director, Tata Memorial Center, HBNI, Mumbai. Dr. Ramakant Deshpande, Chairman, CII Western Region Subcommittee on Healthcare and Life Sciences, and Chairman, Asian Cancer Institute, Kambala Hills Hospital. Dr. Nitin Dharmadhikari, COO, Sun Pharma Advanced Research Company Limited, and Dr. Rukshada Sayada, Chair for Women Mental Health, Indian Psychiatric Society. Thank you, panelists. Dr. Gupta, may I request you to take this forward?
Good afternoon to everybody. And first of all, on my behalf and on behalf of the panelists here, we would like to thank the HBNI and CII for the privilege and opportunity of being here. All of us are under some performance anxiety because I'm sure the hunger pangs have begun and the hard stop is 30 minutes past 1. But we will see how we will carry it along. So let me begin by saying that we could not have asked for more eminent panelists. They've already been introduced. Dr. Dharmadhikari on my left is the Chief Operating Officer of the Sun Pharma Advanced Research Company, one of India's most impactful life sciences organization. Thank you very much, Dr. Dharmadhikari. On my right is Dr. Ramakant Deshpande. He's, if not the finest, one of the finest cancer surgeons in India. Formerly a faculty member at Tata Memorial Center, now the chairman of the Asian Cancer Institute. Thank you very much, Dr. Deshpande, for sparing your time. Dr. Rukshada Sayeda, she's a very eminent psychiatrist and a psychiatry professional. She's been associated with a lot of issues, not only in her own domain, but related to women's health and other related themes. Thank you very much, Dr. Sayeda, for the opportunity. So we had a brief discussion. I think the panel should deliberate on what the audience wants. And I think the audience is largely comprised of young researchers and life sciences professionals who are looking to make a career as they go along. And all of us were once in your shoes. We did not know where life will take us. So we are here to share our experiences. In the older times, when I graduated, when Dr. Deshpande graduated, it used to be a doctor to a hospital or a PhD to a lab, and that was the career. But now you have science communication, regulatory affairs, drug discovery, biotechnology, artificial intelligence, and the interface of many of them. So to just put some light on all these issues, I will request my colleagues here on the dais to make their opening remarks, but I will remind them once again that the hard stop is 1:30 p.m. So we will begin with Dr. Deshpande.
Thank you, Subir. I'm Dr. Deshpande. I'm a cancer surgeon. The rationale for me is that I was born in the last century, but
have proved to be of lasting value through this particular century. Being there, seen a lot of things and understand the value of a lot of things. As I understand, I think most of you are not directly doctors or connected with MBBS or MS or MD or anything like that. And we would like to explore just to have a view of how exactly your life can be applied for these particular things. We're talking of healthcare now. Your session was something which was industrial. So after you leave the medical kind of options for the career, the other non-medical options are tremendous. If you see, there are more non-medical options in the healthcare today. Health basically means that basically one of the four things is the physical health, mental health, social health, and spiritual health. Everything is still in the healthcare. So physical health, obviously the doctors will handle it, along with the help of others. The spiritual health, somebody is don't talk about the Baba and all that, but otherwise so how do physical health, what we have to do is to what we do today. Large plethora of knowledge today. How have you come here? Basically because of the analysis of the data. There is to treat patients to as time goes by. How does this come to be? It comes to by informatics, data informatics. You collect the data of thousands of patients, put it in trials, you find which is the best way of that particular thing. Not all these things are done by doctors. A lot of these things are done by other associates, which are there in the other sciences. The data analysis, the algorithms which are built to identify which is the best line of this thing. The large data analysis by, for example, the genetic studies which are done. Well, maybe between 8,000 and 1 lakh genes. So there will be in each of these things, specification for certain disease. Then in the medicines, will act on some, will not act on some. So we combine these things to identify this scientists, and that is what you can actually have a different level. So the bioinformatics is there. Then there is informatics, identification of disease patterns, so the geography of the country, the local factors, etc. All these medical things which are there, which actually come. The genetic counseling, the counseling parts which come actually advising the patients of various lines of treatment. Now, why should I, as somebody who studied physics, or be interested in medical field? See, if Harvard or Oxford, I've shown you that 20% of doctors. Institution. If you analyze, Harvard has a basic science laboratory where basic sciences like come, the leading science doctors like that I'm able to cancer patients, should become successful, should not be successful. So the genetic studies done, the evolution done, which are and this back to the molecular diagnostics. Now, when you look at the diagnostics, the kind of contamination that report right after these conditions have capability analysis. That's something that which can come actually from you. Some of the topics that you can write about, discuss about, we are understand. So, but this is the far more accurate. So even the data analytics, not something which you can do, but it's something different. You need to the genetic engineering, which is there. You can actually that manufacture physical organs, where the tissue is concerned. You can do tissue model. Today, how do we decide actually, how do the pharmaceutical company actually identify the drugs? He conducts a trial. It costs him almost about hundreds of thousands of patients, 5 years, 7 years. You can actually create an artificial human model. And that he will try to do that. He will with an IV drug. So all these particular things you can do genetic identification of the data, finding out the best kind of this thing. So you can identify, you can coordinate with your doctor friends, you can coordinate institutions, something like hospital, or various other institutions which are there. Institutions interact. What is very important is keep reading, keep listening, keep talking. Don't somebody call your friend. It doesn't matter who calls who what. So interact. That's the but what interaction. So this is how you can actually further your career.
Thank you very much, Dr. Deshpande. We'll request Dr. Dharmadhikari to give your points of view.
So thank you, Dr. Gupta. And then when you said that looking at the audience, we were in the shoes. I just went back to 1989 when I completed my PhD and went to Europe to do postdoc and came back and was wondering what to do in this with this qualification and with this experience. So I went to a mentor. I wanted to tell you a story. There was a mentor who was in the pharmaceutical industry for a long time. So I went to him saying that, okay, what should I do? Person told me this research and all that is a humbug. Nothing will happen in India. You should go back to manufacturing. You should join manufacturing because you are a PhD. Most of them are the graduates and outshine there. That's what was his advice. I learned, rather, I listened to my own heart. Okay, I said, no, I want to do research. I continued in research. And at that time, of course, I never thought that I will be leading a company which is doing basic research in India. So it's first advice I have for, I will say rather first suggestion I have for you guys is listen to your heart. That is most important rather than saying that, okay, Dr. Dharmadhikari came here, he told me something, so I should do it. Don't do that. Listen to what your heart is saying. That's first point I have. Now, when I look at the skills, right? So usually when we do our PhD, we have some, okay, we develop some kind of an expertise, we work on a project, we believe that in depth. That's very important, no doubt about it. But the things have changed, the way Dr. Gupta, Dr. Deshpande has said. The things have changed. It's not like, so when you look at your skills, when you were there, when I was looking at my career, I was looking at my skills like this, okay, so it's more like a depth. That's what I said. I know pharmaceutical sciences and I will excel there. Today, I don't think it is, that will work. You need a T-shaped skills. You need your depth in one area where you are working and then breadth into the other areas because it's all now interdisciplinary rather than saying that, okay, I am a physicist, I am a chemist, I am a pharmacist, I am a biologist, but that's not sufficient. The world is such, and then today research or I will say any activity, it is more interdisciplinary activity. Collaboration is a part of the story, and I cannot know everything, right? So basically collaborating with the colleagues, doing research or doing it for that matter, because you are guys are all doing PhD, probably you are aspiring to do the postdoc, and then of course some people will stay there, some people will definitely come back, and I hope most of us will come back because I believe that opportunities are better in India than outside, right? So outside world is a bit dynamic, but of course India is stable, good economy,
Okay, rising economy. So naturally, there are lots of job opportunities which are there and which will be created. That's how it is, right? So I think that's my opening remarks, Dr. Gupta. But I think we will hear from other panelists too.
Thank you very much, Dr. Dharmadikari. Dr. Saida.
Thank you so much. Of course, they bring in a woman to have the last word. Very smart. So it's an honor to be included in this panel and a pleasure to be here with you guys. Just because, and huge shout out to CII because of that, I come back to the campus and visit again. I'm also excited because right after this, I'm going to go and look in the psychiatry department. I have friends and colleagues there, so they're waiting for me and I'm waiting for them as well. I'm a clinician. I am only as good as I have the tools that I have, right? As an evidence-based practitioner, I am completely reliant on the evidence that's presented to me. Yes, because I'm a clinician, that same evidence-based practice then becomes practice-based evidence as well, right? So then I'm really excited to be here. What I may not make up for the eloquence and the advice that my colleagues have shared, I promise you I'll make it up for in passion and enthusiasm and hopefully a little bit of motivation. It's a symbiotic relationship that I'm looking at, right? Whether I'm looking at you guys from a biotech background, from a AI background, from a pharmaceutical background. Again, I need you as much as you need me, right? For both of us to be successful in terms of service to humankind and service to society. And for me, particularly service to healthcare industry. So I'm also looking at I'm only as good as how I think and how I feel, right? So from a psychiatric perspective, from a psychiatric care perspective, I'm also very excited to get to know from you guys, what are you all thinking? Because brain is one of the most understudied, underdiscovered, under-researched organ even now. And that's like the center of our entire system, isn't it? So when I'm looking to you guys, and I'm excited about what you guys are bringing to the table. What do from you and what can I learn from you? I need to know more about the brain. I need to know more about human nature. I need to know more about society in general for me to be effective at my work, whether that's it as an individual standalone clinician or as healthcare policy perhaps, or even an academician who's teaching and imparting knowledge of evidence-based practice to other people, my junior colleagues. So looking at healthcare, right? I think about, yes, research, but also implementation. Right from even simple thing like electronic medical records. That's the need of the hour, right? That's something that all of us have to do. Not only because the income tax is going to ask me for my records, but also because that's how I'm going to learn. That's how I'm going to share my insights and my knowledge with my colleagues. And unless we share, we don't grow. Unless we share, we don't learn. So right from AI-driven industry to help me do my everyday work, to also have more innovation in care, right? From a psychiatry, even from just looking at a very niche psychiatry, I'm looking at AI-driven data for providing care because psychiatry, again, is a very human resource poor, finance resource poor, infrastructure resource poor. So how are you guys going to help me do my job? But only a few thousand psychiatrists in 1.8 billion population. So even if you're looking at this industry, and frankly, we should be looking at this industry because the world is looking at it as well. A little bit thanks to the COVID pandemic, and after that, a lot of it because of AI as well. So there's a huge amount of innovation going on in that direction when we're talking about even somatic therapies that when we don't have enough medications and drugs that Dr. Dharmadikari hasn't given us yet, and we are then also looking at right from the ECT to the deep brain stimulation to RTMS, all of that has come from you guys. It hasn't really come from us. We just kind of like putting it in practice and holding it for use for the larger population. That's where you guys come in, right? I can't do anything nowadays apparently without AI because I need to know what AI is doing so that I also understand how that's impacting everyday life of people that I'm treating, but also how my junior colleagues are using it. Whether we're talking about writing methodology for a research paper, whether we're talking about just framing the email that is sent to the editor. So even from that perspective, but of course, if we're only looking at generative AI from a large population and not something that is particularly directed towards healthcare, a lot of it is going to get lost in translation as well. So all of this, whether again from a grassroots level, whether we're talking about epidemiological data, all of that is something that we rely on you guys. And there's a long scope yet in the field of healthcare, and particularly psychiatry, that you guys can definitely come up with. And like I said, tell us what your ideas are, and possibly we'll tell you whether that's viable or not.
Thank you, Dr. Saida. So I think the best way to have a discussion from my limited experience is to engage with the audience. And there is somebody, Usha Patel. Can you please stand up and state your question? Although I have it here, listen to it from you. And then I will direct it to the appropriate panelists. So that's from CES. So please.
Okay, so sir, I wanted to ask, like currently, if I'm a woman doing PhD, so where should I exactly go? Whether a job which is good in government job or a industry job. So right now, I don't know exactly what I'll be doing after my PhD. So I wanted to know what is more good, government job which is more secure for a woman, or an industry job which might open more opportunities.
You literally have $1 million question, and I tell you, it is a very hard question to answer. There is no one answer, but I will request Dr. Dharmadhikari to weigh in on that.
So I think when you look at government or an industry, I don't see any real difference there, because see, usually people understand government job is secure, and then of course industry job is little this one, and then there are many multiple differences. So my sense is that it doesn't matter whether you take a government job or an industry job, because you are asking specifically because you are a woman. I don't think industry is harsh with women, right? So my experience is women are very happy. They are also growing in industry, and I can say that, and they reach to the highest position what is possible. So we have a colleague who is a woman, but she is heading one of the very important, I will say, functions in our company. So don't get confused between government and industry. I think what is important, most important, is that wherever you go, you do well. That's very important. Saying that, okay, I go to the government, I do well, and then I go to the industry, but I do well. So I think focus on doing well rather than asking a question whether I should go to the government or industry. That will be my advice to you.
Okay, well, so question is a good one. Yes, of course.
Right. So I'm a woman.
But very briefly, we have 10 more minutes and we have 5 more questions. So
Yes, I'm going to flex a little bit and tell you why I can give this answer. I've been working with mental health and perinatal psychiatry for the last 9 years in the Psychiatry Society level. I'm the past chair of Women's Network in CII Maharashtra chapter. I'm also a mentor and an advisor on a lot of women's platforms, particularly like Led by Foundation and all of that. When we're talking about women and choice of career, it's never as simple as what am I good at? Right? This, of course, applies to everybody. But having said that, when you're a woman, ask yourself, what do I want? And what do I want is a loaded question, because it's also about what do I want career-wise, but what do I want about what do I want from a personal point of view as well? Can you do this? Right? Do I have the capacity, ability to do this? Not again, because based on your skills, but also in terms of what your home looks like, what your subculture looks like, what are expectations from you, and what are your expectations from them. The third thing is, do I want to do this? Again, if you're not motivated and if you're going to be unhappy for a majority part of your 24-hour day because you're at work for a majority part of the day, that's not really helpful to anyone, let alone yourself again. And then the next part comes in, do I have to do this? Yeah, maybe you have to do a job. Maybe you have to bring in that amount of paycheck or salary or package or something as well. And then comes the strategy. How do I do it? No woman is going to be able to be efficient in any aspect of their life, even if I'm a homemaker, unless and until I have a community, I have a village. And the village is not just the number of people I know, the village is the number of people who actually show up for what I want. So wherever you go, sweetie, see to it that you ask for help. There is absolutely no hesitation for that. And if you feel that a government job is secure for you and that's what you need for your needs and for your family's needs, go ahead and do that. But choose your family, that whether somebody that you marry into or some people, the people that you work with a lot of care, right? Because a lot of their attitudes and beliefs is going to impact your decision making. I do want to be somebody who has two jobs, one outside and one inside the house. That's what my mom taught me. She's a 10 standard educated person because her village didn't have college. Yeah, absolutely. Go ahead and see to it what you want and ask for it. Sorry, I know I was a little long.
Thank you. I think the applause from the audience means that it landed absolutely spot on. So, Sharada, I will take the moderator's privilege to read out a question, but please stand up, let everybody see you. You are again from SEBS, and I will direct your question to Dr. Deshpande. And I think she has a very good question. Could you please speak about the present day scenario of having a multidisciplinary healthcare setups? Where do scientists fit in?
It actually, diagnosis proves to identify the best way forward, both for women, and rehabilitation, or rehabilitation of that individual back into the society. So the medical like cancer patient, we would have a surgeon, we would have a medical oncologist, we would have a radiation oncologist, we would have a physiotherapist, we would have a psycho-oncologist, so on and so forth. But we also have somebody from the biochemistry lab, the lab part of it, the medical diagnostic. Now this medical diagnostic is something which actually, when we say that it's part of it, essentially in our process it's alien to us. It's absolutely, it's left, but so much about what analysis, what is going to circulate lab, which is called medical diagnostic lab. Inside, we saw a lot of see industrial machines, a lot of elements, so on and so forth. That is actually very important. Secondly, clinical trial. Clinical trials essentially are very scientists. And diagnosis on that particular thing. Then counseling. So when the counseling, they are the people actually genetics. The genetics essentially medical diagnosis, that's the counseling part, which means that it has to be so this is so what happens to the communicate has to be so when health policy makers, he sees patients now so the national cancer grid. National cancer grid just see national cancer grid. Cancer patients, and we have flat cancer patients out of that particular thing. Through the cancer grid. He doesn't treat all of it himself, of course. There's a time when it's treated. So, but so great amount of big data analysis, then show this thing to decide about the policy, to decide the healthcare policy of the country. You can't do healthcare policy of the country to be sitting there. So all these particular things come in. So that's where scientists, people the picture. Within instrument and within medicine is not singing a song. It's basically an orchestra. The doctor is a conductor of the orchestra. He just moves something which is of a music which is written by somebody else. But is equally important. And quite often, you know, the violin player or the drummer makes more money than the doctor.
Very nice. So I will just add to what Dr. Deshpande said. In Tata Memorial Center in Mumbai itself, we have positions about 75 to 80 positions of scientific officers, and they are an integral part of the health team. So the next generation sequencing based on which I decide to give a drug or not give a drug to a patient, the germline testing based on which I find out whether hereditary predisposition syndromes happen or not, and many other aspects, molecular microbiology, etc. Everything is done by scientific officers, and they are the masters and experts of that. So scientists and scientific officers are an integral part of the healthcare team. And like my colleagues have said, physicians are only the tip of the iceberg, but the iceberg is comprised of many other individuals. So thank you very much, and God bless you. So, very good question. Perhaps the oldest question in science. Ashish from Actrek, can you please stand up? Ashish, you never asked me this question while I was in TMC, but let me read your question from here. So, Dr. Dharmadhikari, for you, how can basic science research be converted into translational research? Okay. Second, how to remain motivated when it does not directly get translational? I think very important question. We should give him an applause only for the question. And that was the loudest applause. Before I ask Dr. Dharmadhikari to say something about the first part, let me say, you know, I became a doctor. I was always very fascinated both with physics, mathematics, and also a little bit with biology, because I wanted immediate gratification. You know, scientists are for the long run. They make fundamental changes to how, about our wisdom about nature. And you know, as physicians, we get immediate gratification because we see the results the next day. So, Dr. Dharmadhikari, how do we become translational and how to keep ourselves motivated?
Sure. So thank you very much. I think that's a great question. And that's where we are also really toying with, but I will try to answer your question. So when you look at the basic science and then when you come to the translation research, see, translation research cannot happen unless and until you have a basic science. So for example, in a drug discovery, unless and until you identify a target, right? Saying that, okay, this is my target on which I want to develop a drug for. And that is usually when that is the most difficult part. So currently, when you look at the capabilities in India, mostly we are talking about a translational research. I will bring target from somewhere and then I will do the research. That's what is general. Of course, there are exceptions and there are definitely good work which is happening in India today. And I'm sure that another 5-10 years we will see that change here. So I think if you identify a target, then you are participating in a basic research. Now, converting that target into a product, doing the various studies, you are doing a translational research, right? That's the difference. So, from the point of view of basic research, there is no doubt that this is the most important part of it. And everybody is having today a lot of hunger. I am sure that people in a basic sciences will get lot of respect going forward in the Indian industry or Indian ecosystem. I'm sure about it. So it's question of time and mature, the whole system getting mature. Now, it's also possible that there are failures, right? And there are always, because we always believe that the failure is a rule, okay, and success is an exception. That is what is there in that is the reality of pharmaceutical research, or that's a reality of research, any research. Now, Definitely, you need to keep yourself motivated. But usually, what we do, I can share my own experience when because there are multiple teams working. Now, one project will fail, another project, and we are working on let's say 10 projects, 9 projects will fail, and one project will definitely will succeed. Now, how do you make the whole ecosystem part of that success? Is the I will say way to motivate the people because it's not that it's that okay I have failed but Dr. Gupta's project for example succeeded. I also get a share of that overall story because I have also worked on my project. He has worked. Now it's a serendipity that one project will succeed, another project will not succeed. That's how we look at it, and that's how I think research should be looked at. So there is nothing to get, I will say, discouraged about when your project fails. Work on the next project. Keep yourself motivated because science is about exploring, right? Science is about exploring, and a day will come when you will succeed. That's the part of. So people will be also. They will success. They will celebrate your success. Today maybe they are celebrating someone else's success. That's what.
Thank you, Dr. Dharmadhikari. And I will also say, Mahatma Gandhi remains the soul of our nation. He once said that the journey is as important as the destination. So long as, we keep on enjoying what we do, even as physicians, we do not succeed in successfully treating all our patients. But, we also have to learn to enjoy the journey along with the destination. And I'm sure you will do well. Thank you very much, Ashish. Again, Dr. Dharmadhikari, this will be for you because these are very good and pointed questions. Dr. Reshma Reddy from ACTREC. Reshma, thank you very much for your question. She's asking, what do industry employers look for in PhD research scholars? First, publication, number of patents. Number two, expertise in the field. Number three, number of years contributed for a PhD degree, and can we have campus placement interviews for PhD scholars? So, Dr. Dharmadhikari, I'll invite you to ACTREC for a campus placement interview, and agree to it.
Sure. So I think first thing we will look at is the expertise. I will say that, okay. But of course, how do you prove your expertise? Prove your expertise by publication or by patents, whatever means you have, because those are the means for me to understand your expertise. But of course, your two things we will always industry will look at. One is an expertise, and second is willingness to contribute, because that is very, very important. I may be a great scientist, but if I don't have a willingness to work and really the curiosity about my, I will say the curiosity about the work, I will put it in. I think these are the two the qualities we are looking at when we are hiring the scientist. The one, of course, one is expertise, and the another is I will say willingness to work. This is a deadly combination. If someone has these two things, okay, expertise and a willingness to work, I think it's a deadly combination.
Chaliye, thank you very much, Dr. Dharmadhikari. Preeti Shivai from ACTREC. Preeti, where are you? Preeti, hello, good afternoon. So she's asked a very good question. What skills or specializations are most valued in the industry today? Let me start from my right, Dr. Saida. Can you please, in general, what skills are most sought after? And then quickly, I will go to all three of you on this question.
So when I'm looking at corporates as well, the people who are actually hiring, the people who are for the work, the life work that you're doing, they're looking at you not only from a skills point of view, but they're also looking at you in terms of how are you a team player, and also if you have leadership qualities. If you don't have leadership qualities, they're not going to invest in you because then you can't go further, and you don't go further, they don't go further. For leadership qualities, you definitely have to have a lot of soft skills. That's the term that most people would understand. And those are acquirable skills. Those are skills that one can learn. So how to calculate all of that? Practice makes permanent. So figure out what you figure out if it's good for you, figure out which is the best way of getting it. The question of motivation again is very, very important because the one thing that you want to do to be able to hireable and to be able to be emotional and to be able to thrive in your industry as well as your life is that you need to invest in yourself, right? What's good for me is good for my body, right? And that's definitely good for my career. So if you feel that you're not motivated, if you feel that you're lacking in some skills, or if you feel that you have social anxiety because of which you can't do group discussions, you can't do presentations, therapy works, life skills therapy works, and if you feel that there's burnout, psychiatry works, right? So invest in yourself, and that's the best way of moving forward. Because everybody else is going to respond and look at it like that because you all have mirror neurons. So that's what I'm going to tell you.
Three things: determination, persistence. Three things if you have, and whatever you do, you'll eventually likely to make a mark and succeed in whatever you want. You must know what you want. That's number one. It's perfectly okay if at all you don't know it. You'll get to know that as you go along. But whatever you do, these three things you must have.
Dr. Dharmadhikari, what?
I think, see, other than the expertise and other things which we talked about, we always look at willingness to work, one thing I said. Second is the collaboration, because I think people should be collaborative. That is what is there. Third, of course, most important is the communication, because these are the three things which are the basic of a, I will say, or they are key to the success of any person who wants to work in an industry. Of course, the emerging skills, when you talk about real skills, I think AI, digital data, ability to understand and then mine that data and correlate that is the one skill definitely currently industry is looking at, because that is where there, I will say there is a lot of confusion. How do you use it? But definitely there are also, we also understand that there are opportunities to use it and do it, right? So probably we look at it, AI is one part, but of course we also understand that human is a very integral part of that ecosystem. So AI plus human is, again, I will put it as a deadly combination. I don't think AI is not really having a meaning unless and until there is a human which is interacting with AI, and an intelligent and, I will say, very astute human. So human AI combination can be a really take us forward. That's what I believe. So those are the skills.
So in addition to what everybody said, I will add my 2 pence bit. I always suggest to the life sciences PhD students when I do their orientation session, please learn to code. Please learn to code, and especially to life sciences. It's a foundational skill in the modern world. It's a language that one must learn. The second thing that I always suggest is please teach yourself quantitative reasoning. And by that, I mean to say that we cannot take our data to somebody else to analyze. We must become the masters of being able to do it by ourselves. So those are the two other things that I will say. You will always be a better scientist and be able better to make sense of your own results if you're able to have those skills. So I think we are out of questions. We are out of time. If there are any last impromptu questions, yes, please get up. Short and sweet. Shoot away, don't worry, we can hear you. Be loud.
Because we're all academic and we're all trying to understand how problems relate to us. Because when I want to pioneering organization that also works in and other things, I want to know why are people gravitating towards? Because there are opportunities in the scope of industrial post-launch. Why do companies in India like Sun Pharma or Footla also offer such programs where we can get equally integrated into the industrial, where we have an industrial post-launch, where we actually understand there are such a big
Sure. So I think the
what she's asking is, why does industry not offer postdoc opportunities?
Sure. So I think the industry look at it a little in silos. I agree on that, because usually postdoc is done where you have your I will say mentor, and then there will be some interest of a mentor, and then that mentor will work on a project, and people usually he will take students to participate in that particular I will say project. In industry, what happens is there are industry projects, right? So rather than we say that we take a post I will say docs, what we do is we hire scientists, right? So I don't think there is a difference when you look at it. You work in an industry, you work in an industrial project, right? Now, there is a possibility, okay, I hire somebody as a postdoc, say that, okay, I give them a scholarship, they work on a project of their choice, okay? Usually, industry is shy of doing it. Industry wants to work on their project, their interest, and there are so many, I will say, aspects to it, right? Business aspects to it. So industry offers employment not as a postdoc. I also don't offer it as a postdoc, right? I offer them as a scientist. I say that, okay, join us, come to us, join us in a, let's say, join us in chemistry, join us in biology, which is a very emerging field. Actually, today, if you look at it, India is in dearth of biologists. We don't have good biologists in India. There are physicists, there are chemists. Physics, of course, I do not interact so much, but the chemistry I see there is a lot of chemistry, and which is historical. Story in India is from the chemistry point of view, it is historical, right? But biologist, we really find it very difficult to find a biologist. Good biologist, we really find it. So it's more like, I don't know whether biologists are there in the audience, but this is one skill which is really, I will say, you guys are going to rule this world. Biotechnologists and biologists are going to rule this world. Okay, because this is all something which is coming and which is developing in India, because this is something historically it was not there.
So, Harita, your point is well taken. On your behalf, I will again request Dr. Dharmadikari. So, I'll tell you, my first PhD student got an industrial postdoc in a company called Genentech in the US. Yeah. And the reason is that, those companies outside, they have breadth and depth of capabilities in many different domains to be able to do justice to a postdoc position. Indian pharmaceutical companies are coming of age. They build excellent capabilities, and I'm sure it will happen sooner rather than later. So thank you for your good question.
Sir, my point is we will offer you good salary and position. Okay, join us as a scientist. Okay, don't worry about a postdoc.
He's giving you an even better offer. Anybody else? Yes, madam, please. Very short.
Hello, can you hear me, sir?
Yes, we can.
Sir, my question is, I would like to know about the communities where we have to interact. For example, if I am a starter, a startup product, if I invent it as an engineer, so if I would like to interact with the patients, I need to go through some communities I heard about. This is a question what actually really I'm trying to address you.
No, I didn't hear the question.
See, most of
it is that if they have a product that they've made as a startup and maybe it is directed towards the healthcare, is there an ecosystem in India where that product can then be evaluated, adopted, and taken forward? Have I understood your question correctly?
Yes, sir. Yes.
Okay.
There are incubation centers, but most of them are for products, so they're not for medical products, etc. But they can still benefit from that.
For example, I made a medical sensor. Wearable coat, I have made it. So I would like to try it with
hospital. Guidelines for testing this particular thing. If it directly touches the life of the patient, then there are certain guidelines which it has to fit. If it's just important for therapy, then probably we could try it in the hospital. That is possible.
No, for that we need to approach some communities I heard about. Is that so?
So we can have a discussion later on. In general, as Dr. Deshpande said, there is no structured pathway. But ordinarily happens with the institutional collaborations. For example, Tata Memorial Center and the Indian Institute of Technology, Bombay have a collaboration. We have a collaboration with Bhabha Atomic Research Center. And then by mutual interest, we decide to take things forward. But as he said, there are several regulatory pathways to be cleared. And it is done in a collaborative manner. We can have that discussion during lunchtime and Dr. Deshpande is available.
Thank you. Thank you.
Trials without clinical trials. You see, so that's going to be unethical. So that's what both sirs are saying, that the ethical considerations, and you need to align with yourself with either academic institute or a research institute for you to be able to do that.
Thank you.
Any other question? You also have a question? The very last one.
The very last one. I'll not come with question, everybody. Up until now, most of the times the questions were posed from here and the answers came from there. I got one thing from Madam's side, that she wanted something to get from the student side. Now, my name is Kshitij Acharya. I'm a DBA's doctoral fellow working in BIC in nuclear engineering division. I'm part of one of the first startups to from the HBNI, like in BTech in any category to get incubated in EIC. And there is another group of friends. We have come up with an application which is live on both Apple Store and Play Store, Google Play Store, which is called Lumra, LUMRAA. It is 30 seconds of critical thinking that we have come up with. There's one question every day, psychological, philosophical, social, and the user will have to answer one. Only one objective is there, either yes or no. Based on all the answers, we generate, get insights depending on the data that we provide, the sociological data, but we keep all of that anonymous. We just been live for 2 months, and now we are engaging 30 to 40 people, like on an average, and we are looking to take it up on a bigger level. We are also generating very intricate and accurate personality profiles, where we think help out these psychiatric communities.
And make it brief. Yeah, that is so wonderful. We understood that they made an app called Lumra, and I request all of us to log into that, download our phones, and try it out today.
Yeah.
Thank you very much. Thank you. And we'll see how critically all of us can think. So with that, I will, on behalf of all of us, we thank the organizers for the opportunity, and we will end here. Thank you all very much.
Thank you, sir. Thank you, ma'am. May I invite Professor Kamati Mudali to hand over please. To Dr. Sudeep Gupta, Director, Tata Memorial Center, HBNI.
Wonderful session. Thank you, sir. Thank you for sharing your
To Dr. Ramakant Deshpande, Chairman, CII Western Region Subcommittee on Healthcare and Life Sciences, and Chairman, Asian Heart Institute, Kambala Health Hospital. To Dr. Nitin Dharmadhikari, COO, Sun Pharma Advanced Research Company Limited. And Dr. Rachida Sayeda, Chair, Women Mental Health and Psychiatric Society. Thank you. Can we have a group?
Thank you very much.
Thank you, everyone. We resume with our next session on foundations of high impact careers at 2:30 sharp. Thank you.
Gentle way of speaking, very nice. Perfect for your. Thank you. Thank
फिलर 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 है वहाँ पे अच्छा कम है इसके लिए
एक लिंक शेयर
संजय 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 ये पानी सब रिप्लेस करना पड़ेगा ये Grapple कर रहे हैं। One more follow. Three only. And lost suppose.
छोटे आहेत मोठे लागतील
हाँ ये तर VIP रूम मध्ये बोले इमर्जन्सी हाँ कहीं जागा बोली
And bites. दो कैमरा दूसरा Why I already explained
Yes, Ali.
How much? Hello, hello.
सीधा सीधा ना बोलो अच्छा but not a problem. It's the Telugu people need to be more much. Sarah, can कहाँ पे पेपर आएगा काम होना चाहिए ना उसके लिए बस हो गया It's the only word there. Say me, you find someone. Yeah. She's not feeling very good, but we might as well. Yes,
Good afternoon, everyone. I trust you all have had a hearty lunch. So, Professor, should we begin or wait for 2 minutes? Yes. Welcome back to the Research Scholars Summit on Employment, Entrepreneurship, and Startup Opportunities. For this conversation on physics and mathematics, the foundations for high impact careers, showcase how fundamental science enables careers in data science, quantitative finance, space technology, defense R&D, analytics, high performance computing, quantum technology, and advanced modeling. This session will emphasize analytical rigor and problem solving as drivers of innovation and competitiveness. Please join me in welcoming our speakers for this session. Dr. S.M. Yusuf, Director, University of Mumbai DAE Center of Excellence in Basic Sciences and former Director of Physics Group, BRC. Mr. M.S. Unikrishnan, CEO of IIT Bombay Research Center. Dr. Rajkumar Singh, Senior Director, Kalyani Center for Technology and Innovation, Bharat Forge. And Dr. Prashant Pansare, Founder and CEO of Intelligent Group. Please join us on the stage, sir. Thank you. Dr. Yusuf, may I request you to take this forward?
So very good afternoon. And we had very exciting morning session. And there you could see we have gone from chemistry to industry to health. Now we have come to yet another one, physics and mathematics. And first of all, I'd like to thank both HBNI and CII for organizing this great event. And I'm happy to be part of it. And thank you for the kind invitation. And I also take the opportunity to thank all the members of this panelist for their valuable time. Professor Kamachi, Professor R.V. Grover, Professor J.P. Mittal, all moderators and panelists of this session as well as the other sessions, and my dear colleagues from BRC, HBNI, UMD, CBS, and other units of the and all the other invitees. So today's session, as you all know, the translating innovative research into employment, entrepreneurship, and startups. And this is designed to allow the research scholars towards the ecosystem that would equip them with a broader perspective and future opportunities. So this particular session is specially designed towards the physics and mathematical research scholars. And semester buzzword seems to say that math is the language of physics. So we are doing physics and math in this session. And physical sciences has been at the forefront of this HBNI success, as you all know. Based on the high quality publications, the National Index 2024 placed in the third position of all the institutions in India and happened to the first position given for the physical sciences. So today, I will speak about artificial intelligence and data sciences. We are essentially speaking about mathematics in action. Concepts like statistics, calculus, power recommendation systems, fraud detections, autonomous vehicles, and modern AI models. Companies like Microsoft, Amazon, OpenAI actively hire mathematicians, statisticians, physicists to build systems that impact billions of people. In finance, everyone mathematics drives algorithmic pricing models, risk analysis, and global firms like JP Morgan, Goldman Sachs, Indian firms like Power Research Capital recruit strong mathematical minds to solve high-speed and high-stake financial problems using quantitative methods. So physics, on the other hand, powers industries that shape the future of the companies like NVIDIA, works on GPUs, semiconductor and quantum computing systems during possible of physics. For satellite systems, missile technologies, orbital mechanics, thermal space research, the organizations like ISRO and DRDO depend on physics. Without physics, everyone knows the space exploration, aviation, and other defense technology. The automotive industry depends heavily on physics and mathematics. Companies like Tata Motors, aerodynamics, material science, and thermal engineering, while designing the electric vehicles that are faster, safer, and energy efficient. So block theory and optimization mathematics are used in logistic and supply chain network for route optimization and shortest path algorithms. Companies like B2C Express, B2BC Express, Amazon, Flipkart use mathematical techniques to ensure faster deliveries and efficient operations every single day. So physics and mathematics build analytical thinking, curiosity, structured problem solving, and the confidence to approach challenges in unconventional ways. And that is exactly what the companies are looking for today. So to every student for project work, I would like to say that when you do research in physics and mathematics or further level subject in basic sciences, you are not just preparing for doctoral, you are preparing the future. So almost all technological breakthroughs, right from semiconductors to lasers to artificial intelligence to technologies, have originated from questions explored through basic research. And industry environments seek individuals who can think, identify opportunities, solve complex problems, and adapt rapidly to changing circumstances. And we have that in sessions. So today, for that, this physics and mathematics based topics, we have experts, and I will request all the three experts one by one to give their short opinions for about 2 minutes or so. Then we open up for the discussion, followed by we take question answer from the floor. Before we take question answer, we will be up to 35 minutes or so. Then we'll open up for question answers. Then after question answer, we will be having one more round that is called concluding rounds. Then we will be giving a consolidated opinion, and then we wind up the session. So first request Professor Prasant Pansari to give his opinions.
Yeah, for 2 minutes. Good afternoon, and thank you, Professor, for your insightful introductory remarks. Feels very nice to be here and seeing so many bright young minds who are aspiring to learn from these sessions and what can be ahead of us in today's I would say the turbulent times when we are looking at this kind of a geopolitical scenario, that what emerging India can be. So certainly makes us feel very nice to be here at the campus. And as Professor very rightly said that physics is a language of mathematics, I will just take that clue and say that physics and mathematics together is the language for writing algorithms for artificial intelligence. And what that means is, this is a one emerging area which is affecting almost every aspect of our living industry, hence education, research and innovation as well. Now, when we look at the applications of the science into these technological areas, and let me just give you some mind opener, so that we can discuss that as we progress. And we know that how the physics and mathematics in AI can actually help you, whether it is text processing or image processing, and how it is changing the way we are actually living, creating and consuming some solutions. And let me give you a little offbeat example. So we all have heard that how drones are helping, whether it is deliveries, whether it is surveillance controls. And I was actually at one of the agriculture summit, and we were talking about the agri-tech innovation. And purposely, I felt that this can be a very relevant example here. That's how this drone technology with image processing, location intelligence, climate change can help in crafting solutions which are very highly socio-economic impact making. So just think about the drones with the cameras and maybe a few hectares of farm, an organic farm, and where you would like to really sprinkle the pesticides. Now, the role of artificial intelligence algorithm can be that on the farm, probably you have some section where there is a decay on the plants. So rather than going randomly across all the entire farm, you sprinkling the pesticide, can you say that okay, only this 3.5% of the plants in the entire farm needs what quantity of pesticide? Can this completely be decided and managed by the autonomous system, and what we call as an agentic AI in today's term? So now think about it, that first you're talking about, the geo-intelligence. So which part of the world, what is the climate at that time, what is the crop, what is an impact of the climate on the crop? And with that kind of an intelligence, geospatial intelligence, you're combining that with your image processing.
Yeah, only this is just opening session. We'll take a very brief, then we'll come back to you.
Most certainly. So it's exciting times ahead as how the industry and academia can come together for doing this kind of innovation. And as an eternal optimist Indian, I feel that we're in exciting times today with our technological advantage. Thank you.
Okay, thank you for your opening remarks. Now I request Mr. Krishnan to give his opening remarks.
Yeah. I'm the industry into academia. So when you mentioned about industry academia participation, I used to be running a company by the name of Fermax, a fairly large energy environment company, for a period of 14 years as a managing director and CEO, then became a professor at IIT Bombay. Currently, I run the IIT Bombay Monash Research Academy, which is only for PhD. So I was told that most of the people are doing PhD. Am I correct in assuming that?
Yes, yeah.
Okay, I'm not asking you to hands, but I presume that way. So I, in fact, I feel that I should have done this job maybe 5 years earlier, in the 6th year of doing that. My ambitions did not to do that way. But I learned one lesson from the industry coming to academy that everything in advancement starts with science. Science creates technology. Technology creates commerce. Commerce creates economics. Economics creates politics. So that's the connectivity between science and politics. So I was on the path earlier of converting technology into commerce. And now I've gone back where the technology comes from science. So I've really seen that there are 750 odd professors at IIT Bombay, and Monash has got 6,000 of them. So I have a research intellectual capital of scientists available who can create technology. That's what I really work in. We are going to have completed 287 PhDs, currently about 181 of them do a PhD, and AI and quantum is a very important topic. And he did tell me, restrict yourself to only quantum. So I'll only do that. So, but when somebody recently spoke about we'll be talking about technology development and science, especially because there is a lot of attraction towards technology. On an average, 1.5 million students get into engineering in a year, 15 lakhs. That's more than the population of countries. I don't know who will get employed into that. Less and less into science. So somebody asked a question as to when is it the right time to get into science? And the answer that gentleman who's an FRS was that no, 20 years back was the best time to get into science. The second best time is now. And he told the second best time so on account of the fact that quantum. So quantum is a science. I'll recipe the other time go anywhere. So I'll talk only about that. Started somewhere in the 80s as a concept, and the first quantum computing came to be as a tool in 1990s. And day before yesterday, President committed a person who will spend all the money for wars. I hope it is not recorded over here. Has committed $2 billion for quantum development of his 1 billion is the IBM. And the balance to 7 startups. And all this is not as a grant, as shareholders in the companies. The first seed capital given proudly also for this specifically. And I have been working a lot on because quantum science forms a part of the researching in my academy. There are multiple students who are working in that. I get actively involved in that. So there we have realized that currently the size of a quantum computer, which is functional but it deployment, is the size of a car that you see in the parking space. Which is expected to be issue computer. I remember when I started my career in 1982. We had one IBM PC 282 in Thermite's office. Only the directors and this had a room, AC room, and we were moving their shoe before entering that room. So the quantum computer could be said, but I presume by the time it was getting to that, it will be the size of a laptop. So we'll talk about it in the applications later. I also serve on the boards of multiple companies, very large organizations, and with the government of India, multiple advisory capacities related to science and technology development. I'm able to relate to all of you now, which I was unable to earlier. So that's it. Looking forward to a good evening.
Thank you, Mr. Onnikrishnan, for giving your valuable remarks. Yeah. Now we move on to Dr. Rajkumar Prasad Singh.
Students. Science. Scientific in this case, which is used when that comes to the people thing, which we are here scientific development. Physics and mathematics intervention into effects. So many things, and all. So I will give some very simple example. Startups are developed actually. So there's some things and some produced. Okay. Now we see so critical condition. So how do we question some matters and we close to silence? We have to be familiar with that. To some often familiar with that. So two books explore this country. That was not the physics of sin. And so we can about that to solve this problem.
I want to so started students who are creating this startup and watching people survive and startup business. Many buildings have been shortly. I think most of them. I have an education of physics and mathematics. See, when people develop the teacher says required forces and a machine gun, it will push you and you may fall down. That is not required forces. You know, when you find a real artillery, how much required forces will be there? The vehicle will go back and hit somewhere else. So, you have to calculate that. Fire. The bullet how in the target, how far in the range of power it is striking. So after use of the barrel expand the little even markers. The accuracy of the barrel. So by also have the accuracy. And for that, we are getting some technology, coating in the barrel so that it doesn't expand and then we second thing is firing. What is the velocity, what is the temperature, and that will affect your accuracy of firing. And that all calculations, of course, to them into consideration, then we will find it. And it's not important. So I was studies too. Other than physics, signals and to signals in physics and works out there. Ropes and can now. When it's not like it's out to one of the demons, you go exactly look at if I give an answer about something, but on the other side of the something from here. So these are some of these. And not people are realizing about the base and blessing of it, and a lot of first and many are very important.
Okay. Thank you, Dr. Rajkumar Singh, for your remarks. Now, to initiate the discussion, I will just not questions, rather raise some points so that we can take the discussion forward. So first to Dr. Prashant Pansare, that for the benefit of our PhD students, so would you please give your point of view how fundamental science enable careers in data science? And I add that how to also bridge the gap between the abstract theoretical concepts, which most of the students, they have in physics and maths, and from that to tangible industrial applications in area like data science.
That's right. It's a very pertinent question, and it is changing the way scientific community as well as the engineering community, scientists, as well as statisticians and aspiring data scientists, we call them as citizen data scientists, how they are imagining the way to solve problems. And there, one is that what is most important in data science is three main things. One is your mathematical skills, another is a computational skills, and third dimension is your domain expertise. You know, the functional knowledge that you need to have to solve that particular industry problem. Let's look at the two aspects. One is your mathematical modeling skills and computational skills. So today, what is happening is these two things, the gaps are being bridged by the low-code platforms, where you don't need very extensive programming skills. And we say that, okay, these are your data tables. So your data tables, how do you effectively use your mathematical skills to build right algorithms, and how you can automate or orchestrate them in a easier and a simpler way. And then when you combine that with your uh, other scientific problems that you really want to solve. For example, you're doing, say, a retina scan with a robotic camera, how that can help you in translating the reading of the image and come out with what is the score, right? Now, if you take this as an example, earlier you would actually need quite extensive ways of programming and converting that image into the mathematical models to compare, relate the scores, and come out with the output, which will use for your recommendation or a decision system. Now, today, what is happening is there are AI tools, AI desktops that actually help you in simplifying the ways you build the computational systems, decision systems, or recommendation systems to automate that. And hence, the focus is very fast shifting, or it is funneling the innovation with a greater amount of speed. How can you quickly, solve these type of problems? And just to elaborate on this, let me share some statistics with you. India is almost 1.4 billion population country, and 7.5 people in India are visually impaired in the age group of till 20, which means almost 10 crore population in India is visually impaired. And we don't have a physical clinical systems that can actually do this investigation and manually prescribe what is the remedy. And hence, country like us need AI systems which will help in doing the easy ways of the robotic way of scanning the retina and come out with the decision recommended systems. And as the professor also said that there is a good amount of work happening in IIT Bombay and IIT Chennai where they're actually building these devices which are truly made in India by first lowering the dependence on foreign technology, making them truly indigenous, making them connected, right? And when you're connecting these systems, one is that how are you capturing the image? How are you processing that data? Where you are storing, how you're feeding that to the next system, and how then your computational systems are helping in extracting the vital data elements out of it, process that, push that into the decision recommended system, and then a robotic is actually instantaneously telling me that, okay, how much visually I'm impaired and what kind of a spectacle with what kind of number I want. Now, if you look at this from, say, concept to completion, probably a few years back, you would need a huge amount of computational resources, a lot of knowledge, resources, and teams to actually build this kind of a system. But today, thanks to the democratization of technology, thanks to open source initiatives and momentum, these things are easier. So now what happens is that when you're doing research and innovation, it is also very important, essential element, as he was talking about the technology to economy, how your research ideas can be commercialized or how they can be made into viable business ideas and propositions. Is that how can you do this, so to say, a workflow compression, which is the essence of artificial intelligence systems, right? And in that sense, how it can be more simplified.
Yeah. I'd like to get one more clarification from you, how the academy and industry can work together to train our next generation for data science.
So today what is happening is, let me give you this answer in two parts. One is, so to say, the IT glamour, because everybody thinks that, okay, if I become Python programmer, I can be a data scientist. That's a myth, right? Learning a programming language, it's like learning an alphabet. If you learn, alphabets, you may learn to speak that language, does not make you default shyer. शायरी के लिए जज्बात होना जरूरी है. You need to understand the domain knowledge. Hence, many people think that if I'm learning Python with some online course and use some tool, am I becoming a data scientist? So data scientist or decision scientist. At the same time, it is also very important that how do you build your team or consortium of the domain knowledge. most of the institutions, even enterprises, see that they build computational infrastructure for AI and data science, and a less amount of time is on the data literacy part of it, right? And being a data scientist is actually not only understanding how a tool operates or how you write a Python program, but it is how do you relate it with the problem. And hence that skilling, if you actually see, because probably it's a very glamorous, so to say, IT branch, today what is happening is that the scale of economics in that is making people become Python programmer and not really a data scientist. Yeah. What we need is that the culmination of the tools and skills coming together. And let me give a very simple example. Look at MS Office. 30 years back, they were small product companies acquired by Microsoft, made into one commercial package, and they were persona-based tools. Somebody wants to do a spreadsheet analysis in a finance function, there was a tool called Excel. If there is a salesperson wanting to make a presentation, there was a tool, PowerPoint. Now, all things put together, it democratized office productivity. Yeah. In data science, yeah, just a minute. So in data science, you need data connectivity. So is your data connect happening to your engineering data, device network, or machine, or it is an image, text, speech type of a data? So it also depends on your data type. Then comes in your data exploration, how you are being able to understand and decode that data. Then third comes in how are you being able to build your machine learning models, train them, and retrained with the continuous learning mechanism so that your output and recommendation systems are evolving. And then how you present that, in advanced data visualization so that you identify the patterns and correlate with the scientific outputs of this data. So now what we are doing in that space is that we have built India's first data science desktop software that actually helps in automating this entire process like MS Office in one single tool. And the literacy related to that is that how do you help people become a little more self-sufficient?
Okay.
So the shift is happening today from, say, IT skills to commoditize or democratize that skill so that the focus is shifting on solving the problem rather than operating a tool.
Okay. Okay. Thank you. Thank you, Dr. Pansari, because we have to take from other panelists. And now we move into Mr. Nikishan. So that to you, my point is that how this quantum technology evolving with regard to job opportunity, and that I request you to respond to this query with respect to Indian scenario.
I'll do that. How initiated are quantum science? Those who are aware of quantum computing, quantum sciences, you can just lift your hands up, then I'll decide how to do it. Okay, so introduce it and then talk about that. So because the difference between quantum computing is that it's qubits, qubits. So the difference between it is based on binary theories, 0 and 1. Everything in the world, data is stored in 0 and 1. Whereas in quantum qubits, it is 0, 1 or a combination of both. That's the first level, qubits. So the qubits, when you string them together, okay, the possibilities are that, say, 4 options, 2 of them 8 options, string of 100 qubits. I don't know how many so possibilities can be done. So to give an example, you've seen about this and you use some to get a way together of that. The way to do that, it will calculate the possible to find out the solution. So it will be a stepwise calculation done for it. But if you for this one, it will have a three-dimensional view. And then it will have all the combinations done. Qubits, and then you get one, you are getting the correct one. That is the correct challenge that all of us are facing related to quantum computing. That tested, you need to. And when this happens at submolecular level, sub-molecular level. So the smallest form of ability is a quantum. For example, light, the smallest form of photon. The photon comes and hits a panel, which is a PV panel, photovoltaic panel. It ejects an electron that right panels or solar panels giving electricity. So it's already happening in the world. The way what you see the world is not the way the world operates in reality. So whatever currently life, it is only part by mimicry. Getting back to the mimicry, that what is happening inside of the submolecular level, atomic level, subatomic level, is utilized for quantum sciences. In that quantum physics is the first one, because you have to understand what is happening at the submolecular level. And then quantum mathematics, because everybody calculates the algorithm, because everything in quantum quantum security, quantum computing, and then further quantum algorithm to be created. Where in the world? Because this is an India can lead the world. Many of your cloud, which is earlier desktops and computers, desktops, now become laptop, that's on the move. You can become computing the world, somebody lying around. But the laptop is the application, but still that will have a centralized supercomputing done, huge for it. But a micro quantum computer, just as I mentioned, about currently the size of a car, when it comes to the size of box size, will be able to last proven ones running is 14,000 times faster than the existing supercomputing. It's the speed that you can get in that one. So in that, what you need is purely mathematics and physics and materials. One item which is missed in the entire thing is quantum materials. It involves the kind of physics only. There is why I really mentioned about the science earlier is that second best time is because quantum taking everything in the world. AI is already started for AI to be functioning further. Imagine the right Q chip is much micro than what a chip that is micro checking. Just about the time the countries now started getting semiconductor manufacturing. There are 7 companies in data having their facilities started in the country. So I would say what are available engineers as an opportunity, maybe starting with some 1970s in the world, 1980s, 90s in India, it's going to be done with BC, MSc, PhD in science, mathematics and physics in India. Provided, please remember, conventional BC that is what I'm sorry, you are as good as a BA. If you're MSc, if you're working that, well, it doesn't make a difference. You're ready postgraduate or a PhD. Even PhD, I presume you're supposed to be trained in deep learning. You've done it, you'll be able to. I give one use case because I don't understand. I already mentioned the photons and the photovoltaic activity, how to calculate. In that itself, currently the maximum efficiency available is 22%. The best of the 20%, that's made with Panasonic panels. But a new research happening across the globe, including India, perovskites. Some of you have done, it's not so it's being done. It will be 30 to 40% efficiency. What it means is, all the energy given free to you by God, that is sun God, energy, only 20% is converted into electricity, the balance is wasted. So every year in the world, people are trying to get it to 530, 35. In perovskites, to calculate what will happen in photovoltaic activity, you have to go to photon to electron level, that is a molecular level. Only quantum science can give an answer. If I had to put that in the calculation, it could take to give a result. In quantum, if I had a quantum computer available at IIT Bombay, it can be done in possibly 1 hour. Similarly, think of a textile company. That's the lowest of the level of technology that it does, or outside technology. They use energy in the form of heat, chill, that is chill water, electricity, and multiple ways that use in that one. A combination of how to time it in 24 hours, each of the energy balance should be done. Today, there is no company in the world, the best in the world, doesn't have an algorithm for it. Quantum computing is able to be. So there is nothing in the world that will be excluded from that. Even the mobile phone, hand is already doing supercomputing, but then you get to the next level, multiple levels. So you guys who have taken physics or mathematics, don't stick to your area of research that you're doing thoroughly. Expand your, you create your own way and spectrum of understanding. There will be enough and more opportunity available. There is nothing that can be denied to you if you are a good researcher in this area.
Okay, so thank you. So if I add that how can academia better prepare in translating physics, quantum physics research into deployable commercial products?
First is, as I mentioned, when quantum mechanics are getting developed, it is getting tested, and quantum mathematics is going to create the quantum algorithm is getting trained. So train is waiting for PhD to be over or the course to be over. You can online courses, about it. There are quantum computers available free from IBM. A lot more available for download and start on that. Once you initiate or fire that particular gun for brain, a portal will open inside that where we collect information. I would say that there is opportunity for to become an academician with a PhD. That is a primary area. Yeah, this is going to be developing. Every university worth its salt in the world, including India, there will be separate departments getting created. Currently, it is embedded predominantly part of that into materials department, into mathematics department, and physics department. But they'll get combined later to a quantum development. Most universities will do that. Of course, it will be led by some companies in China, then to America, and then to India it will happen, but you can take a look.
That is what we need to wait till.
No, we can do it. I'm telling you to do that. Second is there are labs already available in Bangalore, Microsoft to everybody. I want to have the quantum department. In that there are species, they're only taking patients with physics and quantum materials experience. So you can get trained for that one. And third, I would say, if you come with your own quantum algorithm, don't give it to anybody. Do your own startup.
Yeah.
By every means, because you intellectually, if you get that kind of spark within you, and if you're able to convert that into something workable, and the use cases may be very simple. You don't have to look at it for food. It's a quantum provided the possibility for it. Because when you look at the waste management, the food delivery management, these are some of the most difficult algorithms, and computers find the right answer.
A lot of that. Yeah, thank you so much for giving the perspective. Yeah. Now we take the points from Dr. Rajkumar Singh. So to you, I say how fundamental physics and mathematics are useful in space technology.
Yeah, and aerospace are overlapping things because in aerospace you can passenger craft, okay, fighter bomber, there are some differences in that. Actually, I will start from because if you see high school book on physics, it always chapters like heat, light, momentum, electricity, and quantum theory. I love the book actually. Now, every part of physics is used, whether it is or in space. Because if you say heat, now heat is meters. We are treating meters or we are doing treatment of meters. All meters can be treated or accelerated. Because it will depend on the specific which is physics parameter, will depend on mass. And expansion also are presented different for different materials. That's also physics. So, heat treatment cycle theory. If we take the example of light, you have seen that 2 to 3 become converted to electricity. Electricity was converted to light. Now the reverse is happening. Light is being converted, the sunlight is being converted to electricity. So the plan is totally to convert one physics item to another physics item. So all the solar, everything is to the convert light to electricity. And science of light, all are in the play actually, because other than this different type of solar panels, now some solar, it is based on some other observant coating actually. That is giving 5% higher efficiency in silicon panels actually, because as perovskite we said, perovskite can give higher efficiency, but so far perovskite is not stable. Because it is working across the world to get a stable perovskite. So this is one of the examples. Sound, as I was telling you right now, the acoustic is very important because in naval warfare and acoustic is submarine small detecting floating object can get data how far the submarine there, how far the ship was there. We were almost on some science. We are facing a problem of gravity in the world, which is affecting our crankshaft. So we are using totally acoustic in that. Because when the machine cutting is going on, when the crack happens, that time there must be some acoustic sounds in nation. It will be very small sound. When we are trying to develop, I will think based on that, based on that analysis, that Tata will tell us that here you should reverse back so that can take place. So this I will go to share with you that without any propellant, without any explosive gases, you can fire the bullets with unlimited power. That is 90 grams have been developed and it requires more huge electricity so that capacitor network capacitor should be very large. That is why gas are mostly required in the city and warfare. Because if you want to use the ground, you carry some charge load on your generation. So, such a magnetic can melt the metal in the fastest possible time, which no other way with heat you can prevent it. But just applying high magnetic power, you can melt a material in a fraction of seconds. It is so powerful, and a lot of research done on those units, and special cell in the University of Texas working on this. So physics is applicable in space and defense, and when we even treatment of metals to see what is the heat transfer rate and how we can see design rate of cooling. For that, we not only water, oil, but a combination of water and polymer. And with change of polymer concentration, we can say cooling efficiency, and that cooling efficiency affects the microstructure of the material, which has total impact on final properties. Everything we look at from the point of view itself, because we are working on some technology around this target is without electron in this thing. The atom will come here and it will go and it will become some other place. So we will want to high level technology which are being used in defense. So application of physics and application of mathematics can be counted actually. There actually, whatever there is always some part of physics and other part of mathematics.
Right. Thank you, Dr. Rajendra Singh, for giving very, very insights about the application of physics and mathematics in the area of defense as well as the space technology. So now we'll open up for question answers from the floor. I have already got one question and I can start with that. So the student name is Somo from BRC. Could you stand up, please? It's there. Anyway, I can read out the question. In experimental physics research, we spend years solving complex systems. How valuable is the problem-solving mindset in industries like analytics, defense, and R&D? So, would you like to respond to this question?
What is the question actually?
In experimental physics research, we spend years solving complex system. How valuable is this problem-solving mindset in defense, let us say?
Yeah, and I told you right now that you are in the battlefield and you are having the thin lines. Suddenly, the weather has changed and there is a heavy wind. So we use the same parameters for firing your bullets from the big guns. Target will be missing actually. So you have to incorporate all the methodological data into your system through the modeling. So when you are having a method immediately corrected as per the weather condition today. For example, we were asked by an army to fly drone for 10 kilometers. And we took the summit, but that day the weather was very bad, wind was high, temperature was -30 in class sector and all. So we could achieve 8.5 kilometers only, and then the crashed actually. Now it is a deep thing that what failed actually. Did the battery fail? The battery was still having 40% charge. Did the controller fail? Yes, some controllers are there. Can you do stable at -30 degrees? So these are matter of research that what can affect at that condition. Somebody was asking me that India doesn't make cryogenic steel and we have to import. Right. Yeah, so cryogenic steel means the steel or material has to be smaller grain size. Because the theory, if you use some material, it should be fine grain material, it should be nanostructure material. And if you use for high temperature crystallization material, it should be coarse grain material. So theory is just reverse. So I told you that cryogenic steel can be but meaning that quantity will be less, so that we is putting investment, and easily can make it, but we are only into one product and we are not into flat products. And requirement will be the flat products. So we are somebody like Google, say, Tata's can be given this challenge. I think Jindal will be happy to take such challenge.
Okay. Okay, thank you. So we can. Yes.
Yes. In fact, see, physics somebody mentioned about problem solving is what does he know about anything? You are as executive and manager as you rise up is problem solution. Complexity that how to solve. Your mind is creating a natural algorithm to solve it. That's what you're getting trained for. So imagine that you are investment banker also to predict what this is the best share to buy. That's why we get so dollars from IIT after BTech also. Or maybe better. You have the ability to solve the problem. This is anticipated data limited. Maybe this is a parsimony. So when you're solving a problem, what I'm doing, simplest problem is to decide the solution. You have a lot of creation happening, which of course everyone is trying to for it now, but naturally can be created to solve. So that happens. What is the capability that you're picking from your PhD program? But great job in the industry.
Thank you. Thank you for adding. So we can take the next question. Yes, students, please come forward.
What strength they are looking low energy.
Yes. Yeah, madam.
Actually, material management is presented when advancement come up with modern material science, right? If we apply for the same phenomena, land, water, and air, how we can distinguish in the range of scale in nano and micro?
Scale between the land and the micro.
Yes, sir.
It depends upon the use case for each one of them. There are
If we take material management,
Materials management.
Yes, materials what we are adapting for submarines, adapting for aircraft or aerospace.
Yeah.
Or something which we are creating a vehicle on land.
I will answer this.
See, particle smaller than 5 micron, you can say nano actually. Above 5 micron it is macro. Below 5 micron it is considered nano.
Thank you so much.
Yeah, okay. Yeah, please.
Sir, my question is,
Is there a microphone?
Thank you, sir. So my question is like all the problem solving approach and all those things we learn in during our PhD or before for the CSI, whatever preparation we do. The problem is the industry don't recognize all these things as innate ability because when you go to industry, they ask proof of work, and most of our work is around a specific topic. So how to translate this knowledge to actually industry that yes, we are able to do problem solving, like in quant finance. Uh, like in engineering, physics students are definitely preferred, but after PhD, I will prefer. This is the big question. Like I'm not seen much
In the morning session, this was beautifully addressed by saying that your PhD problem may be very, very narrow, but you need to see around so that you are ready for that kind of situation.
But you're more suited to do that way. But it is not yet picked up that way. In the international spectrum, even in a campus placement, normally in North America, I'm talking maybe 3 or 4 years back, a post-BS degree from the campus placement, you would range between 75,000 to 100,000 on an average. A master's, a good master's would gain maybe 25% more. No PhD goes less than 150,000 to 200,000. In India, unfortunately, people from an IIT would get maybe 25, 30, 35, or PhD gets only 20. So we are recognizing, it's a society is difficult right now, but I can say running a research academy, my students are getting placed at fairly higher considering the 7 years, 8 years they spent for doing their masters and PhD. Okay. It's an ecosystem change which just is happening. Many companies are taking lead. Earlier they were taking PhDs only for R&D job. Today for marketing they will take a PhD. They will take PhDs even for manufacturing. So just allow the ecosystem to recognize your extra capability you created. That's wait for it.
So what CTA as a research scholar we should take so that like so in your research institute things are happening, like in our research institute maybe things are not happening. So what we can do to actually get us one step closer to that particular thing?
Yeah, please.
Yeah.
For that, we understand, of course. Consider himself actually understanding work. And have to have some problem. Some say some industry.
Yeah.
Okay. Which our industry. And when they think I can come about. So when I sell yourself for cannot go. 10%, but since I'm industry, what is other watching, just like that, save yourself.
Okay. We can take the last question if there is it. Is there any other question? If not,
high pressure field is very crucial. From last 40 to 60 years, we are doing this material research in materials are in extreme pressure and temperature. So in defense organizations like those organizations which are working on these kind of materials, how are how our PhD scholar can equip them so that they can join the defense research organizations, and do we have that kind of facilities like in gas gun or to create such extreme pressure? Do we have the facilities at these kind of organizations?
Yeah, because see,
There essentially. I'm saying seekers and all that. Okay, okay, thank you so much. So we have come to the final stage of this discussion today's, I'll raise only one point, and that will be your like a one-line kind of response to our students. That what is your advice or suggestion to HBNI PhD students and other students who are present there to build career in industry and startups and entrepreneurship? So one-line answer from each of you.
We are a data-rich country, decision intelligence poor country. So when you do research focus on problem solving that can actually help in making effective decision making in the ecosystem.
Thank you. Thank you.
Since you are something as a researcher, grassroots level. So that's an advice from my side that that area itself, and for you to get a job, and wait for the opportunity to get a job for you, which will be suitable for what you're paying so far. That's my advice.
Thank you so much. Yes. Thank you so much. So let me now conclude, and I'd like to tell the students that you might be working in a very narrow domain of research. That is what is the PhD thesis more or less demands. But now choice is manifold. See, many of you can remain so-called within the pure fundamental science or academics. The choice is yours. But if you want to come to join, let us say, to industry as an employer, as an employee, or you can go for your startups or entrepreneurship. The choice is yours. But if you want to do that, then I would suggest that your CV should be little bit reoriented in the sense from pure academic CV, pure research-oriented, publication-oriented CV. From that, you have to go with a specific. Yeah, your CV should speak that you have ability to solve problems. So that kind of CV is required. And you should also have the learning skill, bridge to skill the gaps, what gap you have from your lab to, if you have to move to industry, and you have to earn the team spirit, which was told in the morning, as well as you have to earn the leadership quality. So these are the requirements if you want to go in this domain. So with this, let me tell you that ultimately the world needs you, your ability, where you can apply your knowledge and ability to solve the real life problems. So with this, let me thank all of you for being with us and all the three journalists, because your valuable inputs, it will really help our students to move ahead. Thank you so much.
Thank you, sirs. May I invite Professor Kamachi Mudali to please hand over a token of appreciation. To Dr. S.M. Yusuf, Director, University of Mumbai DAE Center of Excellence in Basic Sciences, and former Director of Physics Group, BARC. Mr. M.S. Unikrishnan, CEO, IITB Monash Research Academy. Dr. Rajkumar Singh, Senior Director, Kalyani Center of Technology and Innovation, Bharat Forge. And Dr. Prashant Pansare, Founder and CEO of Intellement Group. Can we have a group photograph, please? Thank you, sir. Our final session for today's summit is the valedictory session on entrepreneurship and skilling and creating job creators. This closing session will focus on nurturing an entrepreneurial mindset among doctoral researchers, strengthening industry-aligned skilling frameworks, and enabling startup incubation and technology commercialization. Leaders from industry bodies, incubation centers, and the startup ecosystem will share insights on translating research ideas into sustainable and scalable ventures, thereby encouraging research to evolve from job seekers to creators. Please join me in welcoming our speakers for the last session. Dr. R.B. Glover, Member Atomic Energy Commission, Distinguished Professor Emeritus, HBNI, and former Principal Advisor, DAE. Mr. Nilesh Kulbe, Executive Director, Employee Relations and Special Projects, Hindustan Petroleum Corp. Limited. Mr. Bharat Agarwal, Chairman, CII Western Region Task Force on Education and President, Vishwakarma University. And Mr. Avijit Bhattacharya, Co-Chairman, CII Western Region CHRO Forum and CHRO Tata Capital Limited. Thank you all. Dr. Grover, could you take this forward, please?
Thank you. Well, I come again, James. I was there in the session before lunch. I'm happy to see that after lunch, when we are nearing closing, still a large audience is available in the hall. What I said earlier was that
universities have to engage with industry and society. And this said, the last 4 decades, particularly from 1980s onwards, globally scenario has changed. Earlier, academia engaging with industry, many would consider is walking on the dark side. What we have now, beginning from 1980s onwards, first it happened in USA, then it has moved all over, including India. All universities will have something like an office of sponsored research, an office of technology transfer, a patent facilitation center, incubation center, and so on. These were not there if you think of the period before 1980. Universities do allow faculty to engage in consultancy. While all this has happened, value system in universities still revolves around publications and citations thereof. So this is something which has to change. In place of publications and citations, we have to think in terms of products, processes, which can lead to startups, which can lead to skilling of manpower, and so on. Another issue which is particularly for India is collaboration with foreign universities valued. And this has to change with collaborations within India. I recall an incident, I think it was 2006 or 2007. I was in University of Pune for an event and was coming back and traveling with the then Deputy Director of IIT Bombay. He informed me about various collaborations IIT Bombay has with foreign universities. I asked a question, how many collaborations with Indian universities? He said 0. Then I told him, let us start with the collaboration between HBNI and IIT. That was the first MOU with HBNI signed with IIT Bombay. It has been renewed. It has been very valuable. Our students attend courses there. They are co-guides on all this. This is going on. When you collaborate with a foreign university, this is from a friend of mine working with IIT Delhi. I was discussing with him maybe 10 years or 15 years back. He said all these MOUs are poaching MOUs. They want to poach Indian talent and they get employment in their country. So answer going forward is collaborations within India, with Indian university, with Indian industry. Tech transfers can take place and ecosystem will be created for more and more entrepreneurs to set up their own industry in India. It could be research scholars, it could be graduates and postgraduates. I think in this regard, coming from HBNI, I'm happy to say that HBNI is an engaged university, fully engaged with the atomic energy program in India and all the topics which are taken up for research by PhD students, whether they're employees or full students coming from outside, they are something which relate to atomic energy program. What is the result of all this? Something which industry has to learn. Government of India launched solar energy mission maybe 10 years back. It had 2 components. One was to step up solar generation, and industry has done very well in that. There was a second component which has been forgotten. That was to set up industry in India to manufacture modules, to manufacture solar cells. Where are we in this regard? While in nuclear, complete supply chain is in India, in solar we are dependent on imports, and we know from the recent geopolitical developments, people abroad can cut your supply chain anytime. So with this background, I was trying to see what is happening in R&D in India, and I came across a report on the website of Principal Scientific Advisor. It's a 2024 report. They analyze the R&D budget of R&D industry, which are listed companies, and they are listed top 100 companies. There's a table which is included in the report by top 20 companies, and picture is very bad. Tata Motors 22-23, R&D budget 20,265 crores, reasonably well. This is number one. Number two, Reliance 3,000. 20,000. So of 20 companies total which are listed, the total budget is 47,000 crores, half of it with Tata Motors, remaining are 3, 2, 1 and going down very below. So this tells the picture. So point, why I'm saying all this, when we are talking about students as entrepreneur, R&D has to, since this event is organized by CII as co-organizer, they have to give a message to private industry to create an ecosystem in the country which encourages young scholars like this to create their own startups. Unless that happens, nothing is going to move. Another point, yesterday evening I was listening to an interview of economist Surjit Ghala. He said something which was very disappointing, that capital expenditure by public sector in last 10 years had gone up at 5%, while the private sector has gone down by 5%. This is something again disturbing. So how can we expect young scholars to become entrepreneurs when private industry is giving this kind of signal? CII has to do something about it. As a faculty in institutes, we'll definitely try to see that problems which are given to students, try to link with needs of Indian economy, industry, and society, but private industry also has to do its role. Maybe it requires some change in policies. It requires change in regulation. They have to pressurize government to do that also. Then only we can proceed further. My remarks, many of you may find that contrarian, but I thought that contrarian viewpoint also has to be brought out here so that we have a complete picture of what is happening. With this, I go back to my distinguished panel here and request them one by one to share their viewpoint and how exactly we can create an ecosystem in the country such that young scholars have their own startups, or when they join private industry or public sector, they can contribute towards the growth of economy or growth of industry in the country. The first speaker in the list is Mr. Kulbe from HPCL. Please, you can take 10 minutes.
Thank you, sir. Let's start. Sir, so talking that's a side expenditure on the market. Yeah, so in fact, this is census scholars. Subjects and just perspective. Basically, agile website, what are we expressing signature that's all. Let's start. It's going to be. It's a hard just for acceptance by the and That's something which is still for one free. Something which should stable lines from situations and solutions some of us will to give themselves some find jobs and some for graduates. Here, what that's probably the much wide sense of common. This is startup and entrepreneurship. Now, researchers has that is basically because you keep you process something the materials is very much required. Second is analytical whether science state of research, but probably is required. Creativity also creativity is to imagine from existing anatomy. That. Then say that discipline approach. Now this protocol section so that means one section at least 50% which is required. Now what extra is required for searching? And first is that understanding the needs of the since second complex solution have to be simple thing. The third is important. And this is I don't So that is required. And then what I wanted to do that funding for this company. Where are the influences are going, which are people. Now, said companies which are such a which he needs to start an enterprise. Now, for the answer, mindset, people said this required. And sir, so for this will be very important. So, first thing is that that exposure and mindset in still at the institution. Institution of the university and so the culture where the students are exposed to this kind of lectures also. Excellent. Kind of background. You can ecosystem itself. See, I'm supporting the student case, supporting the student from accessible. That kind of mindset is students. Accessible, but the other institution have come. And we must have venture capital, according to so then this country, this country, so my views are to other countries. If tight governments have got certain to say, I will come to that. Thank you.
Thank you, Mr. Khan. Thank you, Mr. Koval. Request Mr. Bhattagowd, President of Shukamna University, to say please.
Thanks to CII, thanks to HBNI for hosting this event. Very apt topic because we also spoke that research is confined in institutes, academics, only to publications, citations, patent filings, but it has to go beyond that. There are a lot of examples around the world that we have seen that publications or products have developed from labs. Generally, it is nice because it is the right thing to do. That in labs, even if failure is a data point. In a business environment, if you fail, there is a heavier cost you pay to a failure. And if you are working somewhere, if you fail, there is also a heavy cost over there. But in lab when you are in the environment of experimentation, at that time, whatever you do becomes a learning experience for you, and you will be, in fact, promoted, incentivized to do more mistakes, to collect more data, so that your product is more robust. I run an organization which is into academics, higher education, engineering education being the forte. We have around 20,000 students in engineering education, 10,000 in non-engineering, a lot of PhDs. And when we come across all PhD holders or students who are doing PhD or graduation, that what is the disconnect between them having the domain expertise, the subject knowledge, and not being successful in converting that to a business model. I think the lack of knowledge of money. We are, while doing our PhD, so I'm saying this out of the experience I have from looking at the PhD students at my university. A lot of times, us as students doing our PhDs or even graduation, post-graduation, are in love with our product. We have to also understand whether others will love our product. And who are these others? The others are, first and foremost, you should have customers. A bit deep after customers may need it, will customers pay for it? I may need something only if it is given to me free. I will not buy it. So you have to understand the small complexity between the willingness to pay, which is an economic theory. Will employees join you in your team for that business? Will vendors support you in your business by supplying material or supplying any technology to you? And importantly, as sir mentioned, will funders, will people with the finance industry fund you for that business idea? The knowledge of money is something that I think is somewhat disconnected between PhD work, project work, and what actually happens outside. So this knowledge of money has to be built in, learned, and I think it has to be self-learned. You can attend courses in person on YouTube, but then it has to be self-learned, and it involves a process. Second is business is also about opportunities. I have an example, a story which I'll share. A student of ours, not a PhD student, but he was an undergraduate student with us. Just now we had Mr. Umesh in the previous panel. This student of ours worked in Thermats as a trainee, worked in the installation systems of Thermats abroad for 3-4 years. And later on he found that when you are servicing those systems, the servicing agency is not Thermats, it is someone else. And he found that there is a scarcity of these servicing companies in the market. He applied his entire experience, project knowledge, and created a startup as a service agency for the Thermats boilers and chillers. Very happy, he shares the journey with me every now and then, and he just posted a 1 week back photo to me of him buying the Mercedes car. Now these are all, so this was it rocket science innovation? The answer is obviously no. Was it PhD, deep PhD work? The answer was no. He had an eye to look at where is the opportunity. And he was able to use his experience working with Thermats into a business that made use of that opportunity. So I think these are my opening comments. I have more to add. As the mood goes and as the time goes, we will contribute more. Thank you.
Thank you, Mr. Agarwal. Next, I will request Abhijit Bhattacharya from Tata Capitals to make his opening remarks.
Thank you, Dr. Grover. Very good afternoon to everyone, all the research scholars, the delegates, academicians in the audience. In fact, Mr. Kulbe, Bharat, they have both shared their opinions, and so has Dr. Grover. A quick little background. I have been in the Tata Group for almost 30 years. And I've been involved in setting up 5 companies within the Tata Group. In fact, I've hardly worked in a company which existed before it was set up. So the first was, and out of these 5, didn't survive. They actually collapsed. 1 got bought over, and 2 thrived. In fact, Tata Capital, the company I currently work in, is the company that I had set up way back in 2006 and 7, and it has now thrived and gone into an IPO just last October. So this whole entrepreneur, so I can't call myself an entrepreneur, but I'm an intrapreneur because I never went asking for capital. That is the biggest difference that is there. So now coming back to research scholars, as Mr. Kulbe mentioned, he talked about a few characteristics of research scholars which make them very amenable to the entrepreneurs. But there are, I think all research scholars are here because they're passionate about some subject or the problem they are out to solve. This is not a mandatory course or a mandatory qualification to get a job. This is, a kind of a pursuit of passion. So I'm sure all research scholars here are there to pursue a problem which they are passionate about. Even the problem is not given to you. You figure it out. You do your literature survey, you find out gaps in that and find out where is the gap. So the opportunity sensing. And finally, you solve that problem in a fairly unstructured, uncertain world. And this is exactly the persona of an entrepreneur. It is the risk-taking which differentiates, a successful entrepreneur and a not so successful entrepreneur. So it is you who can test, and you have taken a risk. You have taken a risk by becoming a research scholar, that the problem that was set out to solve will actually solve and convert into a thesis, and will all become, a doctorate probably at the end of anywhere 3 to 5 years. So you have all the characteristics of persona that an entrepreneur requires, and therefore, most PhDs, therefore, the traditional career tracks are go into academia, become a professor, or go under the professor track, go into industry, mainly into R&D. Very few actually go into the direct business. But the entrepreneurship track is a track which I feel PhD should definitely look at. There is a debate whether the entrepreneurial ecosystem in India is conducive for that, and we will probably have a discussion on that. But probably you know that the guys who set up Google were all PhD students. The other part is they didn't complete the PhD, but they were all PhD students at Stanford. Larry Page, Sergey Brin, Craig, all of them. Any deep tech will always used to be started by a PhD student. So the option of becoming an entrepreneur is a very, very rich option. And with entrepreneurship comes job creation. In fact, today, officially, there are some 2.3 lakh startups registered in India. This is official number. I think the unofficial number is around 6 lakhs. These startups today employ less than 1% of the total employed population. It's a very small number. Directly, they employ, I think, 0.4%, so around 22 or 23 lakh people. And indirect means like, the Zepto delivery guy, the Zomato delivery guy, these are indirect employment of startups. That is another 77 lakhs. So less than around 1%. The opportunity, therefore, to create jobs is very high. There is money in the system. There are, if we look at from 2016 onwards, approximately 150 to 160 billion US dollars have been invested in the startup ecosystem in India. In fact, after US and China, India is considered to be the third largest startup ecosystem. At Tata Capital, we run a private equity practice where we fund, we fund startups, but mostly we fund mid-stage companies. So a startup goes through multiple stages as it gets funding. So there are funds available for a good idea backed by a passionate founder. And as I said earlier, you already have those qualities. It is just the step or the risk to be taken to embark on that journey. With that, Dr. Grover.
Yes, thank you. I think we heard views that there should be we should have an eye for an opportunity. Many startups in India cater to quick commerce, to fintech, but we have to move to a situation where we go for deep tech startups, startups in manufacturing, and startups in engineering consultancy. That is a way forward. That is a way which will make us Viksit Bharat. But I think all of us have spoken enough. Now it's already 16:21. So I'd like to invite questions from the students, and feel free to ask any question. This is the last session. And then if further time permits, we'll again just like to add something. Please go ahead.
Yeah, sorry for taking from so this development mindset responsibility of students. It is a possibility. I just want to select a strain. Basically, about developing sector. Let's say, options available like academic comes from that mindset, and then some opportunity which I have also noted, sensing the opportunity that very important. Next time, the chancellor script, there is a book inside that. I was flipping through certain pages. This one of the so. So I checked it, sorry, sir. Now this Alfonso is expected to I think in that book.
After that, so, and the experience was, but the experience is true. Yeah, that's a product. That's a very question is much cheaper and bulk is much more. Question to certain researchers to work itself and then we achieve maximum. So that is the sense of opportunity. And that is output. Yesterday, the Prime Minister with the Commission question. When actually, all this plastic, this is so just in the to just go back to researcher or somebody researcher can sir, I thought
Yes, yes, so they're very good. Thank you. Yeah, I think, yeah. Yes?
Yeah, see, I understand, most of you understand. See, the various product outside synthetic gas, sorry, LPG, petrol, and all. So what that is naphtha, actually naphtha is from stock for petrochemical. So what petrochemical. There is opportunity which is available to us as a research scholar and the industrialist also.
Yes,
that I want to say.
The question here is, go ahead. How to get funds for research? Oh. To get funds for research. Yes, for all these agencies need you to be a faculty member in an institute before you can apply for research. The prerequisite is get a job with a university if you want to get research, or in an R&D lab of an industry. It should be registered R&D lab, registered with GSIR. Then government agencies will give you funding for research. So that is the first time when you apply, but enough research funding is available from government agencies at the moment. Okay.
But funding for research is usually through an institution.
Through an institution.
So either institution is an academic institution, or it is a commercial institution like a company which has a R&D budget. So at the individual level, getting funding for research is, at least I have not heard of it.
It's not just not. I don't think there's any mechanism for that.
So I'm not I'm not an expert, but then I would ask you to just go through that.
Yes.
There are certain schemes over there.
Under that, if there is a scheme, but that is again like a venture capital. Then
yeah, I'm not really expert in that. That's why I'm not able to tell much about that.
Okay,
you can explain that.
Just sorry, there are also.
You want to say something? Yes, yes. He wants to say something about Atal Incubation Center.
What they have got possibilities of funding to a person job also. You have to come up with an idea and it will be funded. Amount of money, but sufficient enough to carry forward an idea.
In fact, on the same line, there are incubation centers. For example, IIT Bombay has signed, even WARC has an incubation center.
So, I am a startup founder and I've already got the startup funds.
Okay.
The criteria here is this firm has to be a startup, but I'm also a student. And that's like stopping me from conducting my PhD.
Yeah, the funding is for the start.
Funding is for the start. Okay, fine. Any other question? Or everybody wants to? Yes, please.
So
my question is for Bharat sir and Avjeet sir. So basically, as an MTech student, we are often biased towards our ideas and the prototype we make. We are confident it will work and all. But when we do surveys and get some intuition that this might not be a good, business model. Like as you mentioned in the talk, like finance is something. But how we actually quantify it, how we justify it with data so that we are unbiased and we make a right call. Uh, it's difficult to be towards a product, but it is required. Because as an entrepreneur, as a PhD student, as a master student, I meet you outside and you develop something and you feel emotionally attached to it. और तुमसे feel होता है कि ये दुनिया का problem solve करने वाला है. Whatever that product or service would be. Understand that for it to scale up, you require money. And I will not repeat my topic about money over here, but empathy, we all say, is important. Empathy is not limited to only understanding what the other person would feel and therefore solving that problem of his. Empathy should also be extrapolated to what the other would pay for. I'll give you an example. There is a friend of mine who has launched a company in elder care. Elder care is an issue, and parents are aging. Children of these parents are in the US. So this disconnect is there. After launching the company, he understood that while everyone knows elder care is a challenge, still it's maybe sad, but the people are not ready to pay for it. So empathy should not be only about the solution, but whether people will pay for the solution. उसके लिए तो यार थोड़ा भागदौड़ मेहनत करना पड़ेगा. You have to move around to actually judge whether people will pay, what people will pay for. If it is need based, it will be more need based चीजों के लिए आप पे कर ही देते हो. Luxury या फिर जो फ्री में मिलता है उसके लिए पे नहीं करते हो. Means you will not negotiate for medicines. But something of that sort you have to apply your mind.
In fact, we are funding startups. So let me just give you a little idea of how the funding cycle works in a startup. So any startup usually starts with an idea. In fact, I'll take a minute to come back to this. Just on your, most entrepreneurs start with a technology or with a problem that they're solving and they're falling in love with. And they make a product out of it. And then start looking for a customer. That is not the right way of starting a business, as I think Bharat is also mentioning. In fact, there's a management thinker, Peter Drucker, who said, business is the creation of a customer. So it is first, you have to figure out who the customer is, what that customer needs, and can your technology solve something for that customer? Then you have a business in place. So as they say, either you reduce a pain or you create a gain for the customer. If you do either of the two, the chances that the customer will pay you for it is high, which Bharat is talking about. Only then they start working with that technology and created what they call the minimum viable product. So this MVP. So in the initial part, the funding is entirely based on friends and family. I mean, either it is your money or parents' money, uncle's money, someone's money has to be there. Because you will not get, institutional money. As soon as it develops and your idea fructifies, you get what are called angel investors. Angel investors are people you may not know, but they are people who have been, traversed their journey, they understand entrepreneurship, they have made their money, and they're happy to invest in promising ventures. You usually build what is called a minimum viable product. Means it is the basic prototype of whatever you're trying to do, whether it's a website, whether it is a physical product, whatever it is. With that, one goes to now institutions called venture capitalists, VCs. In fact, one of my friends runs Dream Capital, which is a big VC in India. They will look at many of these and figure out whether this has promise. more than promise, they will look at the founders. Are they convinced about the technology? If there is passion, there is a foresight, then the VC comes and does the first round of funding. If the product then becomes from a viable product to a product which is now next launched, and there is a market created. So if the customer study has been correct, then there will be offtake of the product. And if the offtake of the product starts happening, then Series A funding comes in, which is from the private equity space. So Series A, as it develops Series B, Series C, and there will come a time the product really becomes a big business and it gets into the public markets through an IPO. So that's the funding cycle. Tata's come in at the Series B. We don't come before that. It is a philosophy. There are people who come at VC. We had a VC fund. That VC fund unfortunately did not do well. We shut the fund because all the ventures we funded, collapsed. As I said, I have worked on ventures within the Tata Group which have not survived. So there is a mortality rate of ventures. But that doesn't mean that you give up. And that is what Mr. Kundu was saying. Resilience is a very important quality of an entrepreneur. If you see something not working, you pivot, you move into something else. So these are parts of, and these are personality traits which you already have. So ma'am, coming back to you, Tatas do fund, but they fund at a different stage. So the market has different kind of funding agencies. We just don't play in that space.
I think there's a question at the middle here. Please go ahead.
Good evening, panel. My question is, specifically the discussion was about the risk-taking capability.
What capabilities?
Risk-taking capability of a startup founder. Generally, what happens is by that time, a PhD student reaches the age of getting his PhD completed, the capability to take risk is kind of on the lower end. Like he do not have time to experiment. There's family pressure and other things. Versus if we go for the undergraduate students, they don't have the exposure to go for the deep tech thing and all those things. So there's two aspects of something like in the undergrad students, like I'm from an incubation center. The undergrad students come with the ideas which are more social media hype. Whereas the PhD students are there, but they don't have the appetite to take risks anymore. Like they are searching for the first job they get. So how to balance this and so that the sweet spot where the people have the right exposure and they can go for a deep tech startup. Like how to manage.
Question. Will you take it up? Sure, I'll attempt. So, risk taking doesn't have an age. In fact, this typical image of a startup founder doing a hoodie, college dropout, 22-year-old, is there, but it is mostly not there. In fact, I don't know if you know the story of Meta. Zuckerberg, what did he develop? He developed a website, which was a social media website. It was going nowhere. Do you know who really built Meta? There's the Sheryl Sandberg, who came from Google, who had set up the AdWord business in Google. She came here when she was 36 years old. She didn't come as a 22-year-old. And she is the person who actually built Meta to what it is today, Facebook earlier. So please don't underthink that risk-taking has an age. Risk-taking doesn't have an age. I had the fortune of working closely with Mr. Tata. We have seen the kind of risk he could take when he was 60 years old. It doesn't have an age.
So one thing I want to say. Yeah. Go ahead. Thank you. Suppose after doing PhD, I'm not going for a PDF or an academic thing, and I give my 5 years to a startup that eventually got failed. Now my doors for the academic role have almost closed. So the it has a double, triple for me because my core path has just been closed.
Risk by very nature has a
innovative, but coming into academics, what is your innovation, what product you can make? This kind of stuff. So most of the Chinese money products are making articles that are still I feel present generations are definitely people talk about the latest technologies like digital twin, Industry 4.0, that is wireless technology, Internet of Things. So these are all along with definitely getting into research industry more progressive since 3 to 4 years. And they are going to stay for at least 3 to 4 years. So that is the reason startups are gaining more importance, right? But according to investment point of view, investing, stabilizing in the market, at least say 4 years trying to sustain into the market. So what about the sustainability point of view? Students just into market and data pressures taking a challenge to become an what is the sustainability even though they make a good product have very important primary funding like secondary funding for people like that. So what would be the sustainability? Where they think many startups
I think, I think if you're asking that whether the investors will stay invested in for a long period of time,
what I mean to say, in India, you have invested in very startups, right? Where they are failing.
it is the, no, it is mismatch of product and market. Most, as I said, bring a product because they think it will sell. What I think will sell may not sell because there is no customer for it. That is the reason for failure of most startups. Some startups fail because they cannot get the capital. Those are not too many. If there is a good product where there is a customer, money flows. Money has this innate ability to find out where the returns will come from. And it will go there. That is what the entire financial industry is looking for. Of course, if you are in the startup space to create a viable business means that you are generating returns for people who have invested in it. Simple. That should be very clear in the mind. You are not there for charity. You are not there for exhibiting your technical expertise. You are there to be commercially viable. If you are not viable, you will die. Simple. I think we'll take this conversation outside, ma'am. I think
outside. Maybe it's time for us to stop here. And I thank HBNI and CII for organizing this event. Happy to see a lot of you here. Thank you to fellow panelists.
Thank you, sir.
Thank you, sir. Yes. Since we already have Mr. Bharat Agarwal on stage, can I request to please hand over and Mr. Mudali, Professor Mudali.
I saw him, so it is his. Here it is, please.
Yes. To Mr. Nilesh Kurve, Executive Director, Employee Relations and Special Projects, Hindustan Petroleum Corp Limited. And Mr. Avijit Bhattacharya, Co-Chairman, CII Western Region, CHRO Forum, and CHRO Tata Capital Limited. One more?
No. Don't be one more.
So second. For our final closing remarks for today's summit, for our final remarks for today's for our summit today, may I invite Professor A.K. Tyagi, Dean and Senior Professor, Homi Bhabha National Institute, to please join us.
My greetings to distinguished colleagues from HBNI, guests from CII, all respected moderators, esteemed panelists, invitees, and the most important stakeholder, that is young students. I want to agree that today we witnessed in two sense a unique program, Research Scholar Summit on Employment, Entrepreneurship, and Startup Opportunities. Programs in chemistry, physics, life sciences, but this was encompassing all the disciplines and from a different perspective altogether, that is entrepreneurship and startup. I want to sum up the program and the proceedings and move forward. So I have two segments in the time given to me. First is, of course, summing up. We had another session, and as it is said, the another session is an event which momentum conference, and today's session also is no exception. We have tremendous momentum. Mr. Bharat who talked about vibrant startup system, and he emphasized to change the mindset from papers to products. Time has come, we have to think blood applications. Disruptive discoveries, he gave several examples. Collaboration with different stakeholders, one of them is from Sidney Agarwal. Around the Vice Chancellor, Professor Bukawachil, I may tell all of you this meeting is his brainchild. So thank you very much for pushing this hard to realize this wonderful program. He discussed the basis of this summit, he emphasized on history of Dr. Bhabha, and he also shared HBNI's journey and achievements. His theme address was followed by a special address by Dr. Martin, mentioned that there is a gap between research and commercialization. And he promised how AICs, we have 4 AICs out now in can see this gap. He mentioned about BSc technologies, incubation options, and encourage students to have more interaction with AICs. Another special address was given by Ms. Aarti, where she talked about the high levels of theme of the summit. And she mentioned very rightly when students will be think academic qualifications. Academic qualifications get you at some level, but of course you have many more abilities. Successful parents also emphasize on this part. And think of conventional way was another message given by Sarthi on how to translate knowledge into innovation and innovation into impact and impact into economics. The lessons given by Sarthi. Chief President he discussed about his own fascination about science. I was not knowing that science student, and he emphasized on transformative research, development of products, industry collaboration, mission. He emphasized, he explained to us how Maharashtra is so well placed in this mission of government of India. He discussed the idea of Maharashtra, several industrial townships are going to be set up, and Maharashtra has emerged as a startup capital. We have 5 sessions, very big summarize all 5 of them. Session one was on chemical sciences, careers in sustainable and advanced industries. Pharmaceutical was the moderator of the session. The first speaker was Dr. Richard. He discussed about chemical sciences and circular economy, and how green chemistry is going to take us forward. There is a nice example of obtaining silica from rice husk. I may add here, silica can be obtained from many sources. Rice husk can give you silicon carbide also. In the market, high-end materials for space, defense, and human applications. So waste from wealth was something we discussed. And how to go from high volume to high value products. This is something very important. Volume is important, of course, but can be very also. This is something which you mentioned. And key skill students need to have for relevant for next 4 decades or so. It's extremely important. That's what we emphasize. Second base was Dr. Arvind Saxena. He discussed about chemical industry. Career decisions by students are very crucial. And your journey should be based on your strength. Here, my own vision also, all of us have some strength and all of us have some weaknesses also. We should know how to set the stop. Please, sir. This one for us. All of us have that strength, but we have some weaknesses also. So when time has come that we should transform our weaknesses to strength. Something which definitely I can share based on my experience also. And your passion is going to be paramount. Another important point mentioned by Mr. Saxena. Dr. Ravi mentioned about pharmaceutical industry. Again, we discussed about high value skill of chemistry student and the importance of fundamental science in organic chemistry is something which you discussed. Point was Mr. Arun Bhalu to discuss about, of course, in fertilizers, petrochemicals, and mining. Coal gasification is very important here. We have to think of non-conventional source of hydrocarbons, and that's where can we get hydrocarbons from or other waste products. Here, DRC plasma-based technologies. Highly rich, 75 to 85% of methane. And second session was on planning the future workforce. This also was modeled by other eminent scientists from the Department of Professor R.B. Goyal, Commission, and recipient of Padma Award. He emphasized that universities need to engage with the industry, and same thing, of course, mentioned in fifth session also. And problems. This is something very important which you all agree with, sir. Here we had Dr. Nandkumar was first panelist to discuss about students and faculty members. This is a question posed by Gupta, sir. And he discussed about 4 components of sustainability, 70, and need to technology and equipment. Can we make instruments and equipments which can have better efficiency of heat transfer and mass transfer? If we can see the cost effectiveness is going to be tremendously improved. Second analyst was Dr. Radha Ganesh. She emphasized on indigenous technology. She had very strongly, and industry's investment in R&D also she touched upon. And the biggest message to all the students, which she mentioned, was that now time has come that we move from mindset of frugal innovation thinking. It means something that you can become successful entrepreneur. When I'm asking this question, you will be products. And that's where comes the R&D strategy management. One has to take conditions if one has to startup, successful startup and entrepreneur. And how you all are going to help for future. See ready for future. To be precise. And don't say we successfully mentioned in different sessions. We ourselves also have changed our field every 5 years, every 5 to 6 years we change our field. That's why we acquire this kind of wide knowledge base and contribute to the governmental mandate. Third session was on medical health and life sciences, expanding horizons in healthcare and career. Another eminent person from the Department of Agriculture, Dr. Sudhir Gupta, Director of PhD, was a moderator. And in his own experience of close to 4 decades, He discussed how medical profession has evolved over the years. Childhood, the doctor used to see the labs, and then used to think, swine, like his face, but he discussed that how just by seeing the labs of money, whatever you call, it's highly instrumental diagnosis. And in this, there were three panelists, Dr. Ramakant Deshpande, very, very senior cancer surgeon. He discussed about 4 types of health, namely physical, mental, social, and spiritual. And physical health has been a long way. Healthcare, medical professionals are of course there. But we emphasize that many non-medical health care specialists are also required for physics, chemistry, and life science, data science, and so on. So you can see the kind of opportunities which are awaiting for you. He discussed about importance of interaction. Very important. Should learn of interaction, but across all types of people. Very important. You should also be able to interact with people considered as critics or enemies, whatever. You should be an open person in science. Mr. Bharat discussed about importance of basic research, only chemistry and bench also, and he said something rightfully should listen to your heart. What your heart says, you must do that. All of the become a successful entrepreneur. Looking at whether we could better ask his questions, was what I thought I also will do some of the inputs. And he mentioned that we need to have breadth of knowledge, but we also need to at the same time depth of knowledge. And he used what shape of knowledge. That's something which definitely we should practice. And third place was Dr. Sheba Saida. She mentioned about evidence-based practice and practice-based evidence in medical science. Something very interesting. Psychiatric perspective of healthcare was amply covered by her. And of course, she also shared the art of knowledge. We should share of knowledge should not be in should personal advice, don't be too secretive while working in scientific field. Very important. We must be open. Fourth session was on physics and mathematics foundations for high impact careers. A very old mind from one of the Dr. Hassan Yusuf, we have been together in the department, and he conducted a session in which, of course, his opening remark in nature in high impact and mathematics and data science, structural problem solving, and etc. A lot of examples many of the students and many seniors also embarked on this. This session comprised of very like other sessions also. The first panelist was Dr. Prashant Pansari. He discussed about how physics and mathematics are going to the language of writing algorithms for artificial intelligence, drone technology, image processing, and so on. He talks about and physics and data science applications. Computational skills are something which very heavily emphasized. I want the students got benefit of vast experience of all these panelists. Second panelist was Mr. Uli Krishnan. Since he was left, I was very impressed myself when we connected science with politics. I was wondering how science and politics can be connected. So we connected science with politics via technology, via commerce, via economics, and with economics of the picture. Very nice. I would like to thank Akshay. He gave a lot of examples of quantum computing, quantum materials, quantum mass, materials and mass, expanding beyond physics and mass. You have to think beyond physics, mass, and chemistry, and life science, etc. One panelist was Dr. Rajkumar Singh from Kalyani Center of Technology Innovation Health Coach. He discussed about science and technology relation. And I may here add a bit of time also that there are enough examples I can go on talking where science has driven the technology and technology has driven the science. So let us not enter into this argument because one can give a lot of arguments. And of course, he discussed about physics-based startup. Give one example of ultrasound-based non-destructive testing. So this kind of testings, and some other examples are artillery, how to balance it, and so on. So this session was on physics and mathematics, and a lot of insights to young students, and for the and frankly, all the benefit of the sessions. Last session just concluded, so I won't spend less time. This was again very ably conducted by Professor R. And again, re-emphasized that collaboration within India is very important. He rightly said that we take pride in collaborating with so many institutes abroad. I myself have taken this pride. But now it's very important that institutes and universities within India also. Session comprised of Mr. Nilesh could be entrepreneurship mindset among students, resilience, analytical brilliance, creativity, are the five important attributes which an entrepreneur should have. Thank you for solve all these improving. Mr. Bhuvan is sitting here, of course, he talked about failure. I may add again here that failure analysis of individuals as well as the products is very important for moving forward in successful direction. Self-learning, this also is absolutely correct. Many of us sit in the front row to practice this for last many years. And third place was Dr. Avijit Bhattacharya sitting here in the front row. He was very correct to say that passion about research problem is very important. Risk-taking and entrepreneurship go hand in hand. And you also pointed out in response to that question that risk-taking and failure also are two sides of same coin. I will put it this one words. Thank you for sharing your views regarding this. And risk-taking is something I fully agree. So with this, my first part of the series, I gave summary of all the 5 sessions and of course, in every session also. Now let's go forward. Here such sections. One is for HBNI. Vice Chancellor, myself, and other colleagues represent HBNI. What is the way forward for HBNI? Well, after this great success, student definitely organizing a very complete for research scholars. So we're trying to do this meeting work out by the and our main focus will be on the leadership. Academic leadership collaboration is something that definitely can act as an interface. And show what times we do and then the students this something which you can do. And we also are going to plan special courses on entrepreneurship, startup ecosystem, etc. We have right people on board, and many people got into this today. So please be assured that we are also going to conduct several of such programs. And another area you can visit the website of TTC that has been displayed as mentioned by Dr. Baldwin. These methods can be classified into 3 categories: high investment, medium investment, and low investment. People like you, investment, medium investment definitely recommend investment to 30 to 45 also. High investment when time comes, you can get that also. Second part of part of speech is for future scholars. So there are 4 crossroads. When I grew up, there was one crossroad. Say that way. But now we got 4 crossroads when students. I have myself close to 50 students, so I can tell from their perspective also. One is that whether should you become employee or employer? I would say we become employer. Have been employer. Should become employer. And why not? To make employer as also. Absolutely no issue. Second also, this paper or safe player. Should be taker. Safe player was our generation and generation before me. Mittal sir, Gover sir, and other sitting. Safe players. What nation expects from state capabilities. What is academic industry? I would say industry. If you jobs anywhere there, but industry job are going to increase in coming decades. So we have eye for industry job. And fourth crossroad which our nation almost don't have. And I belong to 1985 by honesty. In India, abroad, corruption. Options. Correct. The for Indian option job prospects, service, opportunities, funding, everything in India is now better than some people can think of. Second is that how to make right choice of career. Again, a lot of things were said by distinguished pedagogists in all the 5 sessions. But you have to go for career passion-wise. If you enjoy the work, what is a pleasure then? Even pleasure is a pleasure. So you should listen to your heart, as one of the pedagogists said. And my own experience, I can share with you in the last 20 decades. Be a learner entire life. Till your last breath, you should be a learner. And please remember that no shortcuts to success. There are people who are extremely successful people studying in first year and second year. Check with them, they will tell you. They all have slog very hard. No shortcut to success. There is one thing for students. And irrespective of discipline, which produce chemistry, life science, medical science, mathematics, discuss number of disciplines today. Opportunities are in plenty. It's up to you how to grab the opportunities. Opportunities were always there. Okay? So only some people have to get the right opportunity at the right time. So you must inculcate this kind of thing also. And tremendous support from government of India, from industries, from the parents. Everything is going well. So you must make big use of this, where policies will support innovation champion. And at last, I must share with you my own perspective, of course. India is a country of 1.4 billion population. And I'm sure you all know, at least 800 million people are having lots of problems. And remaining people can afford higher fertilizers. So what I say always is, India specific problem and India specific solution. India specific problem solution will not come from abroad. It has to come from us only. And for that, this students program, I'm sure, has motivated you to pick up the challenging problems, the high-end problems for Department of Atomic Energy, Space, Defense, and so on, industries. And I will not say no problems, I will say social problems. They are not to be subject, they are definitely problems. Problem for society at large also need to be addressed, which is good satisfaction. With this, I will conclude by saying that top management in and of course in government is very supportive if you venture into entrepreneurship and startup. I can assure you, bright future is available for you. Thank you very much.
Thank you so much, sir, for summing that entire summit up. To officially close for today, may I request Professor Kamachi Mudali to finally deliver the presentation. Professor A.K.
You're getting your own book. So, Minister is saying I'm getting my own book. Thank you.
So, would you like to close or should I close?
Distinguished and research scholars and HBNI and CII colleagues, I'm going just to conclude for just 2 minutes. As it was mentioned by Professor Tyagi, that we want to consider this as a sample program with CII, but we would like to take it to grow in the Western region. We can do similar one-day program, maybe in Pune, we can do it in Nasik and different locations, joining hands with other academic institutions in those areas. This is very important. So this can spread to all the PhD students and research scholars through the Western region to start with. And we also felt that since our domain HBNI students are present in 14 institutions. We will try CII to have a DCI conclave for the research scholars, where all the research scholars can come and we can have an interactive system like this with industry professionals. This is what we want to take forward, and I seek the cooperation from CII Western Region. I hope Prasad will agree with me for this proposal. We have already discussed this, and I think this is where we can provide a platform for various stakeholders like academia, research, industry, research scholars. They all coming together in one place and discussing this. It will create a lot of opportunities, entrepreneurship opportunities, skill up opportunities, and also they will get some motivation, some way forward they will look into. So this is the conclusion that I feel that what we started today should grow further and it should benefit the young research scholars and the nation at large. Thank you so much for all of you joining, and please join for IT, and we would like to look forward to the next conclave that we will conduct. Thank you.